If you've clicked on this video, then you're in for a treat, because if you stick it out to the end, you'll have a complete 2D Asteroids game that you can launch on your desktop and show off to your friends and family. Not only that, but we're going to approach the process in a way that sets you up for success. We're going to start from an empty Unity project and gradually learn the software and the skills required to develop all kinds of things on your own. My name is Matt, and I'm a professional game developer with over a decade of industry experience, working on everything from solo projects to AAA teams. On this channel, I focus on helping developers build smarter, more scalable systems for their games, as well as the reasoning behind using them. So whether you're a beginner looking for a crash course in game development, an intermediate looking to pick up a couple of new tricks, or perhaps you're just game dev curious, you're in good hands. Over the course of this video, you're going to see what it's like to develop a game in Unity from scratch, and I'll explain as much as I can and try to make each step as easy to digest as possible by covering both the how and the why. Along the way, we'll tweak things, make mistakes, and fix them, because that's how game development really works, and it's important to know how to solve problems you might run into. Now, I know that Unity is a huge engine, and getting started in it can be a bit overwhelming, so I've picked this Asteroids game as a starting point for you because conceptually, it's quite a simple game, but I think it allows us to explore a lot of the critical components that you might need to know about when making your own game from scratch. And as you'll see throughout the video, it allows us to lean into some concepts that are more advanced for you that you'll definitely need to know about in order to continue on your journey. It's also an excellent foundation for you to continue building upon once this video is over, and so at the end, I'll give you some ways in which you might want to continue doing just that. If you want to follow along, you can grab the assets for this project in the link down below. You're about to start building your own games in Unity, and there's a lot to learn. So let's begin. Okay, so first things first, you're going to want to go over to unity.com and grab the Unity Hub. So to do this, you just head here and you should find this button called Download. Click that and choose Download for Windows. Also download for Mac or Linux if you're on there, but I'm working in Windows, so this is all going to be mostly Windows focused. And this will start the download for the Unity Hub. You might have to create an account once you open Unity Hub, but once you get that all set up, log in, and you should end up with a screen that looks a little bit like this. So you want to head over to Installs and hit Install Editor. This will give you a list of different versions of Unity. Basically, they release incremental updates with a bunch of bug fixes and patches. So as long as the number here in the middle is the same, you should be fine. You don't need to worry too much about having the exact same incremental version. You know, this one here is 6000.0.67, but basically the long form version of this is 6.3. So as long as you're on 6.3 for this, you should be fine. If you're watching this in the future, this is the version we're going to be working on, is 6.3.7. If you do want to grab that, there are actually other versions. You can go into the archive and find it by clicking Download Archive. But as long as you're in a 6.3 version for this video, you should be fine. So you want to head over here and click Install. And then when it asks you, make sure that you install Visual Studio Community as well. I already have it installed, but there should be a little checkbox here, like here, to ask you to install it. If you happen to already have Visual Studio, then you're good. But if you don't, make sure you include that in the install process. So we'll click Install. So with this installed, you want to head over to Projects, and you want to click up here and choose New Project. This will then open the New Project window. I'm actually just going to make this a little bit bigger. You're then going to have a choice of which version of the Unity editor to use. I have multiple versions installed for different projects I've been working on. But you should see the version you've just installed here, which was 6.3.7. And then you should get a list of different templates. There's actually a ton of starter templates to work with. So I do actually recommend opening a few of these on your own, especially some of the learning ones, because they'll get you familiar with a lot of the Unity editor. For this sort of beginner content, don't really need to care too much about any of this stuff. There are two versions of the rendering pipeline that Unity have. They're now starting to unify it. The rendering pipeline is essentially just the way that it processes graphics and stuff on the screen, and they split them off a while back into a sort of lightweight version, which is good for mobile, and then a really heavy version, which was dedicated for console and high-end AAA video games. Unless you really, really know what you're doing, then you might want to go to the high definition pipeline, but generally universal pipeline now is great. So don't worry about it though. Doesn't really matter too much. So you should see three really main options here, which is sort of a base template for universal 2D, a base template for universal 3D, and then as I said, the high definition 3D. Don't need to worry about that one. This tutorial is 2D based. Basically, they're exactly the same thing. They're not that different, so you don't need to worry too much if you pick one accidentally or the other one. It just sort of configures itself for one specific type of visual versus the other, because Unity can kind of do anything. So it's really just trying to help you get started in a game faster, essentially. And once you get stuck into Unity, you can define these yourself, and you can sort of pre-config certain things to be installed over others and then save that as a template to start from next time. For now, I think we're just going to stick with the universal 2D template, and then we just need to pick you should have an organization as you've set an account up. Do not store this on the cloud. Don't waste your time. Make sure to just check this and choose local project, because once you start doing cloud stuff, it integrates with all of Unity's things, and it just bloats the whole experience. So make sure that you've got your project selected down here to create a local project. So pick a location to install the project in, and then just name our project. We're just going to call this 2D Asteroids game. Once you've named your project and picked a location for it, just hit create project and Unity will do its thing and start up. Okay, and welcome to Unity. This is the default layout for the Unity engine. This is what it looks like, and I'm gonna explain each section to you. It is probably quite overwhelming from the get-go, but it's actually really not. There's just sort of dedicated panels for things. It's a super flexible editor with lots and lots of different things that you can pop up and explore. And throughout the process of this video, I'm sure we'll touch on different areas in a little bit more detail, and I'll probably teach you some tips and tricks to make the whole process a little bit more easy as well. So let me just give you a quick overview of what each section is and does, and sort of explore some of what the different buttons do. But you don't need to be too scared. By the end of this video, you will be really familiar with the editor workspace. So the first place probably is down here in the project window. This is basically where all of the things in your project live. It's actually just a one-to-one of your folder directory. So if you go to where you installed your project, you can see there's a bunch of folders here. Everything inside this, as you can see down here, is called the assets folder. And if we look in our directory, we can see that there's an assets folder. So if we double click this, we can now see all of these things that are just sitting here. So we have scenes, we have a settings folder, it's these two. We have a default volume profile.asset. We also have default volume profile.asset.meta. Meta files are basically just a way that Unity figures out where to put things. You don't need to worry about them, but every single thing you put in this folder ends up with a duplicate asset called a meta file. That's all you need to know. And it's just the way that the engine figures out how to do things. But there is essentially a one-to-one between assets and your file structure. So if anything you put in this folder in the directory will show up in the Unity editor. So yeah, in here, we have a few different preset assets. Like I said, we've picked the 2D template. So it's already come with some predefined objects. We'll go into those in a little bit more detail later. There is an asset here called a default volume profile, which is essentially just a bunch of post-processing effects, just filters ultimately that you can turn on and turn off and globally affect your video game. You don't need to worry about that right now, but that's what's there. There's an input system asset. This is relatively new. I say new, it's been in the engine for a while now, but this is the way that essentially it's going to be able to detect input and keyboard shortcuts. We will be going into that a little bit later in this video, because that's how we're going to make things move around. And then you have the render pipeline global settings. This is just the way that the engine is configured ultimately to draw things on screen. And it's really not that interesting or worth caring about. You don't really ever need to touch any of this stuff if you're happy with just the default setup. It's only when you get super advanced that you can dig into it and get into the weeds of doing custom graphics things if you want some special effects to happen in a game that Unity doesn't quite do for you already. So really, you don't need to worry about two of these things, and we're going to go into detail about the actions asset a little bit later. But yeah, that's the project window. So it's just where all of your things live. And it's where some configurations of things live. In the settings folder here, there's some configurations for settings and what looks to be a scene template, which scene templates are just things you can do when you want to make a new scene. You can pick from a scene template. So there's one built in for the 2D URP if you want to make a new scene. Speaking of which, scenes are ultimately a stage for where your game objects are going to live. So that's explored through this window over here, which is the hierarchy window, and sort of viewed through this window over here, which is the scene view. They kind of work hand in hand. Everything in the scene view is shown in hierarchy over here. Think of it really just as sort of folders and a way to kind of identify everything and filter through everything in your game, because some scenes might have tons and tons and tons of assets in them. And so, you know, needing to put things inside of other things and make folders and stuff is a really useful way to sort through it. But we'll get a bit more detail into that again a little later. All it's really doing is allowing you to select different assets in the scene. And then you might be able to see on the right of the screen here, this is the inspector panel. And essentially that's where all of the configuration of your game sort of goes. So we'll go a bit more detail into that, but there's a bunch of scripts that can be on an object. And then this area over here is where you're going to be able to configure these scripts. So this camera object in our scene has a camera, an audio listener, and some universal data script. Don't need to worry about that either. And you can see it has a position in the scene, as does the light, which has a position, rotation, and scale. Everything has a space in 3D that you're working in, and that's all editable and manageable with the vector window. So this is kind of the one-stop shop for where you're going to be making changes to the game and assigning things, and where when you start writing scripts, stuff you want to reference in your scripts will show, so you can then move things from the hierarchy window into those scripts to be able to reference them. As this video continues, you'll start to understand more and more about what this stuff all is and how it all works. But yeah, that's basically the gist of the inspector. So I'm not going to go into too much detail about the scene view and what all these buttons do, because frankly, they're not that important. Ultimately, there's just a bunch of controls around here to change the way that the scene view looks, or the way that you want to interact with the scene view. So there are different tools over here on the left. These are usually the most commonly used ones. You have a little hand tool that moves the scene view around. You have a move tool that shows a little move gizmo when you have an object selected. And that, if you look, as I move this, it updates the position here. So there's actually a few different ways you can interact with things. I could custom set the position to say 0 over here, and this will move this around, or I can move things up and that will move those. And similarly, there's a rotate tool, and I can use the gizmo to rotate something, and you can see it changes over here, or I can just type the thing into the object in the inspector. So already you can see how the different components work with each other. And again, there's just a scale. This one is useful in 2D when you're dealing with sprites. This is the rect tool, because most things only work in a 2D space. So if you've ever used Photoshop, it's just the sort of scale controls, things you're used to seeing. It'll make more sense a little bit later when we start using it. And then transform tool is kind of a combination of all of them. I don't like this tool because it's very confusing and it's too much. I pick the one that I need. And these are actually all keyed to shortcuts on the keyboard. You can press W, E, R, and then I think it's T and Y, and that just switches between all of them. As you can probably see, I'm right-clicking to drag the scene around, and if I scroll, I zoom the scene view camera in and out. But yeah, essentially, this is the place where you're going to be sort of designing and staging scenes. So we'll get very familiar with the scene window moving forward. Now you might notice another little tab up here, and this is the game view. This is actually the view that is going to showcase a preview of the video game when the game is running, and that will happen when you hit play. Right now, there's nothing, so we won't see anything. This is sort of a preview of what the camera can see, and there's actually different settings as well in here to allow you to change the aspect ratio and pick a default aspect. I usually have it preset to a 16:9 because most users are using 16:9 screens. The window will then just kind of scale to whatever you have. So yeah, as I'm sure you can also see, I'm sort of right-clicking and dragging, I'm left-clicking and dragging on windows here, and that allows me to sort of readjust the scene as I like. I quite like having the game view visible sometimes, and so I'll often drag that down here, and then that way I can be designing things and see how it looks. So you might see me doing that throughout this tutorial. If you do start messing around with things and you want to change how the screen lays out, or you're not fond of the original layout, you can actually just pick some of the other presets here. So for instance, this 2x3 or the 4 split, which is more of a sort of artist layout, so you can see the scene from different views. There's a tall layout. You can also customize your own layout. So if I move the game view over here, I can then do that and choose save layout or save layout to file. And I can name this sort of game view preview, create, and then that's now this type of layout. So I can go default and I can switch between sort of different modes depending on maybe the work that I'm doing or the task that I'm doing. So it's very, very valuable. You might be wondering what all of these buttons up here do. Generally, you don't need to worry about them. There are a bunch of shortcut buttons to Unity related things. And like I said, they're linked to cloud stuff. For purposes of this beginner tutorial, you do not need to worry about any of that stuff. It really only comes later when you start wanting to deal with bigger projects, but all you need to know to get started are what these sort of 4 main windows do, 5 if you include the game window, and getting familiar with those will teach you the basics of Unity. So just before we move on, I want to just give you a brief overview of how Unity defines things. And ultimately, the engine is component-based, which means that you can create little modules of code and add them to an object that then Unity will use to hold all of that data, basically, and run a bunch of scripts on. Now, these objects are known as game objects, and they are sort of the base component of how things exist within the Unity scene. So I recommend taking a look at the manual for game objects to get a bit of more of an understanding of what they do if you want to go into more detail about those. But already you've kind of seen those in camera and the 2D light, because under the hood, these are just game objects. The camera isn't like a special thing. It's just a game object with the camera component or script attached. And as you can see, if move to this button over here, you can just add new things, new scripts to a game object to then define what that game object is. And it just happens to be, this is a pre-configured game object with a camera and an audio listener on it. And so if we right click in the hierarchy, we can actually just create an empty game object, or we can create some sort of preset game objects that come with scripts already attached to them. But they are not different things. They're all just objects. So for instance, if we wanted to create our own camera, we could right click, or a second camera, we could just right click and choose camera, and it shows up like this. But that is no different than us right clicking and choose create empty, and then heading over here and choosing camera, right? And now we just have another camera, but they're the same thing. So when you hear me talking about game objects, that's really all I'm talking about, which is just the root sort of folder or container or box, if you want to think of it that way, for a bunch of logic. And so when we name things, we're really just organizing our game objects into rules around this is the thing that you're designed to do. And it's just kind of a way to simplify the game design process and the game development process by giving little components their own set of logic. Right, so with the basics out of the way, I think the best thing to do is just learn by doing. So why don't we just get started putting our scene together and making things happen. I have a simple background here that we're going to use, and also a ship that we can use to fly around with. And you can obviously use your own assets if you want to do your own designs in Photoshop or Illustrator or something. By all means, go ahead. But I'll also provide a link to all of these images over on my Patreon. So feel free to head over to patreon.com/gamedevguide if you want to grab these yourself for the project. And you can just download those in a zip file. Just quickly, I'll show you how to get stuff into your game from your image editing software. So we're going to just export this. We'll do a quick export as PNG, and then we'll head to our project and we'll choose assets. And then in here, we'll create a new folder, which I'm going to call sprites. And I'm going to name this one space background. That will then export. And as you can see in Unity, we now have a new folder called sprites, and our space background has imported. So it's really just as simple as putting your objects into a folder. If you wanted to make the folder here, you can just do create folder and name a folder yourself. And then you could click show in Explorer. So if you've downloaded them, and show the assets here, double click this, and then just drag the files in here. As you can see, I've exported my ship here. So if I just open the sprites, drag this ship into here, it will copy the asset. And now if I go into Unity, should have a little ship sprite. So there you go. That's basically the gist of how you get images into Unity. Next then, you want to make sure that these are configured correctly. Unity doesn't kind of know what you want to do with images, because there's a lot of things you can do with images in Unity, and there's different ways that images can be interpreted by the engine. And so we need to tell Unity that these are sprites and we want to use them for our 2D game. In the 2D template, it kind of already assumes a lot of that for you. But if you see here, there's a drop down called texture type, and there's a lot of different types of textures you can use. We're not going to get into anything other than these 2D and UI for now. So just make sure that Unity has that selected and change the sprite mode from multiple to single. You can have multiple selected if you're importing a sprite sheet, which is basically just a big texture with lots of different versions, like a flip book, essentially, that you'll be able to rotate through, or different images that you want to use. It's more memory efficient to have a big texture with lots of different images on that you can then kind of cut out in the engine. So that's what the multiple section is used for. But for now, just make sure that this is set to single and click apply. There are some other settings here that you might care about. For instance, if your image is coming in and don't have an alpha channel, this just looks white to you. For instance, if I turn this off, you'll see if it looks a little bit like this, just make sure that alpha is transparency is selected and that the alpha source is set to input texture alpha, and then hit apply. And that way it just tells Unity that, yeah, I want you to pay attention to the alpha channel, keeping in mind that images are just made up of 4 channels, which is the red, green, blue pixels, and then the alpha channel. And so that's it. That's basically the gist of getting images into Unity and getting sprites ready to go. So then the first thing we might want to do when we start is just make this background a little bit more interesting, so we have a nice stage to start from. In a 3D game, you'd use something called a skybox. I've actually got a tutorial on how to make those down below. Feel free to watch that if you are interested in that. Skyboxes can be used in 2D games, but it's very rare. So a lot of times 2D games will just have a background, and then there'll be a few layers in the foreground, or midground, I should say, that move separate to the background, and that creates this form of parallaxing, which is the immersion, like the illusion of there being depth in the scene. But for now, let's just get our space background in. So in this instance, all we actually have to do to create a sprite game object is drag the image into our hierarchy here. And as you can see, our game view now is showing our background, though it's pretty aggressively zoomed in. So one of the things that we can do is if we head over into our scene view here, we can see that the camera is very much cropped into our game. If I bring up the game view side by side, you can see that as we move the camera around, we've really kind of cropped in. I would prefer the camera to be a bit more zoomed out. So what we can do is click on our camera over here and change the size, something that better fits background. So probably about 10. And now if we look, it's a much better fit. And let's set this to 16:9 again. There we go. Now, one of the things I actually want to do, if you can see here, we've got a bit of banding going on, and that's ultimately due to the compression being set on our image, because we don't want to be shipping games with all of our images, especially if they're huge ones, but full detail. Some images we can get away with compressing slightly because maybe they're a bit further in the background, or we don't care too much about their filtering. So Unity will often try to do things to make images the most, to use the smallest amount of memory as possible. So for our background though, we kind of want that to be really high quality, especially for a lot of this game. So we're going to change the way that Unity interprets our images. So if we click on our space background here, we're going to change the compression to high quality and apply. And then as you can see, that banding goes away. And we'll do the same with our ship. Okay, so we now have our background in the scene. As you can see, this is a new game object that exists, and it has a sprite renderer attached, which is just a component that says, hey, I want you to draw this as an image. Ultimately, behind the hood, if we take a look here in our shaded wireframe draw mode, we can switch Unity into different draw modes to see things. The default one is shaded draw mode, where lighting is calculated and part of the scene view. You can go to unlit, where lighting doesn't play into it. A shaded wireframe draw mode, or just a standard wireframe. And as you can see here, if I actually unclick the 2D, we go into 3D space. I'm just right clicking and pressing WASD here to move around. I can sort of fly around the scene in 3D space, and all a sprite is a little rectangle, which I'm sure if you know a little bit about graphics, everything in video games is just triangles. And so to draw a sprite, you just have an image textured to a pair of triangles like this, ultimately. And so that's really all the sprite render is saying, is like, hey, draw a thing on the screen in this rectangle with this image attached. So if I click on here, it's ultimately like, if you think about like a big billboard, that's kind of what this is doing. Is it's a big poster that's popped in the scene. But when you're in 2D mode, you don't know any different because it's just like a background image. So that's ultimately what sprites are and how Unity interprets them. And if you know that, there's a lot of things you can do with how they're being drawn or where they're placed, etc. And so again, like I said about the parallaxing situation, Unity is a 3D engine that it kind of is fake 2D, right? So there's a lot of work going on in the background to pretend like your game is a 2D thing, but actually all it's doing is just drawing everything in the same place. So you can do 3D things in your 2D game to add elements of depth, which again, we'll do a little bit later. I'm just kind of prefacing you here. Don't worry about it too much, but just letting you know that that's something that is possible, and that's kind of how Unity interprets your scene, because we can actually click this space background sprite, which is positioned at 0 in the scene, and we can actually move it further back and forward. Generally, the camera won't care about that because it's set to orthographic, which orthographic projection just makes everything basically set to field of view to 0, which is sort of the cone at which it sees things, and it brings that cone in so that everything is being drawn. Feel free to look up the difference between orthographic and perspective projection. You can change that setting in the camera settings, but ultimately we're just telling it sort of what the window of that projection can be, and that's why the size setting matters. And for 2D games, you often want an orthographic one, or you want a perspective camera set to a very, very, very small FOV. But as you can see here, we have clipping planes, so we can actually determine where our camera draws things. So as I bring this forward and I bring the clipping plane forward, you can see that now the near plane, which is just what's the thing closest to me before I stop drawing, you can set the near plane, or you can set the clipping plane down. And if I bring this all the way down, so I'm just clicking on the word here and I'm dragging, and that actually allows you to manipulate fields here in the inspector. You can just, if you mouse over the property, I can bring the far plane down. And if I set it lower than 15, I believe this is probably at something like 6. Okay, so if I set this to 5, our camera is minus 10 back, plus 5 will allow for a far plane of 15. But if I move the camera back further, you can see it will stop drawing anything within that box here. So if I bring that box, I'm just going to use this gizmo over here to go to a fully flat X position. So we're now X, and I'm going to change this to this little button down here, changes the scene view from sort of perspective mode to an actual orthographic scene camera as well, isometric orthographic scene camera. So then we can view right plane. But if you can see here, we can move this edge of the right plane here would be at 0. And we can move the camera along like so. Anyway, click this back to go to perspective, back here. And we can press 2 on the keyboard or click this little 2D button to switch between 2D and 3D view. We'll just go back to 2D for now. And we'll reset our clipping planes. So we'll set this to something like 0.5. Set the far plane to, we don't need it as far as 1,000 because this game isn't going to be very big. We can probably just set this to something like 100, and that's probably fine. That's just a little overview of how the scene works and how different objects can be seen by the camera and how Unity processes those objects in the scene. So yeah, we have our background now, and I think that's great. I'm just going to rename this. So to rename, you can right click and choose rename. or you can double click on slowly and that chooses rename, or I think you can press F2 and that also the object, or or you can go up here and name the object in the inspector. So I'll make that space background. There are a ton of ways to do things in Unity often. It really just depends on your workflow or where you're at a given time. So the last little bit that's worth pointing out is that if our camera is slightly higher than our image, you can see here that our background is, because we only have, this is only just like an image, if our render box, sort of perspective box, that our the box in which things can be drawn by our camera is outside of the view of this background poster that we have, it will just sort of default to drawing this ugly blue color. So to change that, what we can do is we can go down here in the inspector with our camera selected and choose environment. And in the environment dropdown, let me just, it's smaller. In our environment dropdown, we can actually just change the solid color. And let's pick a wheel here, and we can just pick the edge pixel of our background. Maybe once more in the center of the background. Yeah, that's probably fine. I mean, alternatively, we could just make it black. That might be better. Screw it, let's just do that. Let's just make it black. I think a black edge is way better. Generally, we'll just make sure that the camera can't really exceed those boundaries, but every now and then you end up with somebody who has a resolution that, let's say we're trying to play the game in a crazy wide resolution or something, you probably haven't accounted for that in your background, so you're going to need to handle that somehow. So for now, we'll just set it to black so that the game will take place within this space on like an ultra wide monitor or something. That's why it's useful to have these different aspect ratios that you can check, because you can kind of see how the game looks in any given screen setup. But generally, as long as it looks good in 16:9, 16:10, you're pretty good. But you don't need to worry about supporting ultra wide monitors in this first ever tutorial that you're taking. So just keep it, it's just something worth keeping in mind, and that's kind of why we want to set the background settings on the camera, even though we're going to try and make sure that the camera itself is contained, because video games. All right, so with that, we are now set up to kind of stage our scene and add our player controls. Okay, so at this point, you've probably played around in the engine a little bit, and you should be relatively familiar with most of what you're seeing now. So it's time to move on to the fun stuff. Definitely not massively overwhelming bits of the game, which is actually like making the game happen. And that means we're going to start doing some coding. Do not worry, have no fear. I'm going to guide you through this. And as you know, I've been making games for a while, so I'm going to try and guide you through a way that will set you up to continue developing in Unity. A lot of beginner tutorials will give you sort of very basic information, but I do think it's really important to start with a lot of fundamental programming practices. And I'm going to try and guide you through a lot of that already. But like I said, don't be too overwhelmed. This project is relatively simple in terms of that, but it should give you a great bouncing off point to continue learning how to code from this point forward. But really, the great thing about Unity, and because it's so modular, is you can learn programming in very small, digestible chunks. So do not fear. We're going to get through this, okay? It's really, really not as scary or daunting as you might think. And the great thing about it is once you learn a few concepts and you learn some more concepts, you can start to combine those concepts into new and interesting ideas that will help you develop more and more complex games. You've really just got to think about programming as a tool, and you're really just learning how tools work so that you can continue to design and develop more interesting things. Generally, as an aside, I think that's one of the ways that I would like to try and communicate this, is that if you are a woodworker or a carpenter or a builder or something, you know how all the different components and things you have in your toolbox work. And by learning these different pieces of tooling, for instance, these different things that code can do, you can use these tools to build more and more things, right? So if you are not familiar with a drill or a power drill or a saw, you're not going to be able to drill holes into things. Once you learn how to use the power drill, you can drill holes into things, right? Versus a hammer to nail things, etc. And then you can start to construct more and more complex objects and things based off of that knowledge. And that's really, really all that coding is it's just tools to make more complicated things happen. And you can start with simple programming and you can then just continue to level that up and build more complex systems. And, you know, a little bit down the line, you're making more complex games. So before we jump into that though, we're going to want to get our player into the project. So I'll go back into our 2D view here and let's grab the ship and we're just going to drag that into the scene. The ship is huge. So why don't we make that a lot smaller? Or alternatively, we make the background bigger. Maybe we do that because our ship here is scaled to 1. So potentially, maybe let's scale our background up. So let's click the link button here. And I'm actually just going to bring this up to maybe like 10 times the size. No, let's go 5. We'll go 5 times that size. Okay. Split the difference. We'll go 4. 4 times this. Okay, we'll scale the scene up, the background up 4 times. Again, you can, if you can see here, this is the rect tool in Unity. You can actually just grab a corner and drag around like that. Or you can hold Shift, scale uniformly. You can hold Shift and Alt, scale uniformly from the center of the object. But generally, I like using controls for scale because I can kind of make sure that they stay uniform. I like typing things in. That's just me. But if you do want to use the controls, you can use the scale tool itself. The one from the center will scale uniformly as well. This will scale the y-axis. Oh, you need to turn off. You can use this button to force them to be uniform. Or so to disable constrained properties. So you need to turn it off to make everything even, and you can just type that in. I'm pressing tab, by the way, to switch between these. And click this so that it stays uniform. Weirdly, when you use this version, it doesn't stay uniform. So just keep that in mind. Use the scale tool if you want to make sure that you're scaling things uniformly. But if you want to be non-uniform, then do this. But then make sure that if you do want to reset this. Oh, I see. Okay. Bring it back to uniform. I didn't know you could do that. I've learned something today. If this is non-uniform and then you bring it back, what happens if I change this to 6? Okay, it then makes everything that size. Okay, so it just makes whatever you set uniform across the board. Good to know. See, even I know a ton of things, but I'm still learning things in Unity. So you don't need to feel bad. It's a constant learning experience. That's why I love doing this as well. Every new game I work on is a new experience and a new chance to learn things. And this engine is constantly evolving and there's new features being added. And so it's a never ending process of knowledge. Anyway, okay, so we've now scaled this back. So grab our camera and we'll get our camera back into position from earlier. Set the projection. We're actually going to bring the projection size up. Again, something like 40 will do. Which makes sense. It's 4 times the size that it was. We've got 16:9 selected, and it starts to look a little weird in the game view. You just want to make sure that low resolution aspect ratios is not enabled. Basically, it's just looking strange because preview is scaled, and so it's doing some weird filtering things. If I change this to 1920 by 1080 and then set this to 1, you can see that it looks clear. So just make sure that when you're in 16:9, you set this to disable the low resolution aspect ratios, and now that looks much better. We might actually zoom the camera in a little. So let's go to 35 maybe. See how that looks. Okay, let's go 30. Yeah, I think that looks pretty good. One of the other things you can play around with is to turn compression off completely, or you can change the filter mode and see if that makes a difference. Sometimes changing to point mode and generating MIP maps makes a difference. So that probably looks a little bit better. So, and that's on the actual object. It's on the sprite itself. MIP maps are ultimately just a way of rendering textures when they are smaller than the resolution that they actually are. And it's a clever technique in rendering as they get sort of progressively smaller, and they're smaller and smaller textures. And it's improving the rendering of things further and further away from the camera ultimately. And it makes just things that are smaller look way better. So yeah, to get this to look good at this distance, set the generate MIP maps enabled on the sprite and choose your preference. I actually prefer the no filter because I think it just renders a little bit sharper, but it's up to you. We now have the player object in our scene. Why don't we start getting it to move around? If we head into our project window here and choose assets, we can click on our input system actions asset. And if we double click this, it will open our input system actions. What this system does is it maps specific values to a word such as move, look, attack, etc. And it allows you to define a specific action that then you can map to a keyboard or a gamepad or a VR controller or anything. And basically it allows you to create common verbs ultimately that different input devices can use. And it means you don't have to write a ton of code for all of the different input devices that you want. You don't need to be specific and say, hey, when this button on the keyboard is being pressed, do this thing. It's more just when you detect that the thing I've said as move is being pressed by a keyboard or a gamepad or a joystick or whatever, tell me what the input is from that device, and I will then trigger that message to my scripts to say, hey, move is being pressed, so do this thing. So as you can see here, the preset is defined as move on the left stick on the gamepad, or using the WASD keys on the keyboard, or the up arrow and down arrow, etc. So we're actually going to just stick with these for now. We're going to remove the look controls because we don't need those. We're going to just get rid of anything we don't need. So we'll delete that. We'll keep the attack controls. We'll remove interact. So we just right click and choose delete. We don't need crouch because we're not a 3D game. We don't need jump. We don't need previous. We don't need next. We don't need sprint. So yeah, we'll keep move as is. And then our attack, let's make our attack on the gamepad button south, which is, it's just the designation of these guys on your controller. There's north, south, east, and west. That's all you need to know, really. And then there's the different sticks. Different gamepads have different mappings. I would suggest looking this up if you care more. I think I'm just trying to set this up for now. You don't really need to worry about this too much yet, but feel free to play around. You can actually just turn the controller on and listen. And as you can see, there's a bunch of presets here already, so you can always just look through those. But yeah, we'll make attack space, I think, on the space bar rather than the left mouse. Maybe we'll keep it as a left mouse. Yeah, we'll keep it as a left mouse for now. That'll be fine. Yeah, or we can make it space on the keyboard. We can choose between. So the player can use the left mouse button or space. I think same thing. That's probably good. We won't worry too much about the UI actions for now. They're fine. But all we need to know is that we have a move action and an attack action, and that it will work on our gamepad. Let's just delete this XR controller for now, just not to confuse things. Remove these. If you want to keep these in, that's fine. I like keeping these simple and just supporting the devices that I want to support. Yeah, and then we'll hit save asset and close this. So we've configured our input actions. Next then, we'll click on our ship, and what we're going to do is we're going to choose add component, and we're going to add a player input component. This is just a default component that Unity has to simplify a lot of the input controls. If you want to do more advanced things with input, you can. There's some really solid documentation on the player input. If you actually click this, you can open the reference for it. And if you want to learn how the input action systems work, you can do. There's tons of ways that you can listen for things on devices. The input player input component is just the simplest one to use. And but you can, if you kind of know a little bit about programming already, you can find a more advanced way to detect input in game. There's tons of different ways to do it. So feel free to give this a read if you learn more about that. So we'll make sure that default scheme is set to keyboard and mouse. And then this little warning is saying that project-wide actions asset is not recommended to be player input because it's a singleton reference. You don't need to worry too much about that for now. But to get that to go away, just click the input system, edit, and then just go over here and hit delete. And that will now no longer be like a global input action system. And it means that we can use these actions just on our player. Unity has multiple different ways that it can pay attention to input. It makes a global set so you can listen to them globally, but we don't really need to do that for this. So the first thing we're going to do is we are going to make a script. We're going to right click down here on the assets, choose create folder, and type scripts. This is going to be where our scripts live. Generally, you want to put these in different folders for different things, but the content of this tutorial, we're not going to be making a ton of scripts, but as your project grows, you probably want to keep these organized by the different intentions you have with them. There are lots of different ways you can write scripts in Unity and different reasons why you may want to choose to write scripts one way or the other. It's not something you super need to worry about right now, but as you start to build more complex projects, you'll maybe learn how you like to do things going along. And so I generally tend to keep everything in one scripts folder and have all my scripts in one place. So we'll start by making our new script. So we'll go create mono behavior script, and we'll call this ship controller. And a mono behavior script is just a quick template for code that's going to run on a game object. You can write code that runs on its own. You can write code that runs on a in the editor itself, so that you can write tools and make the process of making games easier. You can write code that is just data, and you use to configure maybe the speed of something or how something looks. And so Unity needs to know what you're doing and why you do something a certain way. So a mono behavior script is basically just saying, hey, this is something that I want to show up when I choose add component, and it's designed to belong on a game object. So now if I click on our ship and choose ship controller, we can see here our ship controller. You can also add a script this way by choosing new script, and you can then create an add and do it that way. That's perfectly fine. I just kind of like to do everything in the project window instead. You can also click and drag once you've created this onto the inspector, and that will just add the script to the ship. But as you can see, we now have a sprite renderer, a player input component, and our ship controller script. So let's double click this here and open the script. Okay, so welcome to code. Welcome to where video games are made and how we can tell our video game do things. So there are tons and tons of programming languages, and Unity uses C# as its programming language. It's a Microsoft language, and it is really, really, really well documented. I love this language. I think it just makes sense to me. Sometimes it can get a little complicated, but I do find that the way that it's built is really friendly. You will learn potentially other languages as you move forward. The cool thing about learning a programming language is moving from one to another one isn't that difficult, because it's really just like speaking a different dialect of English, or using slightly different terminology for things. And in some cases, it's just the difference between, say, like American English and British English, and they can be very, very similar. So one of the reasons I like C# so much is just because it does make sense to me, and because it's so well documented. So if you do want to learn a little bit more about C#, you can go to this URL here and get access to the language documentation, learn some of the fundamental concepts of C#. So something to keep in mind is that you can write programs outside of Unity. C# is the language that Unity uses, and there's a bunch of wrappers around C# that Unity uses to write your code. So it won't be a complete one-to-one. You can get an overview of the basic infrastructure and syntax, the sort of words that are being used and the jargon that you might not understand. So I'm going to try my best to explain it. But if you do need a little bit more detail, if you come in here and look up whatever I say, it should show up for you. You can always just Google that as well. So if I want to, for instance, if I want to know what is a class C#, you can usually find the Microsoft Learn documentation for that thing. And it's very detailed, it's very useful. So I highly recommend using this as your sort of workbook as we do some language programming, because if you do miss anything, it's explained in intricate detail in the Microsoft documentation. I will frequently end up on this website. I've been making games for 10 years. I've been using C# for about 8 of those. And I will often find myself back on the Microsoft C# documentation. Alternatively, if something isn't C# related and it's Unity related, the Unity docs are also incredible, so I highly recommend that. There's a scripting version and there's a manual version. Both of these can be used simultaneously. Just make sure you have the current version of Unity you're using selected, and often there are code snippets and examples of what things are and what they're doing. So if you do miss anything or you don't quite understand anything I'm talking about during this process, these are the 2 resources you can use to learn a little bit more and maybe find some more context if you need that. But I'll try my best to explain everything in as simple details as possible. So when an object is defined as a monobehavior script, it hooks into Unity's processing events. And the best way to think about that is that there's a loop of methods that are being called. Method is just a block of code here that gets called throughout the life cycle of your game. So when you hit play, which we'll do in a minute, when you hit play, Unity executes code at a given interval based on certain events. And this is known as the lifecycle or the function execution order. Lots of different names. It's the player loop, whatever you want to call it. But there's a specific set of Unity inbuilt methods that get called on a monobehavior during one frame. So in one frame, in this order, it will go through awake on a script when a script is turned on. It will then call on enable. It will then call reset. It will then call start. It will then call fixed update. It will then do a bunch of physics stuff, which we don't need to worry about too now. Now it'll check if there's triggers or collisions and call those methods if that's the case. Wait for updates. It will do input events on the mouse, and then it will call update. It will do all these things. It will then call these scene-related events, editor-related events, and then it will end the frame, and then it will go all the way back, and then it will do bunch of physics related loops, because sometimes the physics could be executing faster than the frame rate. I don't want to get into that, but it can happen. So there's like fixed update points, so it makes sure that things are happening on a specific interval, and your game logic will execute an update, etc. So there's generally some best practices on where you should put some code based on where you want things to happen. But the main thing you need to keep in mind for now as a beginner is that there's sort of 4 or 5 main places where you want to do things. So you'll frequently use the awake function in a monobehavior. You'll more than likely use on enable in a monobehavior, and you'll use the start a monobehavior. You'll probably use fixed update and update. Sometimes you'll use late update, but that's about it. There's also things for on disable, which is the opposite of on enable. I'll show you that in a minute. And then there's on destroy. And those are how you turn things off during frames. We'll get into all of this throughout the tutorial, but those are just some of the things you'll need to know. So there are prefixed events that Unity call. These are registered by Unity that it will just call on a script. So you can write these in your scripts and Unity will call them for you. You don't need to do anything. They'll just happen. So just to demonstrate this, what we'll do is we'll use the pre-built monobehavior that Unity has given us. And in start, we'll type debug.log. Debug is one of the classes in Unity. And a class is just, again, a group of code with some methods in it and potentially some other references to things. And then log is one of the methods, just like this start method is a method. And what that lets you do is it logs a message into the Unity console, which we haven't spoken about yet. Console is a tab here that lets you know about things that are happening in your project when they're running. So we'll take a look at that in a minute. So in here, we'll then type in quotes because we want strings. Strings have to be in quotes, so it tells Unity that this is something I want you to print as a string, which is just a piece of text, basically. Don't treat this as me writing code. Treat this as something I want you to print, right? So the string would be start. You just type on start, and then in update, we'll do the same thing. We'll go debug.log, and we'll type on update. And what we'll then do is we'll type 2 more, and we'll do void. So what is void, you're probably asking? Void is saying, I don't want this method to return anything. Don't worry about that. We're going to get into that in a little bit. But basically, you type void in C# to say, this method doesn't give anything back. You don't need to expect me to be passing something back to you. It's just a method you can call, okay? And in this instance, because we haven't declared it as public, other things won't be able to talk to it. Again, we'll get into that in a bit. I'll break down the components of sort of accessors and pre-method code, but we're just going to call a Unity-based function that Unity will call. So for on enable, as you can see, it's sort of predicting things for you. And we also want to make another one under here called void. And these two are the same, by the way. Unity just lets you not type private, but basically this is the same as private void. Private just means only run this in this script. You can only access this in this script. Other things can't call this method. Again, we'll go into detail about that later. So we'll do void, and we'll go on disable. Select that. I'm pressing enter to autocomplete that, by the way. And as you can see, because this is an inbuilt Unity function, if you hover over it, Unity will actually tell you what this method is doing. So on enable, we'll call debug.log on enable, and then we'll call debug.log on disable. So what we've just written is some code that will send a message to the console when the start method is called automatically by Unity, just before the update method, which we'll call on update, and that will happen every frame. So if we're running at 60 frames per second, this will print 60 times in 1 second. On enable calls when an object becomes active. I'll show you how that works in a minute. This will print debug log on enable. And then on disable, we'll call when the object becomes inactive. And so these are sort of a few. You can also use awake if you wanted to. So I'm just going to copy this by pressing Control-C and then Control-V and then typing awake. And we call awake. And then if we head back into Unity and hit this button up here, which is play, and then we take a look in our console, we can now see that it's just printing on update constantly. If I turn the ship off, you can see that it's called on disable. I've turned it off by clicking this little checkbox here. Now, when I press it again, it's going to print on enable, and then it's going to just loop as update. So if I hit collapse here, that just puts unique messages together in a stack. And you can see on update is being called, but all of these other ones have been called as part of that loop. But because these early events on awake and start only happen once when the script is first created, they don't get called again. They get called when you hit play. So these are really good for instantiation type things that you only ever want to happen once when the object is first created. On enable and on disable are great for things that you want when an object first appears, and on disable is when the object disappears from the game. You can also use on destroy, which is when you basically delete something from a scene. Again, we'll get to that later, but this is just sort of giving you an overview of what the game loop is in Unity. And hopefully you can see that basically we want all our game logic to be running in the update loop because that's constantly being called. So that is code that is constantly being executed through. Whereas this other stuff is only happening. If you see I'm turning this on and off, you can see that these two numbers keep incrementally increasing based on which one I'm doing. So well done. You've just written your first line of code. It's very useless, but it hopefully gives you an insight into what's happening. And actually the debug.log method is a really, really, really good way. If you're not sure what's happening, using debug.log, you can quite often detect issues within your code by creating these blocks of code, and maybe you don't hit one of those lines, and it's like, okay, well, my code is failing before I've managed to reach that. Debugging, unfortunately, is just one of those things you get better at the more you learn, and putting debug log will help you learn where things are going wrong. And thankfully, C# is also quite good at telling you if things are misconfigured, but generally, these are quite a useful tool in understanding where your code is executing incorrectly. There's a little precursor to moving our ship around. We're going to want to add a couple of components that allow us to move it in a way that adds some physics. We're in space, so we kind of want some inertia to exist if we're moving around, and we want things to knock into each other and to detect things. So that's where the physics system is coming in. And so before we start writing code to move our controller around, our ship around, we need to set up some of the physics on our ship in order to be able to interact with the physics system to move our character. Now, I could show you how to do that without physics. You don't necessarily need physics objects to do this, but this game specifically will be better with physics objects being used. However, if you don't care about physics or you don't want the game to have a kind of floaty element to it, you could skip some of the physics components entirely. They do just make some of the interactions a little easier to program and a little easier to work with because it's just doing a lot of stuff under the hood for us. So that's the reason why we're going to do some physics related things this early on. But as you'll see, there's some things you get for free with physics that I think generally will make this game feel a lot better. So physics are one of those things that you're going to want to choose whether to use or not. And sometimes it's not necessarily the best use case to use physics. And sometimes it'll be better to just hard code some basic physics yourself if you want to simulate physics rather than use like the real physics calculations. Hopefully that will make a bit more sense as we go through this. So in order to add physics to an object in Unity, you have to create a thing called a rigid body. And there's actually two types of rigid bodies. There's a rigid body system for 2D objects, and there's a rigid body system for 3D objects. So we're actually going to add a rigid body 2D to our sprite. Now, if I hit play, just after doing that, you should see that our ship just starts to fall and it's gone. So if we look in the scene view, we can see that our ship is just kind of falling. And that's because there's gravity involved. So if we did want to, let's say, interact with our ship, we're just going to do this as a slight tangent. Let's add a simple square sprite here. Let's scale this up. See that. We then add a collider, box collider 2D to our like you can see here there's this green outline. I've just toggled the sprite renderer off here. You can see there's this 2D collider outline. Colliders are what the rigid bodies use to actually interact with each other. So if we wanted this box to be pushed by the ship, we would want to add a rigid body itself. But if we just want it to be something that the ship's rigid body can interact with, we only need a collider. So you don't need rigid bodies and colliders together. The rigid body is, hey, I want you to simulate physics on this thing, and that is the script that is simulating the physics. And the collider is the way to tell the physics system to interact with other things in the game. So they don't need to be paired together, but they just often are. So we'll actually end up adding one to our ship. So we need, in order for our ship, as you can see, if I don't add one to the ship, it'll probably still just fall through. So to get the ship to interact with the box, we need to add a collider to our ship. Now it's up to you what type of collider you want to use. Generally, you want to try and use the simple collider objects because they're cheaper. But in this instance, because this is our sort of main object, and we want the physics interactions to be as accurate as possible, we can use our polygon collider 2D. And if you see, that then makes a collision shape that is roughly the outline of our sprite. Generally, these are more expensive to use, but they will create more accurate physics collisions. Sometimes you only want a certain part of the object to actually detect some of these physics actions, in which case, you might want to use a different type of collider, like a capsule or a circle collider or something. And we'll use those a little bit later. But for this game, it's probably simple enough. They're not too expensive. It's just if you've got hundreds and thousands of them, it starts to get expensive. If you've just got a couple of objects using them, you're perfectly fine. And realistically, if you're asking the question, when do I know that I'm using too many? The answer is when your game starts to perform poorly. So just something to keep in mind. If you're doing lots and lots and lots and lots of objects, maybe just try to think about that, but otherwise you should be okay. So we now hit play. You can see that as we hit the box, we now don't do anything. And if I go into the scene view here and I move the box around, our ship, and I hit ship with the box, you can see that we're sort of simulating some physics. So that's kind of how the physics work. It's just rigid bodies and colliders. If I wanted the box to also move around, then I could add a rigid body to that. We'll do some of this later when we start getting into the asteroids. They'll have physics on them as well. But for now, all we need is a ship. So we can just delete the object here. So the main problem now is that our ship is just falling. And in this game specifically, I don't want there to be any gravity. And so to change the gravity, we go into edit, we go project settings, and then we go up here into physics 2D. Notice there's also a normal physics, but we want to use physics 2D because we're running 2D game. And in gravity, the default is set to minus 9.81 because that's the basics physics calculation. There's a bunch of other physics settings. If you want to improve interactions with things, you don't need to worry about that. Right now, I think the best thing to do is just set the gravity to 0. Because this is a space game, we don't need gravity. So I'm then going to hit save by hitting Control S, and we're going to close that. And now, when we hit play, our ship doesn't go anywhere, but it is able to be controlled by physics with this rigid body 2D. There are a bunch of settings on the rigid body here that we'll use a little bit later to control how things interact with one another. Generally, the main things you want to pay attention to are the mass, the dampening. Those are just things you need to tune to control how heavy an object is. That will determine what the interaction is like when it hits another object with a different mass. And it's all just mathematical things for the physics engine to figure out how it should react when it's being hit. Honestly, I've been working with physics so long that these numbers are magic most of the time to me, because I think if I was more tuned into the science of the whole thing, I think they could be accurate. But most of the time, it's just play with them until it feels right, and then you kind of just stick with that. So I wouldn't worry too much about it. So with our rigid body on our ship, we can now start to control our ship. And this is where we're going to get into the meat of coding for this part. So we want to change settings on this rigid body from our ship controller when certain things have happened. Now, each of these scripts are self-contained objects. So our ship doesn't know that there's a rigid body on this object, and it doesn't know that there's a collider. And so because it's outside of the scope of this script, it's a different object that may exist or may not exist. We need to try and get a reference to it. And so that's kind of the interconnectivity of coding that allows you to interact with different parts of the game. And so we can have lots of different scripts affecting lots of other different things of the scripts. So it can very easily get out of control, which is why it's quite important to try and design your scripts and name your script as specifically as possible. So in this instance, it's going to be the ship controller. So we know that it's going to be doing things relative to components on the ship itself. So in order to start working with the rigid body, we're going to need to create a reference to it. And to do that, we'll type private rigid body 2D, and then we're going to call this m underscore rigid body. It doesn't actually matter what you name this. This is up to you. So you could call it rigid body 2D, you could call it my rigid body, You could call it whatever you want. Generally, there's some conventions around how you name things based on what their accesses are, and that's this bit, the private part. So this basically means that I can't access this variable, this property, from a different script. Whereas if this was set to public, I could find that somewhere else. And basically I'm using the M as part of the naming convention in order to show me at a glance that this thing is private. So I don't need to kind of scan the whole thing. I can use the name of the object to know what its intention is. And that's, once your projects start to get larger, using naming conventions like this makes it a lot easier to understand where things are and what their intention is, and helps you identify places where maybe some code might be incorrectly designated. So for now, we're just going to call this private rigid body M rigid body. And then in our awake method, we're going to type M underscore rigid body equals game object dot get component. And then we're going to use these angled brackets and type rigid body 2D. And then we're going to open normal brackets and close brackets and then a semicolon. And so what this line does is it looks on the game object that our mono behavior is currently on. This is part of the mono behavior space. If I hit control and click this, I can see some of the, you can see inside the mono behavior script. Behavior is a component is an object, and it comes with different shortcuts. So you see, once we go inside, so we've gone from mono behavior, we hit control click, you can see inside the mono behavior, which is a behavior, which if we go into that is a component, which if we go into that has a game object accessor on it. And that tries to find the object this script is currently on. Ultimately, all you need to know about what I just showed you there is that there's a sort of level of inheritance that scripts can have. I could have another script that inherits from ship controller. So I could have, for instance, like enemy ship controller of type ship controller, and this inherits from mono behavior. So there's a sort of family tree almost of inheritance that code can continue to stack on top of. And so you can make sort of templates that you can then extend from, and then make a template of that to extend from. And this is what's known as sort of, it's known as inheritance, basically. Again, I recommend looking up some of the C# documentation if you want to know about that. But what that would do is it would let me access, so if I make a public object in here, let's call it a Boolean that sort of is this enabled, for instance, then inside of here, I can, because our ship controller is a mono behavior, this enemy ship controller down here by proxy is also a mono behavior. So we can use the same logic, and then I can, because this one is called is this enabled, I can do this dot is this enabled, you see, because this is inheriting it from its parent, which is the ship controller. But because this is marked as private, I can't do this dot M underscore rigid body. However, if I did want to allow this to see it, but not any script anywhere, I could mark this as protected. If you want to learn more about the access modifiers, I do highly recommend looking these guys up on the C# documentation. They tell you everything you need to know about what they all mean. Generally, the ones you're going to be using are private, protected, and public. And all they really mean is just what level of access other scripts can have. Back to what we were talking about is that the M rigid body equals GameObject.getComponent. It's using the GameObject reference on the mono behavior, which is being inherited from its component parent. And then it calls the getComponent method. This is basically a shorthand script to say, hey, on myself, do I have one of these other scripts? And so we know that the ship controller is going to have a rigid body 2D. So this is calling mRigidBody equals GameObject.getComponent rigid body 2D. And a way to preview this is if we use an attribute called serializeField. This basically says if something is marked as private, I'd like to show it in the inspector. And so now we can see that in the inspector. So what we could actually do is not use this code and then manually assign the rigid body ourselves by just dragging that into there. That's useful when you want to get references to something that is outside of our own container. So maybe there's another object in the scene that we want to get a reference to. That's usually when you'd want to do it that way. But when it's on an object yourself, generally are safer keeping the object as private so that it isn't exposed in the inspector, and then using a get component call in the awake method or the start method to actually fetch that object on itself. Just to demonstrate this, I'll add serialized field so it does show up in the inspector. But if you see there's nothing assigned right now, whereas if we hit play, it's assigned itself to the rigid body. So we know that that's worked. Generally though, we don't really want to show this in the inspector, so there's no point. So then, just to show how this works, let's run a piece of code in the update method and we'll reference our rigid body. And then if we press dot, we get to see all of the potential things that we can reference on our rigid body or on our game object itself. Because again, it's just a mono behavior. So we can also reference stuff on ourselves, but we get access to some of the code that lives in the rigid body itself. So in this instance, what we want to do is on update, let's simulate the gravity happening. So we'll add force Y and we'll type minus 10 F for float and then add a semicolon. And floats are basically just floating point numbers. I'm not going to go too much into detail, but the most common numbers you use are floats or integers. Sometimes you'll use doubles, but floats and integers are all you really need to know. Integers basically just don't have a decimal point. They can be much larger. Floats are best if you need decimal points, but they're not very accurate once they start to get to a certain scale. So there's things to worry about there. For this project, you don't need to worry about that, but just know that this is using a floating point number. Unity tends to use floating points. And so this code here now should move and add a constant force to our rigid body every tick. So if we hit play, you see we are now moving. So we've manually controlled the physics object. And with that, we've actually managed to influence the code in our game. We have a physics object that we've managed to manipulate ourselves, and our ship is falling. So obviously we don't want that, but just to show you another use case for writing code and some of the cool things you can do. Now then, we know that this method takes a float. So why don't we expose a float in the inspector for us to change as a setting or a property that we can manipulate ourselves. So if we take private float m underscore downforce, and then we serialize this so it shows up in the inspector, we can then copy and replace this like this. Now in Unity, we have a value that we can set. So for instance, if I set this to 10 instead of minus 10, we're now sending our ship up instead. So that's kind of the gist of having settings in the inspector that you can change and then do things with in code. And it's really that simple. So why don't we make it that when we press one of our inputs that we turn our ship left or right? That seems like a pretty simple, easy thing to do. If we take a look at our player input component, we can see that it's set to will send messages. And this is, again, this is the reason why I picked this, because it's one of the easiest things about using the input component is that basically, if you remember, we've been using the update and awake. This is using a very similar logic where anything on this game object will receive these methods that we can then hook into and use for whatever reason we want. So as you can see, it says on move and on attack. Those are our two custom inputs that we set up, if you recall. So in our ship controller then, we can type void on move and void on attack. And we can just add some debug messages here. And then we make sure that the default map on our ship input is set to player, and then hit play. When we click, we should see the attack me message. And when we type any of our movement keys, we should see the move message. That means it's paying attention to our input devices. So this is good, but we don't have a ton of information that's that useful to us because we don't know, for instance, which key was pressed or which direction, how long it was been pressed down for. So what we actually need to do is receive some information from the player input component. And the way we do that is by typing input value in our method here. And we should see this and double click it, and it should add using Unity engine.input system to the top here. And we'll just type value. Basically, methods can have data passed through them to each other. As you saw earlier, we were passing in a float to our physics method as a way to manipulate something within that method. So if we call input value here, the input value has a way to fetch information from the input. So we can actually just detect, was that input pressed this frame, which obviously it will be because it's calling the event. Because our move action is set to send a value of type vector2, we want to get a reference to that value. So we'll call vector2 and we'll call this move input direction, and we'll go equals value dot get of type vector2. And then what we'll do is we'll actually just print that in our log. So then if we hit play, now when I press any of the keys, you can see that the value changes based on whether I'm pressing up, down, left, or right. And as you can see, when I'm letting go, it resets back down to 0. So we can use that information to determine which direction we're pressing. And I want the forward and backwards to move our ship forward and backwards, but I want the left and right to actually rotate our ship. So we can't really do anything when the button is pressed, because all that will happen is that for that one single frame, we'd process the event there. It's pretty useless to do on this event call. So what we actually need to do is store the current input on our script and then process that input during our update loop to turn our controller like a little bit every frame. So we need to actually just break these up and store them. So at the top here, let's create 2 new variables. Call one forward input and we'll call one turn input, and then store each of those values from our input direction here into those variables. So now let's expose these so we can see. So now on our ship controller, when we press any of these keys, you should see that our input value is changing based on whichever key we're typing. So between frames, we're actually storing the input. So basically what we want to do is when our key is pressed, we want to rotate our object along the Z axis here. You can see if we're rotating this axis, blue axis here, that's the Z axis. We're rotating along the Y because we're in 3D, remember, technically. That would turn our sprite perpendicular to the camera, or sort of flat on its ground. So not super useful. So to rotate in the axis we care about for 2D, we want to use the Z axis rotation. So we'll hide on attack for now. And down here in our late update, we'll use late update because it's, if you remember, it's part of the physics loop. It just allows certain changes to happen after physics has occurred. Let's first start by getting our current rotation. On the game object, it already has a reference to that transform component. It's just one of the convenience ones. So we can call transform. Under the hood, Unity uses a form of rotation math called quaternions. Way too complicated for you to worry about right now. So as a shortcut, and just it's way easier for humans to deal with, there's a different form of rotation that is converted from that, which is called Euler angles, which is the one that you're more useful. It's sort of the X, Y, and Z rotation. So we want to actually fetch that vector value from there. And so we'll assign that to our variable, and then we'll just get the Z axis from that. Let's rename this rotation vector. I'm just hitting Control R to rename, by the way. But for this then, we will just call this rotation, and we'll do the rotation vector dot Z. So that's our, actually we'll rename this to current rotation. And so what we want to do is we want to add to our current rotation based on our input angle. So we'll do current rotation for now plus equals m underscore turn input. And at the moment, we're only getting a reference and then messing with that reference. We're not actually applying that change. If I log the current rotation here, you'll see that it's not actually applying it. So it's only ever adding 1 permanently, and it's going back to fetching the actual current rotation. So all we need to do is then actually like apply that change while the key is being held down. This should then allow our object to turn. So we can just reassign the current rotation value to our vector and then reassign our vector. And as you see, we start spinning around. Keep in mind though, this is occurring every frame. So the faster our computer is going, the more frames we're rendering, the faster and faster and faster we'll keep spinning. But also because we're a physics object, this isn't a great way to do this. So what we want to do is reference our rigid body, set the rotation that way. So we can actually get rid of this and change that to this simply instead. For some reason, it's much slower. I'm not quite sure, but this is the more accurate way to do it. What we're actually doing here is we're grabbing the angles from our transform. We're then fetching the Z axis specifically, the Z value specifically. We're then just adding our current input to that value we just created, and then we're just reassigning that value to the rotation. And in the previous example, that sort of made sense just because of the way you'd have to access things. Can't just directly edit angles due to the way that Unity have the transform thing set up. But in this instance, we can actually directly change this. So what we can do is remove all of this and just access our rigid body rotation directly, add a plus beforehand, and then choose our turn input value. And so we can just kind of do this with one single line because we're using our physics object. Now it's actually going the wrong way based on my input. So I just need to change that from a plus to a minus, and now spinning around based on our input. Like I said, we're currently running at 900 frames per second. If I were to lock the frame rate here, for instance, to 60, you can see that it's much, much slower. If I increase this value back to 900, you can see it spins really fast. If I bring this down to like 20, you can see it spins incredibly slowly. So that's one of the big dangers about putting things in the update loop, is that you're tying code, specifically movement code, to the frame rate. And so you need to do a few things to stop that from being frame rate dependent. Otherwise, you'll end up with players complaining that, oh, it's way faster, or it's running too fast, or everything seems glitchy. So just a big kind of keep an eye out for this is be really careful about tying your speed to your frame rate. A good way to test this, which is what I've done, is to use the application.target frame rate function, which will allow you to set and cap the frame rate that Unity is running at, so you can test your input. So to avoid this, we basically just have to multiply our input value by the time between frames. That way, if our frame runs for half a second or takes 2 seconds, the distance that we would move in that time is scaled based on the frame time. Unfortunately, what that means is that we move incredibly slowly now because we are actually moving 1 unit basically every second. So while we're no longer time frame dependent, we need to adjust for the time slicing that we're doing. So up here, I'm just going to remove these and keep these private. Make another private float we'll call m turn speed, and we'll serialize this because we do actually want to set this in the inspector. And then down in our rotation, we'll multiply our turn input by our turn speed, and then multiply that by the delta time. And if we set our turn speed to 1000, we'll rotate at the same speed, no matter if we're running at 30 frames per second, or 60 frames per second, or 1000 frames per second, still running at the exact same speed. So at this point, it's up to you what you want to set the turn speed value to. I think something around 500 makes sense. That's also kind of insane. So what I'll actually do in our code here is I'll multiply our turn speed by 10. And what that should do is allow us to use a smaller number. So in fact, we'll actually multiply it by 100. And then we can use a turn speed of like 5 instead, much smaller number to deal with, to get the speed we want. And then if I hit 1, it's now, that feels like a turn speed of 1. And we can go for something about 3.5 maybe. That still might be a bit too fast. We'll start with 2. Often with game development, you're constantly sort of balancing these numbers and it's getting a feel for it. So we might end up changing this as we go forward, but I think a speed of 2 feels good to me. But yeah, there you have it. We now have a little spaceship that can rotate around. All we have to do next is get it to actually move. So it's actually pretty simple to get our ship moving. What we'll do is we'll add another variable for being able to control how fast we want our ship to move. So we'll make a new variable up here called m_move speed. And then in late update, we'll call rigid body dot add relative force y, and then we'll multiply our forward input by our move speed and multiply that by our delta time. And again, we'll probably need to start pretty high here because we're breaking this down by frame. There you go, something like 2000 seems about right here. We'll just head back into our script and multiply our move speed by 100. And then we'll just set our move speed to 1. Keep it low for now. And okay, maybe it does need to be about 2. So now we should be able to just sort of move around the screen, rotate our vehicle, and our ship can start to fly around based on our move speed. We might want to increase this just a little bit. I'll actually probably set this to something closer to maybe 3.5. So we pick up some momentum. That's pretty good. The weird thing now, though, is that we kind of want to be able to stop. I actually don't like that if you press down, it just kind of moves you in the other direction. So what we want to do is come up here and add a new variable called stopping power. And then we'll check if our forward input is greater than 0. And if it is, we'll just do our normal force multiplier. So basically just if we're pushing accelerate, then we accelerate. And then if we're pressing back or down, we want to slow ourselves down. So we actually want to stop, and we want to make sure that we stop at 0. So we're actually just going to set the velocity ourselves, and we're going to essentially interpolate between 2 values. So we're going to do m rigid body dot linear velocity equals vector2 dot lerp m rigid body dot linear velocity, which is just our current velocity, and vector2 dot 0. So we're going to go from our current velocity to no velocity based on our stopping power multiplied by time.delta time. And so what this essentially does is linearly interpolates between value A and value B. So this is no lerp, it's just setting the value. And then with lerp, you see you kind of get speed. So we can actually slow it down, zoom out, and it just smoothly moves from A to B. So essentially, if you think of this first as our start point and this second as our end point, this value basically determines how long it needs to take to get from our start point to our end point. And the value that we get back out is that adjusted value based on our current position. So this is always a value between 0 and 1, 0 being our start point, 1 being our end point. And so stopping power times time.delta time means that every few frames, we're going to move our linear velocity closer and closer to 0. So that value is actually going to get smaller and smaller and smaller. So it becomes this gradual slowdown. So then on our ship, we just want to set our stopping power to something like 10, maybe. Now, as we start to accelerate, press the down key, come to a nice smooth stop. And if this is lower, like something like 5, kind of increase the amount of time. I actually quite like 5. It kind of slows down smoothly and steadily. So you come to a slow stop. That gives us a little bit of precision over our controller. We want to sort of rapidly change direction, kind of come to a stop, turn around, and then go the other way. Much faster than taking a wide swing here, you see, because we've got to push all that momentum back. So we actually get to do a sort of stop maneuver, slow ourselves down, and then we can swing around. It's kind of like a quick stop mechanic. It just gives a little bit more freedom to our controller here. And I don't know, just adds a bit more fun. We now have our little ship that can fly around, but if we go a bit too far, you notice we kind of go off the screen. So we have a few options here where we can either just stop the vehicle from exiting the screen by setting boundaries, or we do the classic thing that Asteroids did, which is essentially just loop the player back around to the other side of the screen. So why don't we do that? In our code then, let's define a rect for the bounds of our play space. We always just want to set it basically based off of the minimum value. So it'll essentially be the bottom left of our grid here, which is about 55 and about -30. So we'll set that as our X and Y value, and then the width is essentially double that. And that kind of just defines the rectangle play space of our ship. And what we can then do is call mbounds.contains and check if our current position is within the boundary. So we can call mbounds.contains transform.position. If we put an exclamation point beforehand, this returns a Boolean, and the exclamation point means not. So it's the inverse value. So this essentially says if we're not within the boundary, we're not within the rectangle, then we are out of bounds. And as you can see, as we fly out of the screen space, we are registering as out of bounds. And then all we have to do is essentially figure out where we are and flip ourselves to the other side. So what we'll do is we'll grab the position and then check if position.x is less than mbounds.xmin, then position.x equals mbounds.xmax, and then we'll do the opposite, greater than mbounds.xmax, then position.x equals mbounds.xmin. And that way we essentially wrap ourselves around. And we'll just do the same for the y-axis. So then all we have to do is detect each edge of our bounds and set it to the opposite side. And then we just assign this to our rigid body position. Now then, we should be able to just completely wrap around the screen, no matter which side of the screen we fly away from. You may want to allow the player to fly off screen just a little bit so it doesn't look like they're fully warping. So you might want to increase the values a little bit to 120, maybe -35, and bring this up to 70. That should allow us to sort of spend a few frames off screen. It might just make the wraparound a little smoother, so it's not like there you go, that looks a lot better. The only downside is that sometimes you might go a little bit off, so you'll need to balance it a tiny bit, but you could also zoom the camera out just a little bit more if you want. That's better. Actually, if we set this to about 32, that seems to work well. Pretty happy with -70, -35, 120, 70 as my final settings here. And yeah, it's looking pretty good. We can fly around and we wrap around the screen. It's starting to come together. The only thing now is that we don't really have a limit on how fast we can go. If we just hold the W key down, we kind of just keep going to insane speeds, and we really have to like force ourselves to slow down. So we probably want to put a cap on our actual sort of maximum velocity. So in order to cap our speed here, we simply have to create a maximum speed value. And then underneath our input, we'll actually just check the magnitude of our linear velocity, which is basically just the distance of the vector, length of the vector, is greater than our maximum speed. And if it is, we will normalize the linear velocity, which makes sure that it has a length of 1, and multiply that by our maximum speed. So no matter what direction we're heading in and whatever our velocity is in whatever direction, it's always only ever going to be as high as our maximum speed. And that just keeps us capped at a certain speed limit. So I found a value of about 25 is good. And then we can adjust our move speed to accelerate a lot faster. And now, as we continue to hold on the acceleration button, you see that we kind of cap off at a certain speed here. We can still kind of fly around and change direction. and move in different directions. And our ship kind of just maintains that top velocity. Okay, so that's our main player controller setup. Now we need to sort of add the game, which means that we're going to need the asteroids to be spawned and fly around and be something that the player can interact with. So we'll start by loading our asteroids into the game, and then we'll figure out how to get them to move around and spawn them and despawn them, etc. So let's go ahead and get them added into our game. So I'm going to select all of my rocks here that we're going to use as the different stages of the asteroids. We're going to export them as PNGs, which will just group each layer together and let me export each layer. And then we're going to hit export, and we'll just export them into our sprites folder. And that should have brought all of our rocks in. Grab all of them, mark them as single, generate the bitmaps, set their quality to high, and hit apply, save. So what we should be able to do is now drag these into the level. In our game view, there we go, we can see that our asteroids are there. So we could individually spawn each object one by one and create code on every single one of them. But realistically, they kind of all want to behave the same. We just want them to look different. So what we can do is we can kind of make a template that all of our other asteroids are going to work from. And then any changes we make to that template will propagate to other versions. So ultimately, we just start with one rock, and then it's very easy for us to continue to add different ones later down the line. So to start then, we're going to just drag our first asteroid into the scene here, and we're going to do most of the work on this asteroid, and then we're going to get all the other ones to spawn based off of the work we do on this one. So we'll just kind of do the same thing we did with our ship. We'll add a rigid body, 2D, and we'll add a polygon collider. And now if we hit play, we should be able to just sort of push the asteroid around. You might also notice when you hit into the rock that it starts to spin our ship around. And that's due to the two physics objects interacting with each other. We kind of want our ship to be more resistant to that. So if we actually just increase our angular dampening to sort of 0.85, that will sort of stop the rock from messing with the rotation of our ship too much. It'll still exist a little bit, but won't notice it as much. Generally, it's always just best to play around with these three sort of mass and damping settings to change the way that the object interacts with other objects, and just find a point that you're happy with and you get the kind of reactions that you want. You can also actually just constrain certain things like rotation to just stop things from happening in the first place. So our asteroid is now a physics object that can be pushed around. Next thing we need to do is give it a script so that we can have the asteroid actually move and interact with our player. So let's head into our project window, and in the scripts, we'll create a new monobehavior script. And we'll call this one asteroid controller. And open that in Visual Studio. And we can actually share some of the stuff that we've got in our ship controller. So we kind of want the ship and the asteroid to share the behavior around needing a rigid body and also having a boundary that it can stay within. So rather than just copying this code and pasting it on our asteroid, we can actually just make a parent script that both of them can inherit from and share that bit of data. So let's go back into Unity, and we'll actually create another script, which we'll call bounded entity. And so then in this script, we can take some of the stuff from our ship controller and put it in here instead. So let's grab this rigid body reference and we'll cut it. We'll hit Control X and we'll put it into bounded entity. And then we'll also grab the bounds, put that in here too. Change both of these protected instead of private. And we'll copy this awake method, put that in bounded entity as well. And then in our late update, don't worry about these underlines, they'll go away in a minute. We'll grab this last chunk here that's all related to moving the object, and we'll cut that and then we'll make our own late update in here and paste that up here instead. Then change our ship controller from mono behavior here to bounded entity and see how now all of this stuff goes away, because we're actually running as a bounded entity first, which is then the mono behavior. So that's how the sort of inheritance works, where we go up a stack. We'll then use our asteroid controller and set that to a bounded entity, clear this stuff out. So they both kind of share the same parent script. And then hopefully all of our data still exists in our ship controller. And what we can do is we can copy bounds values and put our asteroid controller script on our asteroid. And you see how it shows bounds? We can then paste our bounds values in there instead. Then now if we hit play and we push our asteroid out of bounds, it comes back the other side. So we've actually sort of got shared behavior between these two scripts. So their child scripts are independent of each other, but the parent behaviors in the scripts are doing the same thing. One of the things you'll also need to do is we'll actually also need to set our late update method here to protected, but we'll also need to add the virtual method. And that essentially means that it can be overridden, but then also called. So then in our ship controller, we need to change this to override void and then call at the bottom of our script here, base.lateUpdate. And so that's kind of saying I want to add some code to the late update method that you've already defined as my parent. We don't need to do that with our asteroid controller, and we don't need to do that with our awake, because currently neither of those need something in their awake. But if they did, we would want to go in here and do the same thing where we call this virtual void. Virtual is just essentially a way of saying, if my child hasn't got a method like this and you're trying to call that method, call it on me instead. And so certain methods can be overridden, but it's a way to make sure that no matter what in the chain, there's always some kind of object that's handling that method. And then you just call base.lateUpdate if you want to continue executing that method from your parent as well. So again, in this instance, we want to override the late update, say, hey, run this stuff first, then call that part on my parent. But if we had this absent, it would just call this part instead, which is why it's happening on the asteroid controller. So then with that set to override, now both of our elements should wrap around. See? So that's the basics of setting up the object for our asteroid. Now we kind of need to get them to spawn on the screen when the game starts and probably have a little bit of momentum to them. So what we need to do is add an object that actually spawns our asteroid into the game. Let's create an empty object and we'll call this our asteroid manager. We'll then create a new script called asteroid manager. And in this script, we'll define a number of asteroids that we want active at any given time, track the current number of asteroids that are active. We'll keep a sort of reference of them as objects, and we will handle spawning them periodically while the game is running. So we'll start here by defining the amount of asteroids we want. We'll serialize this. Then we want to get a reference to all of the possible asteroid objects that we could spawn. So I'll show you what this means in a minute, but essentially what we want to do is create a list, and you want to make sure that you're using Unity engine you want to make sure you're using system.collections.generic. We want a list of game object, which we're going to call m_asteroid prefabs. Okay, I'm just going to get rid of this for now. Prefab is essentially a stored asset in our project that is ultimately a template or a blueprint for part of our game. Prefabs can kind of be anything, so it's hard to define them specifically, but imagine they're self-contained sort of groups of objects you can use as a shortcut to get things on screen rather than having to like add everything all at once. So what we'll actually do is we'll rename this object to pf_asteroid large_01. We'll then create a new folder in our project called prefabs, and then in here drag our asteroid. So now you can see that it's turned blue. What that means is it's now a prefab. And so we can actually double click on this and we can now start editing this in isolation. So we can make changes to our object. So let's do this. So let's drag, a bunch of these into our scene. And now if I double click on this and let's say, change the image that's being used to this other one, if I then hit save and go back to the scene, it's now changed all of the instances of them to that variation. So hopefully you can see how powerful that can be. So we'll go back in here, change this back to A. And so coolest thing about this is you can take a template and then, much like with the inherited classes that we've just done with the bounded element, you can kind of do the same thing with a prefab where you can say, hey, this is my root prefab parent template, make a variant that is a child of that prefab, but only change these values. Otherwise, get all of my other values from my parent. So for instance, when we want our asteroid to be used, we can keep all of the asteroid logic in the parent prefab, but we can change the visuals in a variant of that parent prefab. So what we're actually going to do is we're going to duplicate this prefab by hitting Control D. You can also right click and choose duplicate. We're then going to rename this to large O2. We're going to click on the sprite here, change this to big B, and then we're going to right click on the polygon collider and choose reset. That just gets it to draw the correct collision box. And then we're going to drag this into the prefabs, and the window will pop up saying, would you like to make a brand new one? Would you like to turn this into a variant? Because we realize that this has come from an existing prefab. So if we choose prefab variant, now, if we make a change to, let's say, the scale of our base prefab, and let's make these tiny, and then hit save, notice how both of them are now small. They both have inherited that change. So you can make independent changes on the parent without necessarily affecting the child, and vice versa. And Unity shows you this with its bolds here and this little overrides panel. It shows you what has changed. There's currently no changes, but while I'm in the scene, if I, for instance, scaled up this object, you would see that there's now an override in the scene on this object. So other versions of that variant won't copy that over unless I right click and choose apply as override to either the parent prefab or the variant prefab. Hopefully that makes sense. And hopefully you can see the sort of things you can do with that. And it definitely just speeds up your workflow a lot. So you're not constantly having to copy and paste changes over to things. It just sort of propagates changes through these different objects. We'll just rename this to variant 02. And then what we can actually do is we can just duplicate the version in the project here. Now that we have a prefab, it's going to contain parent. It's going to keep the same parent. So we'll name this 03, and then we'll just edit this variant independently in isolation by double clicking the asset there. And we'll change the sprite, and then we'll right click and choose reset on the collider. And so now we have 3 independent versions. Oh, yep, I forgot the parent is still very small. Let's go back and set the parent back. So there we go. We now have 3 large asteroids that are available to us. So on our asteroid manager then, we can add our asteroid manager script. And we can drag in our 3 prefabs. Just drag them to the top here. They'll then get added to the list. So we have our 3 asteroid prefabs assigned from our project into our manager. Okay, so now we're going to get our asteroids spawning into our scene. So what we'll do is in our start method, we will just for now spawn 1 asteroid, and then we'll do the work to spawn a whole bunch straight after that. So the first thing we want to do is we want to select an asteroid to spawn. So we'll pick a game object out of our list. So we'll call this asteroid to spawn, and we'll create integer called index, and that will be a random number from 0 to the size of our asteroid list. So random dot range 0 m underscore asteroid prefabs dot count. So then no matter how many more we add to that prefab list, it will always pick a number between 0 and that size. Then what we can do is we can actually just bring this down. We'll just assign this here. So if you hold Alt and up or down, you can move things up and down the line in Visual Studio. And then we'll type equals instantiate m_asteroid prefabs and then square brackets index. So that basically says pull this game object from the list at index 1 or 0 or whatever number it picks, and then make a copy of that object and assign it to this reference. And actually instantiate will just spawn it into the scene. So this will spawn the asteroid. There we go, we have our asteroid. As you can see, it spawns the asteroid just in the center of the scene. And if we spawned more, they would just keep spawning in the same place. So what we actually want to do is pick random locations for the asteroid to spawn in. And we also, it would be quite nice if the asteroid is a child of our asteroid manager object. So to get this to spawn as a child, what we can actually do is we can just put the transform currently on in our instantiate method, and that will now make it a child. And then we can set the position of our asteroid based off of a boundary. You can make a random position from that. So once again, we'll make a rect and we'll set this as spawn area. We'll serialize this and we'll create a vector2 spawn point equals new vector2. And then what we'll do is we will choose random dot range m_spawn area dot min x min m_spawn area dot x max comma random dot range m_spawn area dot y min m_spawn area dot y max. That will essentially generate a random point within the bounds of wherever we want our spawn area to be. So what we can then do is set asteroid to spawn dot transform dot position to that spawn point. So then on our asteroid manager, we kind of want the spawn range to be a little shorter than the edges. So go maybe -40 to 40. That makes the most sense. And then maybe 25. So we'll go make this -40 and -25. We'll make the height 50 and we'll make 80. And that should now spawn an asteroid kind of anywhere within that boundary space. There we go. We have one that spawned there. If we play the game again, it should now spawn in a different location. There we go. We have one there. So we now have a random spawning asteroid from our list. So it'll spawn a random one. So let's just add a few more and get it to spawn a whole bunch of them. So what we're going to do then is actually just gradually spawn a bunch of these over time. If we try and spawn a whole bunch when we start the game, it's just going to kind of lag. So essentially we just kind of want to gradually spawn a few over a few frames to just kind of ease the load a little bit. So what we're actually going to do is we'll just make a brand new method. We'll call this private void spawn random asteroid. Okay. And then we'll just grab all of this code. We'll hit Control X to cut, and then we'll Control V to paste, and it's now in this method instead. What we'll then do is we'll go for int I equals 0. So we're going to make a for loop. I is less than m_maximum asteroids I ++. So what a for loop does is essentially it iterates one specific bit of code until the conditions are met such that it can stop executing. And generally it's sort of a counting system. So you say, I'll start with a number of 0. And then when the variable that I've started, which is I in this instance, is less, as long as it's less than the maximum number of asteroids, we'll do this thing. And then when it's finished, we'll increment that value by 1. That's what the ++ means. It just means increase. It's just shorthand for +1. You could just put +=1 in here, and that's the same thing as ++. So essentially, we're going to loop over this bit of code n number of times to whatever our value set of maximum asteroids is. So if we spawn random asteroid, just to demonstrate this, we'll set the maximum asteroids to 5. I've also just added a bit of mass to the asteroid object, so they're a little bit denser. And as you can see here, we then spawn sort of 5 random asteroids within our area. And so just to make this handle a little bit better, we'll gradually spawn asteroids in. And so to call this sort of gradually over a few frames, we can use something known as a coroutine. So to do this, we can just create a method down here with the IEnumerator type instead of void. And we'll call this spawn asteroids. And then we'll take this out of here and call start coroutine spawn asteroids. And then in our coroutine here, while we're in the loop, we'll yield return new, wait seconds, and we'll wait about 1/10 of a second. And then if we set our spawn number to something like 10, when we hit play, we should gradually see our asteroids spawn into view like this. You see, there we go. They just all popped up together. So we're sort of gradually spawning them, and that just kind of eases the load of spawning an asteroid in one go. The next thing we probably want to do is make them move around a little bit so that there's some motion and the player kind of has a bit more of a challenge trying to catch up with them and shoot them, etc. So we can actually just do this within our asteroid controller script itself. Let's make a variable called force power, and then we'll grab our rigid body and we will add force, and we'll get a random dot inside unit circle, and then we'll multiply that by our rigid body dot mass, and then we'll multiply that by our force power, and we'll set the force mode to impulse. And so what this will do is when we spawn, it will add a random velocity somewhere within sort of a circle. So it will give it a random direction essentially, and then just sort of give it an explosive blast into that direction. And so what that should look like, if we head into Unity here, and we set the force power sort of 10, I think 10 will probably be quite good. We should then end up with a bunch of rocks that spawn with some kind of velocity direction on them at the beginning. And obviously, as they hit into each other, they then kind of bounce around and slow down. And so now we have a bunch of asteroids that have spawned and move around our scene. And then what we can also do is give a sort of random spin to it. So we'll do random.range. Let's give it an angular velocity of maybe minus angular power versus angular power. And we'll set that to about 20. And keep in mind, obviously, these other two will also update as we change these values. So we only have to update the sort of base parent prefab here. That's not quite enough. I think we can probably go a bit more aggressive than that. So maybe let's T. Okay, that's looking pretty good. So we now have our character controller that's moving around, and we have asteroids that are spawning with different variations. You can obviously add more variations if you wanted. So now we just need to find a way to destroy them and have them split up into smaller pieces. Let's go ahead and make more of our prefab variants for our smaller prefabs. We'll duplicate this one and we'll call this asteroid medium 01. We'll open this up and we will get our smaller variation. Again, set our polygon, and then what we probably want to do is reduce the mass on this one, sort of half its mass. It's sort of less, just to add a little bit of physics variation there. And then we'll duplicate this one. And as you notice, as I duplicated this, you see how it added 011? That's kind of annoying. We can actually change that by going into Edit, Project Settings. Down in the bottom here in the Editor tab, there's an option called Game Object Naming. And we just change this to underscore and then set this to 2 digits. And if you want to name them the way that I name them, you want to uncheck space before number in asset names. Basically, you can play around with these to get Unity to name things the way that you like for you automatically. So there, if we duplicate that, it now automatically numbers them for us. And then, yeah, we just go in and set our other sprites on these guys. So we'll go rock B and we'll right click on our polygon collider here and choose reset. That then matches that. Duplicate this again. This up, change sprite to C, set collider, and then do the same for our small one. Also set the rigid body to be 25, just keep cutting the difference there. Set the collider on this one. Okay, so we now have prefab set for all of our different sizes. As you can see, we can put in and they're much smaller. So our asteroid sizes are now set up as prefabs, but before we can do that and get them to break up into different pieces, we actually need to be able to destroy them. So let's make it so that our player can actually shoot some bullets to destroy our asteroids in the first place. Okay, so I've got a bullet sprite that I've imported. As you can see here, it's just a very small object. So we're going to turn this into an object that the player controller can fire. So what we'll actually do is we'll need to turn this into a prefab so we can spawn a bunch of them. And it'll obviously need its own components on it. So we'll change this into a bullet, change this into a prefab, add this into our prefab area, and we'll double click on it so we can edit that exclusively. We don't really need a rigid body on this one because it doesn't need to do anything physics based. It just needs to sort of act as a way for our objects to know that they've been hit. So all we'll do actually this time around is we'll add a collider to our bullet, and it's a capsule. We'll just add capsule collider 2D. And now most of the sprite is just this glow. So I'll actually bring the capsule down so we can click this little button here to get an in-scene editor where we can click and drag the gizmo. So I'll make it so that collision area is kind of just within that thick non-glowy part. And that's good. We'll then also make a new script for our bullet. Call this bullet, and let's add the bullet script to our bullet prefab. That's probably all we need to do for now on the bullet. We can delete that from our hierarchy. Also, I realized the scene has just said sample scene this entire time. Let's go into scenes and let's just rename this to game scene. And then on our ship controller, let's add a reference to our bullet. And then we'll also add a delay for firing our bullet because we don't want to just be spawning a whole bunch all at once. And then we'll also add a Boolean called m_is firing. And then in our attack, get the input value. And we can replace this for m_is firing equals value dot get int. It's a button, so technically it's a Boolean. We just do m is firing and we just do get bool. And that will then just be true or false, depending on if we've pressed on button or not. And then down here, we should check if we're firing. And if we are, we'll write a method called try spawn bullet, which we'll use to handle spawning the bullet. And it's pretty simple. Make a prefab called bullet. Again, same sort of thing that we've been doing before. We'll spawn the bullet prefab. And then we'll assign our prefab in bullet prefab slot here. And then after getting beaten up by the spawning, we click. Oh, no, okay. This is great. You've seen me make a mistake. So this is me doing some problem solving. I'm going to teach you how to debug right now. Cannot read value of Boolean from control mouse left button bound to action, blah, blah, blah. Control is button control with value type float. So what that basically means is we fetched the wrong value type. So we need to update our Boolean here to a float, which then makes this an error. So then we'll actually set that to greater than or equal to 1. And that basically now just means, hey, if this is down, we're actually firing. So I guess we could do greater than 0. That would then always be true. So that should solve that problem. And so now you can see we've just spawned a ton of bullets. There's just a whole bunch of them in the scene here. So we need to deal with those. So we want to do two things. We need to actually give our bullet some momentum. And then we would like to make sure that we're not just spawning a bunch of bullets in one go, which is why we add the firing delay. We also need to keep track of the previous frame. So we'll call this fire count. So in here we'll go if m_fire count is greater than m_fire delay, then fire count equals 0. And we'll do game object bullet equals game object dot instantiate m_bullet prefab. That'll spawn a bullet with basically that'll spawn a bullet when we press the button. And if we don't press the button, or if we've fired already and our count isn't as high as our delay limit, then we need to add sort of delay time to our fire count. So we'll do fire count plus equals time dot delta time. What we'll also do is make sure that our bullet spawns in front of us and in the direction we're facing. So we'll do bullet.transform.position equals transform.position plus transform.up multiplied by 3. And that's just so it spawns in front of us. Up is our y-axis on our ship, and the transform up is basically the up axis relative to us. So if I rotate ship, the up axis is actually this green arrow here. So it's the direction that our ship is facing. So world up will always be this way. It'll always be up on the y-axis up here. But transform up will always be whatever way our ship, our object is rotated. It's always the sort of up vector relative to the way that our ship is rotated. And we'll actually do the same thing by setting the up value to our up value. So then it will sort of face the direction that we're facing. And when we actually aren't firing, we should just make sure that we reset our fire count. So we'll make sure that fire count is equal to our delay value, so that if we press the button again, it will actually fire the bullet. And then we'll set our fire delay to 0.1, that's fine. Moving the bullet itself is really simple. All we do is set a forward speed on the bullet, and then we modify its position every frame based on its forward value, based on its up value, and its speed, and multiply that by the delta time. So just every frame, it's updating its position. And so then we can just go in and adjust our bullet's speed, and we also just want to make sure that it's set to a trigger. And if you want to draw it on top of things, just make sure that the order in layer is above 0. Everything else will be at 0. So just set the order in layer on the sprite renderer to above 0, and it will draw everything on top. And so then, yeah, we'll make our forward speed maybe 25. And yeah, so now we can fly around and fire our bullet. Look at that. Yeah, we can spin around and off goes our bullets. Unfortunately, we now just have a bunch of bullets in our scene. So we probably need to time them out so that they're not just spamming our entire scene hierarchy. So we need to just give it a little bit of a timeout, and then we'll get them to despawn. So we could do a few things where if they leave the zone, they could despawn, or if they time out, they could despawn. I'm fine with a timeout. It doesn't matter really that they keep carrying on off frame. So let's just, a timeout is far, far simpler. So in our bullet then, let's add a float, which we'll call total maximum lifetime, and we'll make a value current lifetime. And in our update loop, we'll just increment our current lifetime by time.delta time. And then afterwards, we'll check, is our current lifetime greater than our maximum lifetime? And if it is, we'll just destroy ourselves. So this will then allow the bullets to despawn. If I actually set this to 1 second, you can see that our bullets will start to despawn as they're firing, which, I don't know, I don't hate that if there's sort of a limit, so you have to sort of move around. Maybe we could play around with that. I think for now, we'll just set the maximum lifetime to something larger so they can kind of make it across the screen. But yeah, there we go. We now have a maximum lifetime of 5, which should allow our bullets to make it off screen before they despawn. But if we just stop touching things, eventually all of our bullets will despawn out of the scene. So that keeps our memory managed and stops us spawning a bunch of objects in our scene. But here we go. So we now have a ship that can fire bullets. We're getting closer and closer to all of the components we need for a video game. Let's move on to destroying our asteroids. So having our asteroids explode is actually not that complicated. Again, we're using a lot of what we've done before, but now we're going to do some things called collision detection and trigger detection. And these are just events that can fire when two colliders overlap, specifically when they're set to certain conditions. So on our asteroid, let's create a new method called onTriggerEnter2D. And this should fire whenever a trigger is overlapping with our object's collider. So we'll just test this. As you can see, as our bullet hits one of our asteroids, passes over our asteroids, we get the little trigger enter message. So that is pretty much how we've detected that the bullet has interacted with our asteroid. Keep in mind, you'll need to make sure that the trigger setting is enabled on the collider. If you want to detect two colliders interacting with each other, not set to trigger, you would use public void on collision enter, and that gives you some more information about the actual collision info. But for now, we don't really want any physics interactions between our bullets and our objects, so we're just going to set this to on trigger enter 2D. And this will be the point at which we actually should damage or destroy our asteroid. So what we really want to do is give all of our asteroids a certain amount of health. So when the asteroid is hit and its health reaches 0, it should then explode into another set of asteroids. I also want our ship to have health. So in our bounded entity, let's add a health variable. And then in our asteroid controller, what we can do is we can then lower our health when it is hit. And just for now, when our health is less than or equal to 0, let's just destroy this object. So we'll just give our asteroids 3 units of health each. And there you go. Once it gets shot 3 times, it destroys itself. So now then what we want to do is explode this into other asteroids when it gets hit. We can do this actually by triggering an event that talks to our asteroid manager. So we can call back to our asteroid manager and handle spawning a different asteroid instead. So what we'll actually do, instead of calling destroy, is make a event on our asteroid controller using system.action. And we will pass the asteroid controller through, and we'll call this on asteroid die. And when we do this, we might get a little error message that pops up because random exists in both system and also in Unity engine. So it's not sure which one to use. In this case, we want to use Unity engine. So if we just put Unity engine.random here, that solves the problem. And what we can then do is type on asteroid die down here with a question mark and invoke, and then pass ourself in as a parameter to that action. And so essentially what events do are just basically allow other objects to listen and then receive that message from the event. And so events are a great way to pass data around because they allow other objects to listen for certain things that they care about without necessarily needing to couple those two things together. So we don't need to get a reference to our asteroid manager. We know that our asteroid manager is spawning our asteroid controllers. So when they are spawned, we can use that specific moment to then listen for this event on our manager itself and then process some code on our manager. So we'll go ahead and do that now. So we add a little question mark on our event invocation here to basically say that, like, if there's actually something subscribed to this, then we'll invoke. Otherwise, it's a sort of null check. So it basically just says, hey, if this is null and there's nothing subscribed to this thing doesn't have anybody listening, don't try and send a message to anything. And that just basically saves some error handling. So anyway, in our asteroid manager, when we spawn our asteroid, what we can do is get our controller. So we get the asteroid controller from our asteroid that we've spawned by using get component, and then listen for, set this to private. That shouldn't be private, it should be public. As you can see, a good example of our accesses. We can now see on asteroid die. Then we'll do plus equals to subscribe to the event. And if we hit tab, that will actually insert a method that we can generate, and we'll just call, we'll name this on asteroid die. And you can see it passes itself. So what we can then do in here is call destroy obj.gameObject. I'm actually going to rename this by hitting Control R and name this asteroid. And that should now handle the death of our asteroid itself, removing the asteroid from the scene. So our manager is now handling the death of our asteroids. What we can then do is use this method to spawn smaller and smaller asteroids and eventually give points to the player and those kind of things. But we can do all of our global handling of asteroids exploding in our manager itself, not within each individual asteroid controller. We basically want to do something very similar to our spawn random asteroid method on a list of smaller objects. So we kind of need a reference to an asteroid's current size so that we can pick the next size to use. So in our asteroid controller, let's go ahead and add a size index, private float m_size, and then we actually want to get access to this from our other objects, but we don't want to be able to set it from other objects. So we want a private setter, but a public getter. And the way that I personally like to do this, because it sort of looks nicest for me in my script, is to call public float, and then I capitalize the value to show the intent that this is a getter. And then I just type m_size. This is just some shorthand equivalent for what would essentially be this code. And as you can see, this is a single line, and I just prefer seeing it this way, but these two would basically be identical. And this ultimately is just shorthand for this. So I'm choosing to do this here, and I like it. And I like using the capital. It shows intent that this is a getter. And so what we can do is then check what our asteroid size is and pick from a different list to spawn from. So we'll just go ahead and set our sizes on our prefabs here. So this can be size 3. These guys will be size 3 as well. Be size 2. And these will be size. And what we can then do is put all of our asteroids into our spawn list here. I'm actually going to lock the inspector up here by clicking this little icon. That means now if I click somewhere else, we've still got the asteroid manager selected. I'm then going to click on our medium asteroids. I'm going to shift click, select our medium ones, and I'm going to drag them and pop them into our list here. I'm then going to drag these smaller ones and pop these into our list here. So we now have a big list of prefabs. We could have 3 separate lists for the different sizes, but what I'm about to do allows us to change the number of sizes that we have without needing to update our list. Because if we want 10 sizes, every time we add a new size type, we'd have to add a new list for that different size type. Whereas if we put all of our items in a single list and then we look through that list for the size that we care about, it doesn't matter if we have 3, if we change that to 2, as we continue to develop the game, it allows us to move forward with a sort of more dynamic approach to the way that we're writing our code. So what we can do then is in our initial spawn random asteroid method, because now there's a ton, right? So we actually need to figure out what size we want to spawn. So we're going to do size, and in our initial method here, we're going to type 3. This is going to be wrong because the range is going to be larger than the actual size that we're looking for. So we're going to want to sort of select our collection down and filter through our list collection. So we can do this using a technique called link, which is just a sort of lookup system in C#. It's called language integrated query. And it's just a way to very quickly filter through lists and arrays and things like that. Very, very useful. It does have some memory allocation issues, but as long as you're not trying to do this thousands of times every frame, you're fine. So what we'll do is we need to make a new list type called for our prefabs, and this is our size prefabs. That's fine. We'll then type m_asteroid prefabs dot where, and open close brackets x. We'll do x.getComponent asteroid controller dot size equals our variable size. So this will now select from that list any objects where they have an asteroid controller on them with a size set to the size that we're looking for. What we can do here is we can fail early if this list doesn't actually exist and it can't find anything of that size. So we'll do if size prefabs equals null, or size prefabs dot count is less than 0, less than or equal to 0, return. So that will basically just stop executing this code if either of these two conditions are true. So you use an ampersand twice for and you use 2 of these pipes to be or. So if either of these things are true, and it always starts with the left one. So you can, if this is true, it won't continue validating it. This will just validate as true and it will do the thing that we tell it. So then what we can do is we can get our index from our size prefabs, and then we can grab our size prefabs.element at our index. And that will then grab a random asteroid of that size. So what we can then do down here is call our method at our other asteroid dot size. We will actually have to do this. We'll actually need to cache the size before we destroy the object. Once it's destroyed, we won't have a reference to it. So our size can actually be set as an integer. So let's go back here and update our size. We don't need it to be a float. We don't need the decimal places. It can just be an index. So I'll actually just make this an integer. This happens all the time. I'll designate something as one thing. You'll decide actually you need to do another thing. So I know this seems kind of chaotic, but this is programming. Welcome to actually it needs to do this. So you change things. I'm trying to make this as live and real as possible. I want it to be as if you're sitting next to me learning this stuff. So please keep this in mind that this is really what the experience of programming is going to be like, where you realize that you need to do different things. And I'll try and explain reasons why I'm changing things. It's not just kind of chaos. That really, I mean, a float would be fine, but it just makes sense to change this to an integer. And for your purposes, we may as well make this an integer. So we'll go ahead and do that. So then what we'll do is we'll decrease the size by 1. And if size is still greater than 0, we will spawn a random asteroid. What this should do now is spawn smaller asteroids when I've shot up a different one. There you go. It spawned another one down there, and one there, and one there. Obviously, this isn't ideal because it's just sort of randomly placing one again. What we really need to do is make sure that it spawns roughly within the same location as our current asteroid. So to do this, let's move our spawn point generation as a parameter. And we'll put that in our enumerator up here instead. Pass that through. And then down here, we'll spawn it in the position that our asteroid was in. So we'll grab vector2 asteroid equals asteroid transform dot position. There we go. It now replaces the old one with our new one. And eventually we remove all of the asteroids. That's good, but we kind of want it to explode into smaller ones. We're just kind of spawning one at a time right now. We could do multiple things, really. We could decide, we could make a list that kind of indexes how many we want to spawn. We could just kind of randomly spawn a bunch. That's possible. I think the size that we want to spawn to how many it spawns would make the most sense. So what we can do is make just a simple integer array. We'll just call this num to spawn on death. We're going to use this index to determine how many we need to spawn when an asteroid dies. So we need to make 3 entries, and at the bottom, that's going to be the biggest because we start counting at 0 and we want to use our size as the determining factor for how many to spawn. So we actually want to start at the end of the list and work backwards. So when our third one spawns, it becomes element 2, size 2, and so we spawn 8. And when our second one spawns, we want to spawn, sorry, when our third one spawns, we want to spawn 4, and when our second one spawns, we want to spawn 8. And this is just going to be 0 because we won't actually be counting that. So, but again, if we scale more, we can add more values the larger and larger size we have. What we can then do is do num to spawn equals num to spawn on death, and then our size index. And then what we can do, int row I equals 0. I is less than num to spawn, I plus, and then we can spawn a random asteroid at that point. And then just to make sure that they're not all overlapping, let's spawn at a random point using our inside unit circle and then multiply that by our asteroid point. So it spawns, we add that to our asteroid point. So it should then spawn randomly within sort of a circular range there. There you go. So we could multiply the size of our unit range, maybe by 2. Sort of has a bit more of an edge to it. There we go. And so now it's just a case of kind of balancing our numbers a little bit. So we get something that we're pretty happy with. I've just gone through our asteroids and adjusted their balance a little bit. I've decreased the force power depending on their size. And so the largest size have the more power, and they just sort of get weaker. So they hang around a little bit more. I've also just increased the radius at which we explode when our asteroid dies. Again, you should just tune a lot of these things yourself depending on how you feel it should react. Have a play around, see what you think. And so now all that's really missing is our bullets kind of keep going whenever we hit into an asteroid. We want to just make sure that they get destroyed, and then it feels a little bit more like they're actually being hit. So to do that, we basically just do the same thing we did on our asteroid controller, and in our bullet, we just detect if the trigger has entered anything or anything has collided with the trigger, and we just destroy ourselves when we are hit, basically. And so now when we hit our asteroids, our bullets disappear and our asteroids break. And we just have that little bit extra feedback of, we are actually hitting those asteroids. A little bit later, we'll add some visual effects and stuff to really sell the fact that we've hit this asteroid. But I think this is a good start for now. And now we can move on to the next step, which is making more asteroids appear gradually over time and making it a little bit harder. Okay, so we want to make a few more changes to our asteroid manager. We're actually going to have it just continually try and spawn asteroids every few frames. So what we basically want to do is keep a count of how many there are and reduce that count anytime one of them dies. So what we'll do is we'll go private int m underscore current asteroid count. And then anytime we spawn an asteroid, we'll actually just increase that count. And what I'm going to do is I'm going to add a new variable. Because realistically, this first variable is our starting asteroids. And so we'll use this value in our loop here. So I'm just double clicking and then pasting that in place. And so now we'll spawn asteroids at the start. So what we're then going to do is make a new coroutine and call this asteroid spawner. And let's rename this old one over here to spawn initial asteroids. And at the end of this, we're going to call asteroid spawner. And then in here, while our current asteroid count is greater than or equal to our maximum asteroid count, we're just going to hang out till the end of the frame, and that's just going to keep happening. But if it isn't, then we're going to spawn a random asteroid, type 3. You know what? We'll make a method for this grabbing of the spawn point. So we'll call this private vector2 get spawn point random. And we'll grab this, put that in there, and then return that. And get spawn point random, we'll replace that in there, and then we'll put that in here. And so what that basically does is it allows us to make sure that if we change it in one place, it changes in the other. So again, it's trying to minimize duplication of code where you do want code behavior to be shared. And we do want this to kind of just spawn anywhere the same as our initial frame. So we'll do that. And then we'll do the same thing where we'll yield for another second. And then we're just going to start the coroutine again. So we've kind of created a loop that's just going to run while our game is running. And it will hang out for a bit. Otherwise, it will spawn another asteroid. We'll actually just bring that up here. So this is just going to run endlessly until we've met our maximum number. So now, back in Unity, we have a starting asteroids, which we can make 3. And we can make our maximum asteroids 10. We also need to make sure that when we destroy an asteroid, we lower the count. But we should set the maximum asteroids to maybe 20. And actually, let's set our own delay. And we'll use that in our spawn method to determine how quickly we want to spawn new asteroids. So let's set our asteroid spawn delay. Let's just set it to every half second. Now we have a maximum amount. So we have quite a few on screen, so we're not going to get any more. But now, as we start to destroy our asteroids, we should be able to get new ones starting to spawn. only after we've started to clear these away. There's definitely a lot more than 20 on screen right now. But as you can see, if we increase that number to something crazy, it will continue to start to spawn asteroids until we bring it back down to something less insane. What we could do is only decrease the count when we remove a size 3 one. So if size equals 3, we lower the asteroid count. And we could potentially only increase the size if size equals 3. And that way we're kind of constantly just in control of the bigger asteroids. Then, yeah, as we destroy these bigger ones, it then kind of spawns more bigger ones. And you're then in a race, because as you create smaller ones, we're then getting inundated with larger ones here. So you kind of have to take care of the smaller ones before destroying a bigger one. Otherwise, a bigger one will spawn again. I think I quite like that. So maybe let's go with that. So there we are. I think it's looking pretty good at this point. Now we kind of move on to all the extra additional stuff. We've kind of got the basis of our game loop started. So yeah, congratulations. You've now got the inner workings of a video game. It's really starting to come together. And basically what you've got here are all the little components that you can start to customize to really get this to start to feel how you'd like it to feel. So feel free to get stuck in and kind of fiddle with some of the stuff that we've already been doing. The next step is really going to take this from what I would consider to be a toy right now into a real video game. We're going to add a score system, health, a game loop, visual effects. We might dive briefly into shaders so you really learn the gist of Unity and some of the breadth of things that you can do in there. And then from there, we're going to do last little bits of interface design to really sort of package the whole thing up, build a main menu, load the scene, allow you to sort of make it a piece of software really, and then build the game and allow you to give it to other people to play. So hopefully you're having fun, and I hope you're excited for the next section. So let's dive in to making this into a real video game. Before we move on, just a quick note. If you're enjoying the video and would like to see more content like this, please consider supporting Game Dev Guide over on Patreon. The core project files for this tutorial are completely free. You can grab those in the description. I want this series to be accessible to everyone. That said, patrons get access to private channels on the Discord, including a dedicated Asteroids tutorial channel that I've set up specifically for this course. It's a space to ask questions, share progress, and get help both from the community and from me directly. You'll also get early access to videos that are sponsor-free and ad-free, your name in the credits, and downloadable Unity package files for each tutorial so you can explore everything at your own pace. And if you're looking for something more personal, I also offer a mentorship tier for anyone who wants direct support learning game development or advice on their own projects. Videos like this take a lot of time to put together, and they genuinely wouldn't be possible without the support of my Patreons, so if you're already a Patreon, thank you. Alright, let's get back to building out our Asteroids game. So right now we have some basic components that really sort of make this feel like the beginning of a game, but really to turn it into a real game, we're going to need to add a bunch of things that build out a game loop. So we're going to need some scoring, we're going to need some health, and we're going to need a way to sort of make the game have a loss condition. And that's really what you would consider a game loop, is there needs to be a kind of lose state. There doesn't necessarily need to be a win state, because I think the best way to do this, and I think for this game, we want to have it to kind of just survive as long as you can and get the highest score you can. So the game loop, I think, is going to be sort of 3 lives and a score system. So let's start with our score system, and we're going to need to track basically some points somehow and then represent that on screen for the player to see. So we're going to dive into a bit more broad code tracking for things like that, something that can listen to the entire game state, and then figure out sort of how to get UI into the game, which is a user interface to show things on screen for the player to be able to see how they're doing. So let's dive into that. Okay, so first things first then, let's get support in for tracking a score. There's lots of different ways that we could track this, but I think the best thing to do for now is to just have a independent object that can sort of pay attention to things and track the score that way, and potentially then feed that back to the user interface as well. So let's create a new game object in our scene, and we're going to call this Score Manager. And then just to kind of keep things organized, let's also right click here, create empty, and we'll create a new object called Managers. And then we'll drag and pop these as children into our hierarchy here. Now, realistically, we could technically put these scripts just on a top level object, But I quite like, and let's actually zero this out over here. I don't like just sort of folder type objects that I make to have an actual transform position. Yeah, what I was saying is exactly that I tend to use hierarchical objects as sort of folders for things, and it just keeps the hierarchy organized because it's very easy to have this whole thing sort of become this just tedious list that you have to search through. So it's quite nice to have an actual parent object that our manager classes live within, because then when we need to get access to them, we know to go find the manager's object, and then it will be a child in there somewhere. So you don't have to do that, but it's just a sort of housekeeping thing that I enjoy doing and just keeps my project more organized. So in our score manager then, let's create a new mono behavior script. I'm going to call this score manager, and we're going to drag that onto our object here. And what we're also going to do is we're going to create an empty C# script. And we're going to call this game events. And we're going to open this up in Visual Studio. So what we're going to do is we're going to have a little middle manager that the more global parts of our gameplay system can pay attention to, and the different components of our game can then talk through, and they'll be able to pass data between one another. And the reason that we would do something like this is so that we don't necessarily need something to exist in order for the things to talk to one another. And it basically just makes it a little bit easier when you're developing your game, because you can remove parts of the game without breaking the other parts. Because if you tightly couple it, so for instance, if as we build our score manager, we get references to our asteroids and our ship and our player, and we make those directly coupled to each other, it then means that if we make any changes to our player, we split that up, then we have to update our score manager to pay attention to that. Whereas if we go through a middle manager, which is essentially an event system that we're about to build, our event system is kind of the only constant in our game, and it can just send messages around to all of its different objects that are paying attention to. So we're ultimately going to just do a similar thing to what we did before with our asteroid, which was this event that we made. But instead of it being something that can subscribe to that asteroid itself, we're going to have a sort of more global event system. This should all sort of start to come together as we start building it out. So I'll try and walk you through it best as possible, but just it's really not going to be much more than what we've already done with that initial event that we made earlier. It's just that it's going to be isolated. So we're not actually going to add this as a mono behavior. This is just going to exist the first time that something needs it, and then that will just sort of exist in the ethos of the game and allow us to handle the state. So if we don't add the mono behavior, we don't get all of the update loop stuff, but we also don't need to try and add it to a component in our object here. It can just be isolated from the rest of the game loop. So what we're going to do though, is we are going to make a reference within itself, a static reference within itself called game events. And this is going to be a uppercase I instance. And we're going to make a private one. And so then what we're going to do here in our public one is type get. So what we're going to do is we're going to check if our instance is null. And if it is, we're going to make a new version of it. So basically there's only one will ever be able to exist when we try and fetch it. And then we're going to return that. Now, what the static declaration does is it basically makes it global, but it makes it global within our code. So actually it will continue to be global wherever we access it. And so it's sort of outside of Unity's loop. So it's important to be careful with static references. Like I said before, if you want to understand how statics work, take a look at the C# documentation. It goes into a lot of great detail about how the static modifier works and the sort of use cases for it and where it makes the most sense. Generally though, you tend to use it to get a global reference to something, and it's most commonly used to get references to singletons. And so this is what we're about to create, which is a singleton reference. And so the first time we try and access our instance of our game events class, we will create a new version of it if it doesn't exist, or just return that version of it that already exists because something else has initialized it. And so then in here, we'll be able to put all of our game events that we're going to need a little bit down the line. So we're going to leave this for now, and we're going to move on to start building our score manager. But this is basically how we're going to tell our score manager where our score is coming from and handle things in that way. And we're then going to be able to feed that into our UI system and have the whole game pay attention to things that are happening. There's a lots of different ways you can achieve the same results, but this is just my favorite because I find it the cleanest, and I also find it the most logical. I can make changes to different parts of the game without drastically needing to refactor everything or ending up with missing references, etc., etc. So in our score manager then, we basically just want to have a tally of the player's current score. So what we'll do is we'll make an integer that we'll call score, and we'll be sure to serialize this field. We'll also make a reference to the top score, and we'll make two methods to add and clear the score. And actually, let's allow us to pass a value in here, but we'll default to 1. So if you don't actually pass anything in, it will just add 1 automatically. So you could just type add score, open bracket, close bracket, and that would work. Or optionally, you could pass a different number in, and that would be used to add the score. And then we'll make another method, clear score, and this will reset the score back down to 0. Now, I haven't actually explained this yet, but one of the cool things you can do, especially in Visual Studio, is if you type // it can generate a little summary block here, and we can type clears the current score. And then in doing that, if you see when we mouse over our score here, it shows us what we just wrote above. So that's a great way to communicate what methods are doing and actually write comments in your code. Generally, you should comment your code so that when you come back to it in a week, 2 weeks, a month, you kind of roughly know what past you was thinking. Trust me, it's very useful because quite often I will open something that's uncommented and I will hate the past version of myself, and I have to figure out exactly what I was thinking at any given time and get my head back into the headspace. Comments have saved me so many more times than the work involved in writing them. So try to maintain good commenting. So we're not going to do that for everything, but I just wanted to bring that up here. Find points where you can add comments. So adds a score to the current score, or adds an amount to the current score. And then in here, we can say how much we want to add. And so if you hover over this, you can see that that now shows up in our method. And if we were to call it, for instance, if we try to call clear score here, you can see that while we're typing it, IntelliSense shows us what the actual method does. So it's very useful. And yeah, so that should probably be it for now for us to add our score. We should set our score at the beginning. So in our awake method, let's just call our clear score method, and that will reset our score to 0. We should probably find a way to save our top score. Probably the best thing to do is do a check here in our add score method every time we add our score, or potentially in our clear score. Let's do it in our add score method. So if m_top score is less than m_score, then our top score equals our score. So anytime update our top score if our current score exceeds. There we go. Update our top score if our current score exceeds our previous top score. And then that way, basically, anytime we add score, it will just keep updating our top score. So these are probably the two values that we need to just track our game. We could do different things in here if we wanted to, but I think this will be fine for now as a way to track our score. So I think what we want to do is anytime we kill one of our asteroid pieces, we increment the score. And that should just be a basic way to track our score for now. We can get a little bit more fancy with it later. Maybe there's some other objects that we'll pick up to get a higher score bonus. But I think this is probably the main place where we want our score to increase. So what we can do is we can create an event in our game event system that our asteroid manager can call and our asteroid controller can listen to in order to increment our score. So here in our game event system, let's go public event action, And then we might get a little message here. So what you can do is press Control period. And what that will do is it will suggest a namespace that you might be in need of in order to actually make this a valid piece of code. You've seen me do it a little bit already, but I didn't really want to get too much into it. But essentially, namespaces are just little groups of folders or code. I don't know the best way to explain it, but essentially they're little blocks of code that are self-contained within a specific namespace. So system, Unity engine, and you can make those yourself. If you want to know more about them, again, I suggest looking up what namespaces do, but just know that you can import namespaces to get access to other groups of code. And that's sort of what's happening there when you're typing things and you're getting squiggly lines. If it doesn't come up, it's probably missing a namespace. So yeah, you can right click and choose quick actions and refactorings and import it. You can type that up here yourself if you want and import that namespace. Or what I tend to do while I'm typing, just because it's easier, is just hit Control period, and it will often give me the one that I want. And in this case, it is system. So, and we'll call this on add to score. And then we'll make a method called add to score, where we'll pass an integer, and then we'll call on add to score question mark dot invoke and the amount we want to add to our score. And we'll comment on this. Dispatches an event to increment the score value. And then amount to increment by. And that's great. And so then over here in our asteroid manager, when our asteroid dies, we can call game events dot instance dot add to score. For now, we'll just make it 1. So they'll just add 1 every time. And then in our score manager, so we'll add 2 methods, on enable and on disable. And in here, when we're enabled, we will subscribe to our score event. And when we're disabled, we'll unsubscribe from our score events. It's really important that we handle our event cleanup logic, but essentially it just means that we're doing some housekeeping, and when our object is no longer needed and no longer needs to pay attention to that our game events isn't just keeping loose references around. So generally, you want to subscribe to events when you need them and unsubscribe from them when you no longer care about them. So we'll just call game events.instance.onAddToScore plus equals add score. And we'll copy this and paste this in here, and then we'll subtract the event from our manager there. So now then, if we take a look in Unity, we should have our score manager script here. And when we hit play, if we start shooting some of these asteroids, you should see that our score is starting to increase as we take these asteroids out. So anytime that an asteroid gets destroyed, it's sending that message, and our score manager is listening to that message and incrementing our number. So we now have an accurate system for tracking our score. That's great. We just need to get it on screen to show the player now, because while it's in the editor here in Unity, nobody's going to see that. So let's start building out our interface for the player. We're going to need a font to use, so let's head into Google Fonts and grab one. I suggest that you do this yourself. This is not going to be something that I share in the project. I'm going to grab this Orbitron font, so we'll grab that one. I quite like this Iceland font too. We might find a use for that. I think it's quite nice to sometimes have 2 fonts side by side. Sometimes you want one for one interface and then you want one that's a little bit more legible. So let's grab that one too, and we will download both of those. Okay, so once you've downloaded your fonts and you've got them in your project, I've just grabbed the TTFs here and popped them in a fonts folder. You want to select the ones that you want to use. You're going to right click and you're going to choose Create, Text Core, Font Asset, and then SDF. What that's going to do is turn these fonts into a format that our UI system is going to be better at using. If you want to look it up, SDF stands for Sign Distance Field, which is a type of rendering that just allows essentially for clean edges and a sharp display no matter what resolution you're looking at. So it's really great for user interfaces. With our font ready then, we can start creating our interface. We're going to right click on our hierarchy. We're going to choose UI Toolkit and pick UI Document. And that's going to create an element for us there. So we then should have a UI Toolkit folder. And then in here, we are going to create UI toolkit, UI document, UXML, and we are going to call this our heads up display, which is just sort of the main UI scene. And then we're going to click on our UI document here. We're going to drag that into our source asset. And then if we double click this, we're then going to select in our hierarchy here, click on the HUD UXML and choose match game view, or alternatively, you could just sort of put something in as, 1080p or whatever in the size over here. But ultimately what that does is allows us to work within the UI space that we're probably going to be playing in. UI Toolkit is Unity's most recent UI system. I actually have a full video explaining sort of UI Toolkit. If you want to get the basics of how that works, you can check that out down below. But ultimately, I'm just going to give you the sort of cheat sheet here. And if you follow along, you should sort of start to get the gist of how this works. What you're seeing right here is the UI builder, which is the what you see is what you get editor for our UI. But UI Toolkit is closer to a web development UI system where there's one script called the UXML file that keeps all of the sort of hierarchy of our objects. And then there's another script called a USS file that handles the styling of our UI element. So it's very much more web dev focused, but I really like it because it gives a lot of flexibility and allows you to reuse a lot of the same functionality across different UI elements. We're not really going to get into the details and weeds of that in this video, but like I said, there's one down below if you want to check that out in more detail. But by the end of this, you should have a basic understanding of how to build a UI here in Unity. Okay, so what we're going to do is we're going to add a sort of container that will create our content in. And so we'll just drag a visual element here. This is a sort of flexible box that you can put things in, and basically everything sort of extends from visual element. So this is just sort of the base element here. So on our right here, you can see this is where you have a bunch of properties to change how things look. And so you can just get in here and mess around with how each of these elements look, but we won't worry too much about that just for now. It's worth keeping in mind though that any changes you make on this side here are actually baked into the element. You have to use your style sheet in order to be able to share certain visual properties across multiple different elements. So before we go any further, we're just going to make a basic style sheet so that we can share some things across our elements. We'll left click up here and choose create new USS. And then let's just save this in our UI toolkit folder. We'll make a new folder here called styles. And then we'll save this and we'll just call this base styles. And so now we'll be able to add different styles in there. We'll also in our hierarchy left click on here and choose class list. And that will then show any classes that we assign to share those styles. Okay, so we have our visual element. Let's right click and just give this a name. We'll just call this container for now. And then let's create another element in there, which we will right click, hit rename and call top bar. And what I want to do is set grow to 0. We'll give it we'll select our size drop down here. And in our height, we'll set this to something like maybe 100, then a little less. Let's maybe go 75. Let's do 75. I think that's a good space. So now anything that we put in there will be in this little top section that we've defined. And as you can see, that has actually saved our styling into the UXML element itself. So what I like to do is just keep everything out of the UXML and put it into the USS. So up here, we'll type top dash bar and then hit extract inline styles to new class. That now has made this top bar. You see how this is updated here, and it has removed the styling info from that XML document itself. And that then means that if we wanted to override what top bar meant, we could do that a little bit down the line, or we could change it for a different style that maybe has a background or something without needing to actually change the makeup of the UXML document itself. So it's very useful if you want to start customizing things to be using classes. And then let's just do the same here for our container. And so there we go. Generally, the rule in the USS is applied the same as it is in WebDev, which is essentially that the bottom-most class has priority. There's a few obviously nuances to that, but for now, that's probably all you need to know. So if you start getting some weird behaviors, just make sure that the ordering of these are correct and move them around if you're getting some odd sort of dominance over your classes there. Okay, so that's probably fine for now. Maybe it would be nice to add just a sort of slight background to this. So we'll click our little top bar here and we'll choose our, actually, if we click on the HUD, we should be able to choose canvas background and then camera and select our main camera. And that now shows us what that would look like in the scene, which is great. So we can actually design this as if we're in our scene here. So let's click the top bar again. And I just want to add a little bit of black. So I'll bring the alpha up to about 60%. You can fiddle around with this until you get something that you think looks nice, but that's probably fine for now. We're just going to have our score over in one side, I guess maybe on the left, and then we'll have sort of our lives over on the right, and potentially any other information that we want. We could always just put a button there for the player to click to if we needed that. So yeah, let's do that. Let's get our label. We'll just drag that into our top bar here so it becomes a child of that. Now by default, if we just type some text in here, so in our attributes section, we have a label. I think that's actually rendering as black. So we'll want to change the text settings to be white. We'll also scale this up to about, let's do 30. And our font, we can choose our font asset here, and then we can select one of the fonts that we downloaded. So I'm going to go Orbitron Bold. As you could maybe see, you can see how this is sort of half the size vertically of our box. And if I duplicate this, it kind of stacks it underneath. And that's because by default, the layout is set to sort of stack things underneath each other. So we can actually change that by clicking our top bar and changing the flex direction to row. And now it'll put the elements next to each other, which is perfect. So we want to name this label here the score label, and we'll type score here. And then this version of our label here will actually change the font to maybe regular. And then we'll set the text just for now to 000 so we can see what that would look like. So we'll name this score value. And then I'll actually make a class for that and we'll call this score value. Extract the inline styles to new class. And we'll do the same for the label. We'll call this score-label. Extract inline style to new class. And I think actually I'll just make the top bar a little bit more transparent, just so it stands out a tiny bit, probably not that much. It's probably better if it's something like 15. And our label here is kind of close to the edge. So why don't we go into our spacing options and we'll give, we could have the bar, if we set the margin, that isolates the bar a little bit, but no, let's, we can right click and choose unset on that. And then in our padding, let's actually set a padding of about maybe 5 generally, but on the left-hand side, let's set this to about 25. There we go. So it's just sort of inset a little bit from the front. And if you click on the, or hover over the element, you can sort of see a preview of what that looks like. So yeah, I'm pretty happy with that. I think that's a good way to show our score. So let's get that actually showing our score. So one of the coolest things about Yoa Toolkit, and one of the reasons I love using it, is because it can basically just kind of do it for you, and it can track data and show things and update things on the screen purely based on the way that you set it up. So what we can actually do is click our score value here, and over here in the data source, we can change the data source type. So make sure this is set to type, and then select our type. And then all we actually need to do is search for score manager, and we can see the score manager script that we made earlier. So we can double click on that. And then over here in our text, we click these 3 dots here, we can choose add binding and then click our type here. And then as you can see, the 2 values that we created earlier now show up. So we can actually create our M score here. If we click that and choose add binding, we've now bound that label element to that piece of data. So anytime that data changes, it will update. There's just one more thing we have to do to get this to work. Let's create a script here. We'll make it a monobehavior script, and we will call this HUD. Let's rename our UI document here to HUD, and then we'll grab our HUD script, drag that onto there. So in here, we'll grab on enable, we'll fetch a reference to the UI document on our game object. And then in here, we'll get the root visual element. And then we'll also grab our label by querying our root element for our label called score value. And then we'll make a reference to our score manager. And we'll set the data source on our score label to be our score manager, like so. And so then in Unity, if we drag our score manager into the score manager on our HUD script here, because we set that as our data source type, and then it knows which data to track. When we hit play, you can see that our score is 0. And as our score increases, our UI automatically updates based on that value. So we don't need to listen to an event. Our UI system just automatically handles that and tracks our score for us. Okay, so we now have the basis for our score. Let's add a bit more to our game loop here and make it so that the player can actually lose lives. So to do that, we're gonna need to give them some lives, and then we're gonna have to detect them getting hit and give them some health. And then when they get hit too many times, disappear, and then we'll respawn them and lose a life. And then when we have 0 lives, the game's over and we have our game loop. So to do this, let's head into our score manager and let's create 2 more values. One for our lives and one for our maximum amount of lives. And what we'll do is in our clear score, we'll reset our lives. So we'll say current lives equals max lives. And then in our inspector here, let's select our score manager and we'll set maximum lives to 3 for now. And then we just want to show this on our interface. So let's head into our HUD element and we'll put it in our top bar here. So what we'll do is we'll add a visual element here in the middle and we'll just call this spacer. So that will kind of keep these elements separated because I kind of want the lives to show up over here on the right. So what we'll then do is we'll add another visual element and this will be the icon for our lives. So we'll call this lives icon and we will disable grow on this one and we'll set the width to about 45. That should be fine. We might want to make a change to that in a minute. And then we will head into the background section here, change this to sprite, and then we'll actually just select our player icon. So we'll just grab the ship. If we zoom here, we can actually see the images that we have. So we'll double click on our ship here, and then that shows up there. And then all we do is we set the scale mode here to scale to fit, and that should now fit nicely in our box there. So what we'll do is we'll add the image here to our style. So we'll just call this lives icon and extract inline styles. That's now in there. And then all we kind of have to do is the same thing we did before with the score value. Let's just duplicate that. I just hit Control D on my keyboard to do that. You can also right click, choose duplicate. We'll rename this to lives value. And yeah, the styling is fine. We can use the same styling as the other one. And as this is already attached to our score manager, there's not really much we need to do. We just need to go in here and edit our binding. And then instead of using m_score, we can use m_current lives and hit save. Let me just double check that worked. Yep, that's m lives. And then what we can do is because both of these values are using the score manager, we could actually just bind the score manager to the top bar here, and that should sort of update. So we'll go into the HUD, and instead of using the label, let's change this to a visual element, and we'll just call this top bar. I'll just replace this here, and then we'll search for the top bar element. And so that will actually bind the parent element to our score manager as the data source. And then everything underneath it will then be able to use that data. What we'll do is we'll grab our top bar here. I actually want to space this out on the other side too. So we'll grab our top bar selector, And we'll also pad the right side by 25. So now there's kind of an even distribution there. And I'll grab the lives icon, and I want a bit more space between the icon and the label. So we could either make it wider, that might be fine if we set this to a width of 50. Oh no, that will actually scale it up. So what we'll do is we'll give a margin on our right of 5, and that just kind of separates it a little bit from the text there. And yeah, that should be good. I mean, this is only going to be one value, so let's just make sure that looks good at, a number. Yep, that does. I think that looks pretty good. And so now if we hit play, nothing happens. We actually didn't get bound there. Oh, okay, I see. I didn't change this to a visual element. It's trying to find a label. So when you see this error in the console, what that essentially means is that it actually can't find the reference that you're looking for. That's what null reference exception means. So when you're using something like get or find, a null reference exception is I haven't actually been able to find that, and it sort of stops executing at that point. And in this instance, we're actually trying to query for a label, and the top bar isn't a label, it's just a root visual element, so it fails. So we just need to change this to visual element, and that now should, hooray, there we go. Okay, we're bound again. So we have our lives and we have our ship, and we can fly around and destroy our asteroids. So now we just need to make it so that the player can actually get hit and lose some health. And then when they've lost all their health, we'll destroy them and then respawn a new version of them in the center of the screen. So because our ship actually extends from our bounded entity, we actually already have a health value, but we're going to want to be able to reset that health value to its maximum amount every time we reset our player. So we'll just update our bounded entity to support a max health value, which we will default to 1. And then in here, we'll make a virtual method where on enable, we'll just set our health to our max health value. Now we just need to detect whenever we get hit and lower our health. On our ship controller then, we want to detect a collision with an asteroid. So let's head in here and let's add a on collision enter 2D. So we basically just check if the object we collided with has an asteroid controller on it. So we'll call if collision.gameObject.tryGetComponent asteroid controller. So basically, if we collide with our asteroid, then we want to lose some health. Now, we should put that method that can lower the health in our bounded entity, because then anything else that wants to be able to lose health, such as our asteroids later maybe, can use that method. So in our bounded entity here, let's make a new method. We'll make it protected so that it can be accessed by its children. We'll just call this lose health. And then we'll set health lower. And then what we'll do is we'll make a method called if mHealth less than or equal to 0. We'll call on die. And I'll press Control period, and we'll generate that method for us. And we'll change this from private to protected. And we'll do override. Protected virtual void. And basically then our children can override this method and handle that process. So what we want to do is we actually want to go into our asteroid controller, and we want to move some of this stuff around. So this is now handled by our parent. So instead, what we'll do is when our trigger is entered, we'll call lose health, and we'll override our on die method and move this piece into there. And then we can remove all of these pieces. So we've now just sort of refactored our code so that we can sort of have similar behaviors just happen from one place rather than have a lot of our code copy and pasted all over the place. So then essentially we can kind of do the same thing with our ship controller. And so in here, if we collide with an asteroid, we'll lose some health, and then override our on die method. And for now, we'll just send a message to the log. So we'll call debug.log, and for the sake of it, we'll turn ourselves off. And so we should then see our player controller just completely disappear. So then if I just hit into this a few times, there we go. We hit into it too much and we died. So Now we just need to handle that actual event and reset ourselves, lower our number of lives, and then reset our player controller. So let's make a new event in our event system. So we'll go into game events, and then in here, let's make an event for our player. So we'll actually just make it a public event action. We don't need to pass any parameters. We'll just call it on player die. And then we'll make a method to invoke that event. And we'll just check if it's null. And if it isn't, we'll invoke the event. So then in our score manager, where we're listening to add score, we'll just listen for our on player die method too. And we'll just make an event for that. And make sure to unsubscribe here in our on disable method. And then just to keep things clean, I will move this down here. And so then we will lower our current lives. And if our current lives are less than or equal to 0, we'll just call a game over message. And so we just have to make sure on our ship controller here, instead of our little debug die, we just call game events.instance.onPlayerDie. And so now we send a message to our event system for our score manager to listen to. So now when we hit into things a few times and kill our ship here, notice how we've lost a life and our player has disappeared. So now all we need to do is get our player to reappear in the center of the screen when it's died. We'll actually add a little bit of a delay, so there's some juice to it, or it sort of feels a bit better than just kind of instantly respawning. But yeah, that's all we'll need to do. And then we have our little live system. So what we need to do then, instead of turning ourselves off, is essentially disappear for a little bit and reset our player controller. So we don't want to completely turn our object off because it will stop things from happening. We just need to sort of set it as disabled and not pay attention to any collision events or anything like that. So what we want to do is sort of temporarily disable a few of our components, but our ship controller needs to stay enabled this whole time. So up at the top here, we'll get a reference to our sprite renderer, which in our start method, we can get a reference to. And then what we'll actually do is, instead of turning ourselves off, we will disable our sprite renderer here. And actually, rather than put this in the ship controller, just to make things more uniform, let's put this in our bounded entity, because they'll all have sprites on them. And they actually will all have collision and objects on them. So we'll get a Collider 2D as well. And we will put this in the same place on our bounded entity as our other elements in our awake method. It just makes sense to put this all in the same place, keeps it nice and clean, and it means that our asteroids can do this too if we do ever want to disable things. So these are all protected, so we should be able to reference them in our child object. And then let's turn off our collision entity as well. And we'll set simulated to false on our rigid body so that basically we can't fly around while we're trying to reset ourselves. And we'll also add a Boolean in here called just isDead that will set to be true when we die. At the top of our update loop, if m_isDead, we'll just type return. And that'll basically say if isDead is set to true, don't do any of this stuff. So just don't do any other calculations. Let me just double check that this is fine too. Yeah, okay. So that's good. Essentially just stops moving completely whenever our isDead is set to true. So basically, if we play now, we shouldn't really notice anything very different there. But under the hood, we've now set everything up so that we can kind of reset ourselves. So then in here, we will start a coroutine, which will just give us some time to sort of move things, reset things, and give us a little bit of invulnerability time too. So what we'll do is we'll create a coroutine, and we'll call this respawn player. I'll just call this private. And on die method, we'll start our coroutine which will cool. And we'll give it a second. Let's say maybe half a second. We'll see, we might want to tune this. We'll then put our player at the vector 3.0. Basically just completely center our player again. Oh, okay, position, there we go. So we'll position our player at 0, and then we'll actually turn our sprite render on. And then we'll just wait another beat. And then we'll enable our rigid body again. So we'll set simulated to true, but our collider isn't going to be working. So we won't actually be able to hit during this phase. So we'll give ourselves a small amount of grace period. So maybe about 2 seconds, and then we'll turn our collider back on. But we should also make sure here to set is dead to false so that we can keep going. The one thing we also need to do is reset our lives, which originally in our bounded entity, we actually had this set in our on enable method. I'm actually gonna change this so that we take this out of our on enable method and put it in its own method. We'll just call reset health like that. And then on enable, we can call that there. And then in our ship controller, just as we reset ourselves completely, so this is our sort of resetting phase, we'll reset our health. So now that should be all we need to have our ship go back to its center point and reset itself. So I'll just try and hit a few things. Boop. And it didn't reset me, but it did make me lose a life. We'll need to set our velocity to 0. Okay, it didn't move, but nearly there. So what we actually want to do here is set the rigid body position, set the velocity to 0. Linear velocity equals vector 2.0, and transform.position to equal vector 3.0. That should now reset us into place. Oh, and we want to make sure that we're rotated correctly. So we should do rigid body dot rotation equals 0. So now if we hit into one of our objects, we can fly through and we get reset anytime we die. There we go. So it's our last life. And that's it. And then we hit the game over point. So this is pretty good. We've got the basics of our game loop in place. We have our player now has lives, and when they lose their life, they get reset and respawned. And when we lose all of our lives, we are detecting a game over state. So what we really need to do now is just finish that off and add a game over screen. So let's get into that and finish our game loop. Okay, so this is relatively simple. It's kind of just doing a lot of what we've done before. We're going to modify the heads-up display to have a screen that shows up when we lose all of our lives. And that's basically going to kind of pause the game and allow us to restart or just quit the application. So let's jump in. We'll just design that in our UI builder here. So in our container, let's drag a new visual element, and we're going to call this game over. And what we're going to do is we're going to set this to, in position here, we're going to set this to absolute and click this one here to expand to all anchors. And that's going to expand to all of the screen. And then we are going to just head down here into background. And let's just set this mostly dark, I think, for now. I think that'll be good. And that can be the little panel that pops up. Then we'll add another visual element in there. And we'll just call this something like center panel. And this one we'll set grow to 0. And we'll set the width to something like 500. And we'll set the height to about, maybe about 650. Yeah, there we go. That's good. Okay. And then what we'll actually do is we will set, just so we can see this, you can see this change. I'm just going to temporarily set the background color here. And then in our game over object, we're going to change our alignment here so that it aligns the items to the center and then also justifies the content to the center. So that's how we kind of center child elements. And what we'll then do is we will extract this class here on our game over. So we'll call this game over background and extract inline styles there. And then we'll right click and we'll actually unset the background color on our center panel here, because I actually didn't want a color there. I think this will be fine just with the black background. We could do something fancy and add an image and a gradient or something, but I think for now, this will just keep it nice and simple. Feel free to get creative in this place. Your UI doesn't have to look exactly like this. I'm trying to just keep this as simple as possible for the video. Cool thing about the UI builder is you can get really creative and you can diverge a little bit from what I'm showing you here. But basically what we want in our center panel then is just some text that says game over, and then a button that allows us to replay or a button that allows us to quit. So to do that, I think for now I'll just stick to a label. So I'll pop a label in here and we'll just type game over, set the color on our text to be maybe red or an orange. Ooh, yeah, something like that. Change from font to font asset so we're not all pixelated. And we'll pick the extra bold. There we go. Oh, that already looks pretty decent. And then why don't we mess around with some of the visuals here? We could give it a nice, you want to give it an outline, maybe like a yellow outline so it kind of stands out a bit. What does that look like? Oh no, that's not fantastic, is it? Maybe, or just a sort of darker orange maybe. Yeah, that's a bit better, isn't it? I'm actually just going to grab this color here and change the value, color, space. How far does this go before it starts to look insane? All right, I think 2 is the safe spot here. Okay, that looks good. I'm happy with that. So I will then add a style class here called game over label, and we'll extract that, and then we'll rename this to game over label. And I'm not actually a big fan of using the button controls because they come with a default Unity styling that's really annoying to unstyle. So instead, what I actually tend to do is just make my own visual element as a button. So I'm actually going to grab a visual element here and we'll rename this to be retry. And we will put a label in there like so. And let's call this, we'll just type retry in there and we'll style that in a moment. We'll just call this button label. And then what I'm going to do is do not set this to grow, and we'll set the, yeah, this should be fine now. We can sort of customize this a little bit later. So I want the button to look a bit like a button. Let's do a teal and orange, why not? But we'll set the border width to maybe 2 and a radius to 15. Nope, that's too much. Maybe 10. 5, just so it's roughly rounded. That's a bit better. Okay. And then we'll set the color to the same as this, but bring the value down. And then what we want to do is, let me just check our center panel here. Yeah, our center panel is set to stretch. So what happens if we, there we go. If we set this to center, so let's call this game over center and extract our styles there. So we're not sort of stretching everything to the edge. And then we'll set our retry button's width 230. Let's try that. And then bring the height up. Oop, no, not that height. Maybe about 45. I think that looks good. And then we can extract this, and this can just be button, because we'll reuse this style on our other element. Let's center our text. Yeah, oh, wait, no, let's set it as our font asset. And then bold. Perfect. Center the text like so. We'll set this one to grow on here so it actually centers to our label size, and then bring this up to about maybe 22. Yeah, that's good enough. I could spend a whole ton of time designing this and trying to make it look really pretty, but I think for the purposes of this video, we just need something that looks semi-decent. So I'm not gonna worry too much. I might mess with the color on this button a little bit. I'm not a huge fan of that blue. Let's maybe change the background color to be, I don't know, maybe maybe we just stick with the same sort of color. Maybe we just go with, I think that's probably better, isn't it? Yeah, let's stick with the orange. We'll just stick with the orange. And then that means we'll set this to be the same. What we could do is when the button is selected, we'll highlight it to be closer to that. So I think that's what it could look like when it's selected. So we'll just actually select the button color there, bring the value down a bit so it's a little bit of an edge, and then update our button label to set the text color to something. White is probably best for inside. I'm a little worried that that becomes unreadable. Maybe just slightly off-white. So let's select this and then push the saturation up. I think that looks fine for now. Yeah, that's probably good. Okay, we can have retry. Okay, cool. So then what I want to do is actually put a little visual element in here, and that can be our spacer between the label and the buttons. So then we have our retry button, and let's also duplicate that. Again, a lot of this is just kind of getting a feel for it. This is the creative part. We'll update our button class here to have some spacing. So let's give our button a margin of maybe 10 pixels, maybe 5. Yeah, 5 is probably good. Okay, great. And then let's update our text. We'll do exit to desktop. There we go. Okay, perfect. And then if we have a look here, our buttons kind of don't react to our mouse if we go into preview mode here. So we should just add a little bit of interaction logic in our stylings. And so that's kind of the cool thing about UI Toolkit is it gives you a bunch of visual animation and flair for free, which is one of my favorite things about it, because there's a bunch of transitions built in just by changing some stylings on assets here, which in the older UI system would have been much more difficult to do, and you'd have to kind of do a lot of that in code and by hand. Okay, so to style our button for a mouse over event, what we can do is we can actually just type button and then colon hover. And if we go in here, let's head into our border section and we'll grab our color here, and then let's set this as sort of a bright yellow. If we then click preview and we mouse over the button, notice how that causes our button to change color. So we've actually detected a hover event just like that. It's really easy to detect hover events and change how our buttons look. And because these two are sharing the same styling, it permeates that change across both buttons. So it would actually be quite nice if the text changed color too. So why don't we go into our text here? Let's actually extract this style to a class. So we'll call this button label and then extract inline style to new class. I'm just going to move this above our button here. And what we can then do is put this on this class too, button label. So these two now share. What that then means we can do is we can create another selector called button hover and then dot button dash label. And that then allows us to select for this hover state on the top button, but make a change to the lower label state. So find our text and change this to the same. We'll grab the color of our border here, copy this color format, so it's FC, we'll just copy that hexadecimal. And on our label, up in our text, we'll set this override to yellow. Now when we preview, notice how our text is then overridden. If you're getting weird behavior here, it's probably because the overrides are still there. So because we were overriding the text and we might have duplicated stuff. So if you end up in any weird situations like this, you can just right click and choose unset all. And that should now remove any of the local settings. And we can change this button label to be whatever we want it to be. So that can sort of be darker if we wanted to. Just make that obvious. I think that's fine though. I'm pretty happy with that. So then down here in our transform, why don't we actually scale the button a little bit? So we'll go 1.05 by 1.05. And then when we hover, notice how it gets larger. And it's cool that it kind of jumps to that, but what we can actually do is get it to transition nicely as we mouse over them. And so to do that, we just head onto our button class here and set the transition animation property and type scale. Click that and set the duration to 0.35. 0.35 for me is usually the sweet spot. And I think we'll just stick to ease for now. What that should then do, as you see, as we mouse over, we get a bunch of animation for free. So our game over screen has a nice animated state to it with basically no effort. And so what we can do is we can actually change what this looks like when we click on the button by setting this to active, and we'll change our border color to something lighter. Unfortunately, we can't actually preview this in the UI builder here. We have to do some stuff in code to get it to add that active state. but that's fine for now. We'll get this set up and it'll work once we've got it working in the game. So yeah, this is pretty good. The last little bit we should do, I think, obviously, is make this hidden so it's not showing up at the beginning of the game, because I think if we go right now into our game view, it's just showing up over the entire screen. So what we'll do is, one of the things I like to do is add a style class called hidden, and then just set this in the display here to none. And then we can just kind of add that hidden thing anytime we want to hide something in our menu, and always just bring it to the top here. So if we click on our game over visual element and we type hidden, that will now disappear into the ether. One of the other things I probably want to do as part of this so that it can fade in is we just set the opacity to 0, and maybe also put the transform. So for now, yeah, bring the transform down, maybe just by like 100. What that should let us do, if we go over here and click on our game over background, we can just set all of our transition properties to transition. And then if we add hidden to this, and then hit preview and turn hidden off, we can slide up the game over screen. And so then when we remove hidden in code, that will be what it looks like on our screen. So generally just play around with the transition settings to get the visuals that you like. You could add a delay to maybe the game over using stylings to get the game over thing to pop up. I'm not going to do anything like that yet. We might do that a bit later, but yeah, for now, I think this is pretty good as a game over screen. It will serve its function. So let's move on to making this function appropriately. Let's not forget though to add hidden as the default state for our screen here. Okay, so let's open up our HUD script and let's create a local reference here to our game over screen. Fetch our game over screen. And then what we'll do is we'll make a new event called on game over and add a way to dispatch that event. And then we'll listen for that event in our UI. Let's make sure to unsubscribe from this event when we disable our screen so it's not hanging around. And then basically all we need to do is set game over screen dot remove from class list and hidden. On our score manager here, when we have current lives is less than or equal to 0, we'll call game events dot instance dot on game over. And what we'll also do is we'll call time dot timescale equals 0. And that will essentially pause our game when we die. So then if we test this, drive ourselves into an asteroid, we should get a game over screen pop up. And we officially have a game over state. So the game's paused in the background, as you can see, and we can maneuver around our two buttons here. So then all we need to do is get one of these buttons, get the retry button to work and our exit button to work, and we have a full game loop. Let's not forget to reset our maximum lives here. That's one of the good upsides to being able to do things in your inspector, is that you can essentially manipulate things to test things quickly. And that's why you'd want to expose certain attributes. You can either just look at them while you're working and make sure everything's running okay, and then make changes while the game is running to potentially debug things a little bit faster. And so really it's up to you what you want to expose in the inspector there, but that's kind of why we might choose to do that. So really all we need to do now is get a reference to our retry button and our quit button in our menu and then make them actually do something. So we'll head into our HUD script. In here we'll grab our visual element called retry button, m_gameoverscreen.q, visual element, and we'll also fetch our quit button the same way. So in order to get our buttons to work, we're actually going to take advantage of something that's built into UI Toolkit called a manipulator. And these are basically just little pockets of code that allows us to handle specific events and behaviors on our UI elements. And you don't need to worry about them too much, but I just wanted to show this to you just to get a little bit of a basic understanding of it, where essentially there's just different bits of code that can kind of run on an object for you. And these are just kind of defined as the form of a manipulator. So for instance, the clickable manipulator, which we're going to add support for essentially being able to click something and then trigger an event off of that click. So let's add a clickable called retry clickable. And that's going to be a new clickable. And we're going to trigger a Lambda expression here. We've already used this before, but just to go over it a bit more, basically this is just a shorthand way of inlining a method. So rather than pointing to a specific method, we can kind of just do something inline. I generally prefer this with things like clickables or small actions. It lets you just kind of define an action while you're still in the same code space. You could just define an event called, you know, on clickable event or something here and do it that way. But you end up, I find that often I'm then calling a different event from this. So, you know, handle retry and then generate a method there. So it saves us kind of having to write an event just to write another event. So that's kind of why we do that. And then what we'll do is on our retry button, we'll add a manipulator and then add our retry clickable. And then in here on our quit button, we'll do the same thing. So we'll add another clickable called quit clickable. And in here, we'll make an event called on quit, which will turn into a method. Again, I'm just pressing Control period to bring that up shorthand. You can also just right click and choose quick actions in refactoring, and that brings this up and generates a method like so. So in our on quit method, we're going to do application dot quit. And then that just means in a build that will actually cause the game to close. So what we're going to do is we're going to write a little bit of code that will only be compiled in our editor version of this code. And it keeps it safe for when we make a build. So to do that, we're going to just put a hash key and we're going to type if unity underscore editor. And what this does, I'm going to also then do the same thing and type end if. What this does is it lets you put certain keywords in. And in this instance, it means that this code is anything within this block, this if and this end if, is going to run only in the editor compiled version. What that also allows us to do is it stops, it means that the build will safely build. Because if we start putting editor code in an application, a piece of the application that is trying to run at runtime, it's going to cause a conflict because we're not shipping the editor components of the code in the compiled version of the game when we release it. So if you're doing any editor coding inside of sort of gameplay code, you want to make sure that you can wrap it around in this. Generally, there's other ways of getting at this, but this is just mostly for ease while we're testing. So in here, we're then going to do Unity editor, and we'll get access to that namespace, which again only compiles in the editor. Dot editor application, and then we go exit play mode, and that will stop play mode. So then in our retry event, we're going to make a new game event called on retry. And we'll make an event to dispatch that. And then in our HUD, we're going to call that event. So we're going to call gameEvents.instance.onRetry and handle that event. So the reason we're using this clickable is because one of the things that comes with it is that click state that I showed you earlier in the HUD. So let's just give ourselves one life again. And let's just bounce into something until we die. Okay, so now when I click this, okay, actually I just realized that we have renamed these wrong. Yeah, our button names are wrong. So if you spotted that before I did, congratulations. So let's just go in here and update the quit button here. So then if we go in here and play, you can see that active state now gets executed. So because we've added that manipulator, our retry button registers the click there. And we can change the state of the button based on that click. So we get some feedback for clicking the button. So now all we have to do is actually have the game over screen go away and clear everything and reset everything whenever this action is called. Let's also just add that clickable to our quit button. And what I'm actually going to do is I'm going to just organize these a bit. So what I tend to do is I sort of group the functions together. So now all of our sort of clickables. And so that's kind of just a little bit cleaner, I find. So we now need to basically go through all of our scripts and have them pay attention to that event. The first thing we'll do is in our HUD, we will hide our game over screen. To do that, we'll just add the hidden class back in. So I'm just going to kind of copy that bit of code. We'll add to class that's hidden. So now the game over screen will go away. In our score manager, we'll add an event for that on retry, So let's just pop that at the bottom here and make sure that we unsubscribe from this. And then in here, we will reset our timescale and we will clear the score. Okay. Then in our ship controller, we will override the onEnable method. And let's actually just go in our bounded entity and make sure that we can override the onDisable as well. So then in our ship controller, we'll subscribe to both of those. And here, we'll call GameEvent.instance.onRetry. Now, we can basically just call respawn player, but we kind of still want the coroutine to happen. So we'll have to make an event to do that. So we'll have to do plus equals, and then I just hit tab here to insert this, and we'll just call this onRetry. And then let's make sure we call base.onEnable as well. Same here in onDisable. And then we'll select our game event, pop that in there and unsubscribe. And then on retry, we will just start our coroutine to respawn the player. So what I want to do is I actually want to use this code in here too. So let's move this into its own method. We'll call this set player as dead. And then we'll grab these and we will put that in there. We could call this like disable components or something, or disable components and set players as dead. I like to make sure that my method names are descriptive of what they're doing, because, you know, while you could write comments everywhere, if I just want to get into this, being able to just look through the methods and be like, oh, that method makes sense. You know, there's more verbose and descriptive they are, the easier it is to understand the code. And when I come back to it 6 months time and I'm trying to remember what the heck I was doing. So try to make it as descriptive in your names as possible. But yeah, so we now can call set player as dead, which means that then when we retry, we can just make sure that everything is kind of cleaned up. And so our score manager should reset, our ship should reset, and the only thing we need to do then is kind of wipe all of our asteroids. Our asteroid manager handles all the spawning, so we can kind of just subscribe to it in there. So in our start method, in fact, let's do this on enable and on disable. So on enable game events.instance.onRetry plus equals on retry. And then on disable, we will unsubscribe this method. And what we'll do is on retry, we will clear out our existing asteroids. So what we can do is call for each transform t in transform. That basically grabs all of the children in our transform component. We can call destroy t.gameObject. And then we'll start the initial asteroid spawning routine. And what we can actually do instead of repeating this is just call on retry here instead. Because if you remember, we're constantly calling our asteroid spawner. So what we actually want to do is also pay attention to the game over state in here. And let's just move this. And let's also just move our retry method as well. And so then what we want to do is basically when it's game over, we want to make sure that we don't continue our spawner routine. We just kind of cancel that. So what we should do is we could get a reference to that routine, but I think it's fine in this instance just to call stop all coroutines. If we did want to make a reference, we could make a local reference to a coroutine and then assign that like that, and then we can call stop coroutine specifically on that one. But you know, this script is kind of only doing that. So yeah, so that should then allow this. And we also want to reset our current asteroid count. So where are we? Current asteroid count. So we need to set this to 0. And that should allow us now to restart the game. Let's take a look. There we go. And I hit retry, and the asteroids have spawned, and we respawn. We're back to 1. So let's try and get some score here and see how long I can last. Let's just shoot these bullets around. And then I lost. We got a score of 23. We hit retry. It resets everything. And that's it. We have our game loop. Yeah, so from here then, we really are just going to work on some additional game loop stuff. We can probably improve the asteroids a little bit. There's a bit more of an incentive to get the player to move around because they're not super threatening right now. So I think we could add some kind of collectible that moves the player around the map and makes them need to avoid these asteroids. And I think we could make the player controller a bit more interesting to play with and make it a bit more acrobatic. Once we've done that, we can then, I think, really start to punch it up and add some juice to the game with some visual effects and some shaders. And once that's all done, we've pretty much got the last little bit, which will be adding in a menu to sort of package this thing as a piece of software before moving on to the last bits, which are obviously sound and music, and then getting the game out of the Unity editor and into something that people can be sent or you can upload and people can play. So yeah, let's jump straight into making this a more polished product, shall we? Okay, so there are a few other things that we can do really to improve the game at the moment. What we have is fine, but you know, part of game development is really just sort of getting a minimum sort of product together, testing things out, and then just kind of iterating on that. And, you know, the first pass of things that we've done here is more than acceptable. But I think there's just a few things we could do to spice things up a little bit and maybe tweak a few things to change how they're working and just kind of improve the experience a little bit better. Because I think it's important to highlight the fact that you can implement it like 80% of the way there, move on to the next thing, and then come back and refine it once the other components are in place. Because 2/3 of the time, when you're developing a component or module or design element or mechanic in isolation, it might feel amazing, but then in context of everything else happening around it, you start to realize that the thing that you've decided to do doesn't work. And that's also why spending a ton of time on one thing is just not necessarily a good idea, because it's kind of wasted effort until you get the bigger picture. So that's kind of what this section is about, really. It's just sort of making some tweaks and fine-tuning some things, but also adding some additional context to the game with an understanding now of the sort of core components. So let's get stuck into doing that. So I think the first thing I'm going to do actually is just refine our asteroids component a little bit better. I think right now they're spawning in the center and it looks a little bit weird. We'll probably do better to have the asteroids spawn from outside the game screen. So we could expand their sort of boundary a little bit more and then have the spawner spawn them sort of on the edges and then push them in. I think I also want to give them a bit more of a constant momentum because it's pretty easy for them to just kind of sit and hang around a little bit. And I think really we should have them flying towards the player, giving the player something to dodge and avoid. So we probably want to give them some more constant momentum. And that's really just kind of an observation of what we've got right now. I think if we have a look, you see they all kind of just spawn from anywhere. They can sometimes spawn from where the player is, and that can cause a little bit of an issue. But they're also just moving kind of slowly and not really that dangerously. So yeah, I think we could do a little bit more. And then obviously when they sort of hit into each other, they then just slow down here. So there's a few things we can do. I think just giving them each a direction and then just a constant momentum in that direction, at least will give them a bit more energy and make the whole thing a little bit more interesting. So let's go ahead and do that. So what I think we can actually do is essentially pick a direction. So top, left, bottom, or right, and then spawn relative, so sort of somewhere relative to that. So let's say we pick the left side, then we sort of randomly pick a point from the top and bottom and then spawn our asteroid there. So we're going to update our get spawn point random and we're going to pick a side. So we're going to do int side equals random dot range 0 and then 4. And the reason we pick 4 is because the random modifier on an integer doesn't include the top bounds. So this will actually randomize a number between 0 and 3. It's just something to know about the way that Unity works. It does tell you when you type it that max is exclusive, but when it's a float, it's inclusive. So just keep that in mind. That's one of the biggest gotchas in Unity. This is really useful for when you want to sort of pick something out of a list. So you can just do list.count and it will always give you an index of something relative to the list size. So you'll never get an incorrect index. That's, I think, the intent of this method. But yeah, it's just something to keep an eye out for. So basically what we can then do is we can create a switch. Let me just comment this out for now. And we will just, so we don't get errors everywhere, we'll just copy this. We can switch on side, and basically 0 is left. So case 0, 1, case 2, case 3. Actually, let's go up. Let's go clockwise. We'll go up, right, down, like top, right, bottom, and then left. Okay, then what we can do is we can, let's bring our spawn point up here. In fact, let's actually remove this, and we'll just go new vector 2, and we'll just do x, y, and then we'll make 2 floats up here called x and float y, and that just makes things a little easier. So just to stop getting errors, we'll set these initially. That will be fine. Okay, so at the top, what we want to do is pick a random location along the top. So we'll do x, and we can do random dot range, the same as before, and we can do what was it? Spawn area dot x min, and then we can do m spawn area dot x max, and so that will spawn anywhere along the top. And then y can just equal m underscore spawn area dot y min. That'll be the top. No, it'll be max, because y plus is the maximum in Unity. We start from the bottom left, so y up is going to be y max, and that should give us a location. And then we can kind of just copy this and then change the values as we need to. So we can do this on our right hand side. So this will be spawn area dot x max, and then anywhere along the y. So we want to do y min and y max. And then we can actually just copy these then for the bottom. So we can go bottom down here and change this to y min. And then for the left, we can grab this one and change this to x min. So now that should spawn our asteroids sort of within that square location. So we have the spawn area set differently, but you can see that now it's actually spawning within that sort of square location. So that's working as intended. We now just need to sort of make that spawn boundary much bigger. And so let's take a look at our asteroid. These guys are prefabs. So they're all picked from the large one. So we should be able to just set large O1 and it will update across everything. So their bounds are -7. So what we're going to do is we will copy that rectangle, go back for now and just paste that as our spawn area. And then we actually just want to expand these a little bit. Let's just keep it clean. We'll go -100 by -50. And let's just bring these up to 150 and 100. And that way they can go off screen a little bit and then come back. And that adds a little bit of intensity. Maybe there's nothing on screen for a bit. I think that'll be fine. So now we should get our asteroids spawning from the outside of the screen instead. And I think that's much better personally. They sort of come into existence now. So yeah, I quite like that. Next then, let's give our asteroids a little bit more momentum. So I think if we head over here into our asteroid controller, we probably want to just give it sort of some constant momentum while it's alive so it doesn't just get stuck spinning around in the center. So that's pretty easy. Let's just go into fixed update. And we'll essentially just, instead of doing this in the start where it has just one initial force, we'll just give it a constant force. So we will pick our direction first. So let's, why don't we do this? We will pick our initial direction and then just whichever way is our up direction, our forward direction in 2D, we'll just continue moving in that direction so that if it does start to spin around, it can kind of just continually have momentum in that. If we hit it and it changes direction, we kind of don't want it to fight against that and then just kind of go the other way. So probably let's try. This might work, this might not, we'll find out. So let's do this. Let's go vector 3 direction equals transform.up. So keep in mind that's the local direction. Vector3.up would be the world direction, which would always be that way. But if we're facing a different way, we'll be that way. So it just allows you to figure out whatever the sort of forward direction is relative to the object. And then what we do instead of this inside unit circle, let's just add a force to the direction. And let's make a new one, which we will call constant power. And then we'll add that here. And we don't really need this angular power thing, I think. Let's see what that looks like. Maybe that's better. So then our force power is 10. So let's set our constant power to maybe 3. And let's see what that looks like. Might be a bit too much. Okay, because we need to multiply this by the time. So let's just bracket that and then go time.delta time. There we go. There we go, much better. This feels a lot more like an asteroid field now. This is great. There's sort of just constant power, a little bit of fake gravity, way, way better than it was before. Yeah, this is great. Okay, I'm really, really happy with this. I think this is good. We could make all of them have different ones. I think I'm gonna turn the angular power down so they're a little less spinny. So let's set this, maybe let's half this. Keep in mind, you can do mathematical equations in the box here. So we'll just do divided by 2 and that will then work. And let's also just set the constant power by 2. So we'll just do divide by 2 as that as well. And then we'll double the initial power so it has potentially more momentum. So let's set this to 30 and that can just give it an initial velocity. We should be able to see what's going on. So yeah, some of the asteroids are doing things outside of the screen. I think that's fine generally because they will sort of eventually circle back around. But yeah, I'm pretty happy with that behavior. Now, theoretically, you could have different difficulty models. We're not going to, that will be out of the scope for this tutorial, but that is probably a really good way to make this more interesting and more challenging, is the have a difficulty level setting, and that would potentially increase or decrease the amount of asteroids that are showing up. And then you could have different scores for that kind of thing. But for now, let's just stick with this. I'm pretty happy with this. I think it's way better than it was, and they're not just sort of spawning in the center anymore. So yeah, this is great. So with the asteroid behavior improved, I now want to make the player's intent a little bit more clear and give them a bit more reason to fly around, because it's pretty easy right now to just sort of stick in one spot. So what I'm thinking we can do is, when we destroy an asteroid, every now and then, sort of there's a chance that it'll drop one of these orbs. And one of these orbs could be worth a point bonus. So maybe it's worth 50 points if you pick it up. That would then cause a few of these to be scattered around and force the player to need to move around and potentially get hit. So there's a bit more of a challenge to the game loop. So why don't we take a look at how to do that? Let's start then by dragging our orb into the scene. And as you can see, it's up here. So we do want it to be hidden by everything. So I think it's fine there. Let me just take a look at what that looks like. Yeah, I think that scale is okay. It should kind of just be like that, I think. We could maybe make it a tiny bit bigger. Let's see if we scale this up, how... Okay, yeah, maybe about 1.5. I think 1.5 is a good scale. That's pretty good. And then let's turn this into a prefab. So we'll just call this pf_collectible. Drag that into our prefab. And then what we can do, we can just delete that from the scene right now. And then on our object here, let's create a new script. And this can just be called collectible. Let's call it collectible controller. I do like to use a suffix that explains what the script is doing. So this is the collectible controller, score manager, ship controller, and then just at a glance then you can tell what the intent is of the script. The only bit that we've broken for that is bullet, but it kind of is the one script that is controlling the bullet. So that should really be called bullet controller, but that's that's fine for now. This script is going to be super simple, so let's just put a score value in here. So we'll call private int m_score, pickup score maybe, that's a bit better. And let's serialize that because we want to be able to set that in the inspector. And then what we'll do is we'll call public on trigger enter 2D. Then we'll do if collision dot try get component out ship controller. Then that means the ship has entered us. And what we can then do is call a score event. So we'll call game events dot instance dot add to score our pickup score, and then we can just call destroy and then ourselves. So that's pretty much it. That's our collectible controller ready to go. Now we just need to spawn the collectible when the asteroid blows up. In our asteroid manager, let's create a reference down here to our prefab. You could have a list of collectibles that you want to pick up. For now, we'll just stick to this one, but as I'm sure you can see based on how we did things with the asteroid prefabs, you could maybe have a list of collectibles and they would have different scores attached maybe, and there would be different sort of, maybe there's different behaviors where maybe it starts to move, that kind of thing. But for now, we'll just drop it in its one location. So we'll get the collectible prefab, and then when we destroy an asteroid, what we want to do is spawn spawn collectible, and we'll make that into a method. And then what we'll do is we'll basically roll a dice. So we'll call if random.range is between 0 and 1f, and that's greater than 0.5f. There's literally just 50% chance. Then let's game object. We'll want a position to exist, so let's put a position in here and then get the asteroid that died with the asteroid point. So let's pass that into there, and that's where we'll spawn our new one. So we'll make a collectible equals instantiate our collectible prefab, and we'll put that in our self. We'll set the position as our position here, and that should pretty much be it. There should now be a small chance of this collectible spawning. The last thing we need to do is actually add the collider to the collectibles. So let's go in here, open our collectible, and then we'll just add a collider. And we can just add a circle collider 2D, nice and simple. I'm going to hold Shift and Alt, and I can then bring in the full radius. I'm actually going to bring it in slightly smaller, so you actually have to go over the center of it to pick it up. You can't just sort of go over the glow here. We just have to make sure to check is trigger up here. And then let's also make sure to add our collectible script up in here too. We'll set the pickup score to say 50, and then we'll select our asteroid manager and make sure to assign our collectible prefab here. So we should be able to shoot these guys. And as you can see, we've dropped our collectibles, and then we can pick into them, pick them up, and increase our score. Okay, so this is much more challenging now. I think it's way more interesting than we had even just a few minutes ago. And you can see how just by tweaking a few things, balancing a few things, changing some numbers around, and really just playing the game and play testing the game and getting a feel for sort of how you want it to play, you can really make small improvements and get a completely different experience. And yeah, so I'm really happy with how this is starting to feel now. We have a bit more of an incentive to fly around and pick things up. And there's a little bit more of a challenge to it. So I think the final thing that I want to do is add a boost to the player so they can press a button key and get an increased burst of speed to maybe be a bit more nimble and a bit more acrobatic and get around certain things, and really just sort of make that a bit more of a risk reward scenario. So in a pinch, you can maybe fly around, but then you lose a bit more control. So to get started then, let's add a new input into our input system. So let's click our input system asset here, click edit asset, and then we'll go in here and we will add a new action. Let's click this plus button here, and we'll add a new action called boost. We'll want to detect whether the button is pressed or not, because if it's being held down, we want to boost the player. And so we'll change this to a value, and then we'll set in our bindings. So I want this to be the shift key. So I'm just going to hit listen here and hold shift. And I'm going to select shift on the keyboard and set that to the keyboard and mouse. And then I do want this to work on gamepad. So I'm also going to hit plus here, down here, and choose add binding. And then I'm going to pick gamepad. What would it be? Maybe let's do it trigger, because we're going to be moving with our stick. So we'll press the trigger for that. So we will do gamepad or right trigger. There we go. Let's do that. Okay, and then set that to the gamepad control and choose save asset. So now we should get a new method on our player controller here. We click on our ship. We should have a new method message called onBoost. So let's head into our ship controller and handle the boosting. So we'll make a new method called void onBoost. That will be our input value. And let's copy our isFiring method. We'll paste that there and we'll call this M is boosting. And we'll do similar things. So if value.getFloat is greater than 0, we are boosting. Then what we want to do is add basically have two values. So we need a max boost value and then a just a normal max value. So we'll keep this as max speed. We'll go serialize field, private float m underscore max boosting speed. And essentially we just need to detect if we're boosting or not. We should probably also add a boost power to boost speed. And ultimately we're kind of just copying what we had, but just giving it more momentum. So in here, we can detect if we're boosting or not. So in our forward input, if boost m is boosting, then we do one thing. Otherwise, we will do another thing. So we'll go across here and we'll just copy this and we will multiply this by our boost speed instead. We could theoretically sort of move this up here so it's always applying, and then we add an additional force when we're boosting. That could also work. If we wanted to do it that way, we could. That's fine. I like the more defined version so that when we're boosting, there's a sort of fixed cadence to it, but it's kind of the same thing. So really, you get to choose based on your taste how you want to get that to look, but I think this is fine for now. So yeah, we'll have our boost speed there, and then in our maximum speed, basically want to do if is boosting and we are above our maximum boost speed, then we essentially just bring ourselves down to our maximum boosting speed. And then we go else if we're not boosting and we're above our max speed, then bring us down to our max speed. So then we just have to set what that is. So our maximum speed is 25. So let's set our max boosting speed to maybe 40. And let's actually bring our max speed down to 20 so it feels a bit better. We'll also bring our move speed to 100. Let's make this 130. And let's set our boost speed to 200. I think that will feel significantly better. So now let's hit play. And if you see, if we hold shift, what we get is boosting. And then what we kind of want to do is if we're holding shift, we kind of just want it to boost in whichever direction we're facing. So we don't need to press up, I think. So let's do that. Let's bring this out of here and just put this there. So now no matter what, if we're boosting, then we do just add an additional force. I think the boost speed can just be aggressive, so it feels really fast. So let's maybe just set this to 2000. And so just whenever we hit shift, oh, it doesn't seem to work. We actually don't need the forward input pressed, and it just goes when we press our boost. So basically if we're boosting, we just, no matter what, we just move forward in whatever direction we're facing. Now then, we should get a burst of power anytime we press shift. And so I can just hold shift down and we get a nice boost. So I can kind of just nip around with a shift button, slow down, and yeah, we got a nice little sort of boost component there. And I can kind of boost in any direction. I can be nimble around. And you get a nice tight kind of control there. That's much better. That's cool. And it's sort of more responsive, and we can kind of spin around and gets us to do some cool things. It might be a bit too fast, to be honest, but it gives you that slight danger that you're going to hit into something if you're not careful. But that's just adds a little bit more acrobatic nature to the game, and I think that really elevates it. So yeah, I'm pretty happy with that. We can obviously tweak the values as much as we want, but yeah, that's good. So we've improved our asteroids. We've got orb collectibles that we can pick up when we destroy our asteroids, and we now have a boost mechanic for the player. So that's sort of how you can elevate different parts of your game once you've got the main pieces together. But there's still a few things missing. So visual effects can add a lot to your game, and here's just an example of what that means. It's usually a sort of particle-based system that can be all sorts of things. We can have smoke, we can have fire, we can have wind, projectiles, blood, sparkles, all that kind of thing. Like there is a plethora and just an endless array of things that visual effects can do to elevate your game, and different use cases for different things. But at its core, they're particle-based systems. They're essentially made up of lots of sort of sprites that are rendered on the screen and transformed in some way or another to create the illusion of a larger system. So smoke, for instance, might be a bunch of transparent sprites overlaid on top of each other, moving in a certain way to give the illusion of smoke, but actually it's just a bunch of sprites instanced in a specific point that can then layer on top of each other to create the effect you need. So there are actually two particle systems that you can be using in Unity. There's the built-in particle system and there is the visual effect graph. Now, each of them kind of have their own pros and cons. Generally, the visual effect graph is newer and a little bit better, but it's a little bit harder to get into. However, for the purposes of this tutorial, I want to dive into it because I think it's important to give you the basic understanding of how it works and because it's more sort of forward thinking. So the built-in particle system is simpler to use. It's mostly controlled from the inspector, but it's pretty simple and you can't quite get at certain things very easily. Whereas the visual effect graph is much more customizable and it's sort of node based. So I really just want to dive into that because it will give you as a beginner a bit more of understanding of certain parts of the Unity engine that you might not be familiar with. And I think if we just did everything through the built-in particle system, we'd just kind of be rehashing some of the same techniques. Whereas the visual effect graph will allow us to sort of explore more interesting things and will sort of act as a basis for the next section of the video that we're going to talk about. It's sort of the more flexible solution and allows you to do a lot more creative things, especially when you get into working with shaders and shader graph, which we will be exploring a little later in the video. So let's add a visual effect graph to our scene here. If we go here into the hierarchy and we choose effects, you can see that we can add the legacy particle system. So that's this one here, and it's just a bunch of sprites, as I said. And yeah, it's pretty simple to use. You can use this if you want, feel free. It's does what it says on the tin in design. So, you know, you just can mess around with all the settings and get the results that you want. But yeah, I really enjoy using the visual effects graph because again, it can stack to be quite a powerful tool. If you've used geometry nodes, or the shader nodes in Blender, then you'll be a bit more familiar with that workflow. If you've ever really used a node-based workflow before, that's what Visual Effects Graph is using, but by default, it doesn't come installed on Unity. So I'm gonna introduce you now to one of the core components of Unity that we haven't explored up to this point, but it was irrelevant up until now, is the package manager. So Unity doesn't ship with all of the features that it has available to you. It kind of, the template you choose makes the assumption that you're going to want a certain type set of configurations installed. But every now and then you need more things to come into the engine, and you can get at those through the package manager. You can get there quickly either by clicking on this little asset store link here and choosing My Assets, and that will open up the package manager for access to things that you've downloaded from the asset store. As you can see, I have a few of them already here, including visual effects. So you can also get to it by choosing Window, Package Management, Package Manager. And that opens up the package manager. And then if we look in the project, you can see that we have a bunch of 2D packages already installed and assigned to our Unity build. And this is always on a project basis. So when you pick one of these, it won't install that package across all of your installations. So they're kind of separate from the Unity installation itself. These are packages locally related to your project. So in this project, we have all of these installed, but we want to get access to the visual effects graph. So what we can do is search in the Unity registry. And if we click here, we scroll down, you can see all the things that exist. There's multiplayer, there's localization for changing text into different languages, there's leaderboards for multiplayer things, more complex tooling, VR support, XR support, post-processing, all sorts of things. But today, all we want to do is grab the visual effects graph. So we'll scroll down here and we'll choose visual effect graph, and then we'll click install. And we'll wait for it to install. They actually provide a ton of samples to you that you can import if you want. There's additional assets to use. We can maybe grab that. Different events and some learning templates. If you want to take a look at these, I definitely recommend the learning templates. There's some great behaviors and it will give you a basic understanding of the things you can do in Visual Effect Graph. We're not going to do that today, but definitely worth exploring if you're interested. However, we will grab these additions because I'm sure they'll come with some sprites that we can use. So, okay, once you've got Visual Effect Graph installed, we can start working on our first visual effect. So we want to do a few visual effects. I think we need to do an explosion when the asteroid gets hit. It would be probably quite nice to get some bullet hits, maybe some smoke or something on the asteroid when it gets shot, and probably an explosion when the player dies. So that one's going to be probably the easiest one to do. So let's do that one first, and then we'll move on to some of the others. Actually, before we do that, we can have a look at the visual effects because we downloaded those samples. So let's have a look at this lightning effect here. So you can see it's doing this cool kind of lightning strike down this route, and we can open up this effect, and it's a bunch of nodes to define how that works. We'll go into this in a bit more detail, but yeah, check out some of these samples, these prefab samples here. Here's the smoke sample. That one's probably pretty good. It's kind of small. But doesn't this look nice? It looks so realistic. Really like that. How are they doing that, actually? Let's have a look at that one. It's using this wispy smoke effect, which is a pretty high quality, it's actually flip book. So it probably is animating across these, and then it's just layering all these on top of each other. So that's pretty neat. It gives you a very, very realistic looking smoke effect. So let's create our first effect. Will just be a nice sort of explosion effect when the player dies. So in our project, let's create a new folder called visual effects. And in here, let's right click and choose create visual effects, visual effect graph. We'll get this create new asset wizard that pops up to just ask us what kind of template we want to start with. You can install some of the learning templates to have a bigger list here, or pick one, or you can just start with an empty one. I actually think we mostly can just take advantage of the initial burst, because I think when we explode, just a burst of particles is probably fine. So let's do that one, and we'll call this ship death effects. What we can then do is just drag this into the scene, and there we go. This actually is probably good for a sort of bullet hit, which we can maybe reuse this in the future. So over in the inspector here, you'll see that this has created a visual effect for us with an asset template. So we can actually put any of these assets into this part of the script. And you can see here, we could change this up to some of the ones that already exist. That's the smoke one, there's a flames one. And yeah, ultimately these two things are separated. So the asset itself is going to contain all of our logic for the visual effect. And then this is more of like an instance of a visual effect from the template data. Right now, that's all we kind of need to know. So let's open up our ship def effects. And then I'm going to bring the scene view down here so we can at least kind of see it while we're working on it. Okay, so this seems overwhelming, but it's pretty straightforward. Essentially, you don't need to get too worried about this. A lot of the time, it's just kind of experiment with things and see what happens. But the basics of it is that there's an initial sort of trigger to spawn a bunch of particles. There's then some logic to create the particles in the first place, how they want to start. And then in the update, that much like our update loop, what do you want to happen every frame that the particle is on screen? And then there's the sort of, how do I render the particle? How do we want the particle to look? And so that's kind of it. And then you add different modules here to change those settings depending on what you want to do. So it's really that straightforward. And generally, this is the section of the tutorial where I suggest you really just play around. You can follow me loosely, but the more you play, the better you're going to get with this. And there's really no wrong way to do this. Get the explosion to look how you want. I'm going to probably just stick to something simple, but you can easily spend hours just messing around with all this stuff. So again, feel free to diverge as much as you want here. I want these particles to be nice and big and kind of just burst out in an explosion. It's honestly going to be very, very similar. And I do think this kind of color scheme is pretty good. I'm also going to lock this selection so we can keep it playing. So to do that, we're going to click on the ship def effects, and then we're going to lock the inspector here. And that now means that if we click something else, the inspector won't change. So we've got it static, which means that then this is going to continue to be selected and should continue playing our visual effect. So that will keep it running on screen. Okay, so there's no gravity, so I don't want the particles to kind of fall off like that. So what I'm going to do is delete our gravity node here and just delete that. Okay, so now that's better. Let's also add so this is a sphere. Let's bring this up. And that's pretty good. So that kind of bursts into a sphere. Make the lifetime a little bit longer. We'll go from 1 to maybe 3. Oh, that's better. Yeah, so it's like, okay. The drag is pretty good. I would like it to be a bit more aggressive. So velocity we can do. Min speed, let's set this to 3. Maybe 1, and then max speed, let's set this to 8. Maybe we'll set the min speed to 2. That's pretty good. Okay, so that's a lot more aggressive. And then we want our particles to be a little bit bigger. So to add a new node here, we're going to click on the particle center, and we can right click and choose, create block. or we can just hit space. I like to hit space. And then I'm just gonna, there's a ton of different things we can do. Often I try to just search for what I want. So we're gonna do size, and we're gonna choose set size, and that will set our starting size. So we're gonna set this to 1. I think that's pretty good. So we can zoom out now and see what it's gonna look like. That's maybe a bit too big, maybe 0.5. And then so we have our multiply size over life. And we can mess around with this to get it to look the way that we want. So this is a sort of curve, which from 0 to 1, that's the time. So from the start of its lifetime to the end of its lifetime, how does it want to react? And this is multiplied by how much. So we want to multiply by, it's its peak size at this point pretty early on, and then it fades out. Yeah, I quite like that. And then for me now, this particle is kind of too aggressive. So we probably want to multiply the color in alpha over life. And we want to start it faded out a little bit. So let's actually add a new element here, and then we'll click this first one and we'll set this alpha to 0. Okay, yeah, so I've gone for this sort of bright blue to this pink hue. I think that actually looks quite nice. Included in all of the assets for this project, there's actually a set of particles that I've created for this portion of the video. So feel free to pick and choose from any of those, or create some of your own if you are so inclined. So yeah, I'm gonna move away from this initial sort of dot that you get to use from. We could use a more sort of glowing one if I turn on soft particle. But I actually think this will be better if it's more like a sort of star kind of explosion. I quite like this particle 6, so I'm going to put that in there. And what I actually think we can do is add a little bit of rotation to these elements now that they're not circular. And that should probably be really all we need for this basic explosion. Let's go into our simple burst initialization, and let's just give the particles a little bit of angular velocity. So we'll go set angular velocity. We'll change this to Z because we rotate on the Z axis of the particle. And then let's grab a random float between, let's say, 2 and maybe 10. And then, oh, actually, let's go -10 and 10. And then if we plug that into here, we should now get an angular velocity, and it just sort of bursts out that way. We can probably go a bit more aggressive. So we can go maybe -50 and 50. And then our particles then kind of explode out into the center. So if we look at that in our game view, yeah, I think that's good enough. So right now our particles are spawning constantly. So we just need to make sure that this only happens once. So to change this, let's head up into our spawn system here and change the loop count from infinite to constant. And then we just have a single loop, and that means it will only fire and execute this spawn system once. We'll then change the loop duration. It doesn't really matter what you set this to be. It's kind of just what we expect the life to be. And then if we did want to have, 5 bursts in one go, we could change this to something like 5. And it's sort of what's the gap between each burst. So we could make this 0.5, and we could have it shoot a whole bunch all at once. That's where it could go, pew, 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 if we really wanted to. But I think this is fine. And then if we click here and hit play, you can then see it does those loops again. But yeah, like I said, let's set the loop duration to 1. When there's just one singular loop count, doesn't really matter. So yeah, I think 1 is fine. And if you wanted to add and change the amount of particles that we're spawning, you could do that here. There is a maximum capacity in the amount we want to initialize. So just keep those in sync if you want to keep those in sync. But I think 128, that is more than enough to get across what we need. So yeah, let's save that. Back in our hierarchy then, let's make sure that our inspector is unlocked, and we'll save this as our prefab. So we'll go pf_ship_def_fx, and then make that a prefab. And in our ship controller then, we basically just want to spawn that prefab whenever we die. So let's get a reference to the prefab. We'll put this here with our bullet prefab. We may as well. So a serialized field. Game object m_death VFX prefab, and what we can do is find our on die effect. We want to put our death effects in here, but I'm also just thinking ahead, and I'm thinking that we're going to want the same kind of thing for our asteroids, and they both share this bounded entity script. So let's actually put a spawn VFX method on our entity ship, and that way we can share this behavior across both of those objects. So yeah, we'll create a new method in our bounded entity called spawn VFX, and in here we'll allow it to pass a game object called our VFX prefab. Then we will create a game object called VFX, and we'll go equals game object dot instantiate VFX prefab, and we'll set the transform dot position to our position. And that's kind of all we need to do. So then in our ship controller, when we die, we can just call spawn VFX and pass in our death VFX. And then if we delete that from our hierarchy and then make sure that we go to our ship and assign our death VFX prefab, and then hit play. Let's just knock ourselves out here. There we go. When we die, our VFX spawn. The only issue is that, as you can see, it still hangs around in our hierarchy after it's been destroyed. So we want to create a script that our VFX can use, that when they've finished doing their thing, we can actually just kill them. And we'll basically just do this with a timer. I think it's pretty easy to assume that we kind of only want VFX to be on screen for a certain amount of time. So I'm actually just gonna, I'm gonna keep this here for now. So let's create a new script, which we will call VFX cleanup handler. And then on our ship death effect prefab, we'll open that up. And in here, let's add that VFX cleanup handler. Now if we open that script, let's create a private float m underscore current time, private float m underscore lifetime, and we'll just serialize this lifetime component. And then in our update loop, we'll check if current time is greater than or equal to our lifetime. And if it is, we'll call gameObject.destroy, and we'll destroy our game object. So it'll die and remove itself from the scene once its time has run out. And then we will just add the time between the last frame and this one to our current time. So basically every frame, the delta time will tick up, and eventually that will hit our lifetime limit and destroy our object. So, we can have it hang around for a little bit after it's finished. It doesn't need to be tight. So we know that this is probably going to be like 5 seconds or something, maybe 3. It probably doesn't even need to be that high, but 5 seconds just gives a grace period. There we go, like that. So this should then just destroy itself. So that's great. It now cleans itself up. So that's awesome. We have a little bit of feedback when our character gets destroyed that I think is way better than without it. Let's keep going and add a couple more visual effects. Something we could probably do is add a visual effect to our ship itself here so that there's some kind of feedback to us pressing forward on our controller. I think that would be pretty easy to do. We could essentially have input detection to turn on both a left and right thruster here, and we could thrust for when we're moving forward, left or right when we're turning, and then potentially for when we boost as well, we could get a specific visual effect for that. So let's add those in. So we'll create a new visual effect graph, and we'll make this one a simple loop, and we'll set this to we'll call this thrust effects. And let's open this up. Also drag this into the scene so we can see it in place. And let's put it on one of our thrusters here. And yeah, so instead of being pushing up, we'll just set the direction to -1. That's pretty good. And let's set our size and just to 1. Out of the gate, that's actually pretty good. That's kind of the effect we want. So we might just be able to manipulate this a little bit. Okay, so I've got this little particle here that's kind of glowy, and I think that would be really good for the thruster. So let's pop that into our main texture here. And then let's change the setting here to use soft particle and turn alpha clipping on, and then change the blend mode to additive. So these kind of stack colors on top of each other. And then we'll bring the alpha threshold down significantly. And honestly, I think that's really nice. So it probably just hangs around a bit too long. And maybe we go the other way. Let's see what happens if we reverse this. I think that's better. Obviously, it would then trail off like that. So yeah, I think that's pretty good. I quite like that. That's very good, actually. I don't think we need to do that much more, really. Maybe we don't make this a full-on swap of colors. We bring this down, and we put a color over here, and then a color over here. And we set this color to our sort of orange, and then bring that over. So then we can kind of decide how long it lasts based on how that goes. So yeah, I think that's pretty good. That's great. So then if we had 2 of those in our scene here, and they were side by side, that would be how our ship would work. That's honestly not bad. I'm pretty happy with that. As you can see here how quickly we can get visual effects working just by changing a few of the settings in our particle system here. Now, more complex graphs would stack different versions of these together. You could have multiple stacks of these loops, so lots of different things were happening. That's kind of out of scope of this, but I did just want to get you familiar with the visual effects system. I've actually got a tutorial on the channel of how to do a sort of comic book effect here in visual effect graph, so feel free to check that one out if you're interested to learn a little bit more about how this system works and to how we can stack multiple blocks and groups together. This is a very, very powerful tool, so I'm really just scratching the surface here, but as you can see, with just a few little tweaks, we can make some really interesting effects. So I think this looks great for when we're boosting, but I think when we're not, I'd like it to be a bit more reduced. And this is one of the cool things about visual effects graph, because we can actually expose properties in the inspector and have some conditional logic occur inside of our graph here to change values depending on properties. We can also then change and assign those properties in our scripts, which we'll do in a moment. So what we can do is when we're boosting, we can actually change our minimum speed and our maximum speed, because if you see here, if we change this to say 1 and maybe 3, we get a much more reduced burst there. So we kind of want those 2 ranges to change whenever we're boosting or not, right? So what we can do is add a new property here called bool, which we'll call is boosting. And then we'll drop this down and choose exposed. And then we'll create a new node outside. So we'll click outside here and we can either right click and choose create node, or again, we can hit space. And then let's choose branch and we'll drag our boosting variable out here and plug that into here. And then we'll plug this into our minimum speed and we'll set our minimum speed if true. So if we are boosting, our minimum speed will be 4. Let's just round that up to 5. If we're not boosting, we'll set this to 1. Then we'll duplicate this and we'll make true 8 and false maybe 2. And then plug that into the maximum speed. And then we'll just plug this into here again. And then we'll hit save. Now in the inspector, we should see in our properties area here an is boosting property. And what we can do is if we check this box, you should see how it then changes the speed based off of our setting here. So we've got a sort of conditional effect occurring in our graph. And you can see how powerful that can be. Essentially, we could pay attention to lots of different variables in the game, feed those into our graph, and then have the particles react differently depending on it. So we could have direction changes depending on the way that we're facing. We could have different impact colors depending on a certain variable that we might want to set in code. But for now, we'll just keep it as this simple effect where when we're not boosting, we'll just stick to this more reduced version. And then when we are boosting, we could do this more aggressive version. And I think that will look really cool. So let's set that up in code and get this to work on our ship. We don't need to really spawn these guys specifically because they're kind of just part of our ship scene. So what we can do is we can just drag these guys and put them in our ship. And then we'll call this thrust effects left. And we'll call this one thrust effects right. And let's start them off as not boosting. And then as you can see, if we go over here in our visual effect and we disable this, it will just stop, right? And then we turn it on and it will start and it will stop. If we wanted this to have a bit more of a slowdown for a cutout, we could do that. But I think for now, we'll just turn this object on and off depending on whether we're moving or not. So with these in here, we can head into our ship controller, go visual effect, M underscore left thruster, and then serialized field private visual effect M underscore right thruster. We don't really need to do a reference to the full game object itself. We really only care about the thruster. So then back on our ship, we can see our thrusters here. So then we'll assign our left thruster and our right thruster here. So we can enable and disable our thrusters with just a simple Boolean. So we can make a method that we can then just call depending on which thrusters we want to enable. So we'll make a method called enable thrusters and we'll call bool left and we'll make one for bool right. And then we will get our left thruster dot enable to equal left and our right thruster dot enable to equal right. Then when we move, if our forward input is greater than 0, we can enable thrusters left true and right true. Otherwise, we will set our thrusters to false. And we'll start with these guys disabled. So we'll turn these guys off. And then in our game, now when we press forward on our controls, we should be flying around. So down here in our onBoost method, we can get our left thruster and set the Boolean is boosting to whatever the value of our is boosting Boolean is here that we've set up here. And then we just do that and do the same for our right thruster too. Now they will both detect the boosting state. It helps if I spell boosting correctly. What we also want to do is check if we are boosting and make sure that we enable our thrusters and that if we don't have a forward input, that we disable our thrusters. And as you can see, we've got a little bit more feedback on our ship and it just looks a lot better. So I think the next effect then should just be a bullet hitting into something. I think we would have just a little spark to explode when we hit our asteroid. We can turn our asteroid life up then, so there's a bit more emphasis on hitting them. So let's create a new effect for that. And this one can be our burst effect, bullet hit effects. Let's open this up. And we'll just drag this into the scene so we can see it. The default effect is pretty decent. I do kind of want it to have that pushback this time. So having some gravity there is probably quite good. Like I don't hate that effect. Let's grab our prefab and pop the bullet in place and see how that would look sort of in place of the bullet. Yeah, that's pretty good. I think we can just tweak a few things here. I think we can change the color and let's just have it be white. Or the orange. Actually, the orange that the bullet is, I think would look good. Yeah, maybe orange to white. No, let's just have it as orange. Or actually, let's have it go from the sort of a yellow kind of spark to an orange. That looks really good. And yeah, I'm pretty happy with the size. Let's always bring this down to 1. I don't like that it starts at 1.5. That seems strange to me. So we'll do that to 0.2. And we'll make that kind of ramp up. And then a sort of soft ramp down. How's that look? Yeah, I think that looks good. Like that. And then let's change to one of our other sprites here. I think this particle would be better. It's kind of a triangle effect. And then we kind of want it to just point at where it came from. So what we'll do is we'll set our direction blend to 0.25. And then we'll also add an angle. We'll set the Z angle to about 40. And that just sort of straightens this up a little bit. And then what I think we can do, we can set the scale over life. And then what we want to do is with our X and Z components, we can make these pretty straight. And then we'll keep our Y component as a little graph here. So it starts at 0 and then gets to 1. So it kind of grows. And that just adds a little bit more variation to it. It doesn't have to be much, it's just a little bit of feedback. So it's kind of just sparking whatever it's hitting. And then in our linear drag, we'll use the particle size. And then what we can do is set size. And let's go up here into random. We'll turn that per component. And we'll go 0.15 to maybe 0.35. Maybe a little less. We'll go 0.2 to maybe 0.05. Just so there's a bit more variation across the board there on the sparks. And yeah, I think it's subtle, but that's probably pretty good for a bullet hit. It doesn't need to be too aggressive. It's just a sort of little bit of feedback there. Honestly, I might reduce the amount of particles. Bring this down to maybe, let's divide this by 4, maybe to 32. Yeah, we really don't need that many. I think it just needs to be a sort of small impact. We could maybe mess with the size a little bit. So maybe we do go with 0.3 and then 0.5. I think actually if we change this angle, the set angle to a random per component, and we maybe increase the B size to about 100 and set the A size to maybe 30. Doesn't look fantastic zoomed in like this, but when we look here, that looks a lot better, I think. So yeah, I'm pretty happy with that. I think that's good enough. So let's get that working in the game. So same as before then, let's turn this into a prefab. And we'll go into our prefab folder here and we'll drag that in. Then let's also open that up and add our cleanup handler. I mean, the lifetime of this one is so short that I think it can just be a second. It could be less than that really, but that'll be fine. And then on our bullet, let's have our bullet drop the hit when it is removed. So in our bullet then, we will create a reference. Let's create a reference to our bullet hit. And we'll make sure we serialize that. And then let's make a new method, spawn VFX hit. We can just call it that, that's fine. And then we'll just call this hit. We'll do gameObject.instantiate, get the bullet hit VFX, and we'll do hit.position.transform.position equals transform.position. And then just before we destroy ourselves, we'll spawn the VFX hit. It's important to make sure you do things before the destroy, because once the destroy occurs, the code stops executing. So we'll do it beforehand. Actually, we don't need the hit to happen there. We just need it to go here. So that's great. We'll spawn our VFX hit, and then on our bullet prefab, and let's make sure that we grab the bullet VFX hit. And that should then give us some feedback whenever we hit one of our asteroids. There you go. So it's subtle, but it definitely adds something, right? So it'll specifically look a little bit better if we go in here and we actually give our asteroids a bit more health. So I think right now everything just has 1. So what we should do is go in here and change our max health on our large ones to 3. So they have to take 3 hits each. And then our smaller ones can take 2. And then we'll set our small ones to 1. So now the larger ones will take a couple more hits to destroy. There we go. That's better. So I actually think we can make the larger ones even more difficult to blow up, because even 3 hits is probably still pretty easy. So let's grab our larger ones. Let's give those a maximum health of 10. And then let's give our medium ones a maximum health of 3. And then our smaller ones can have a maximum health of 1. So all that's left then is to add a little effect for when our asteroid actually breaks, because right now it just kind of breaks into nothing. And so it'd be nice to kind of hide that with maybe a little smoke effect. So the spawning of the slightly smaller one is hidden a little bit. Okay, so for our final effect then, let's create a new visual effect graph. And this one can be a loop. Actually, this one can be a burst. And we're going to call this asteroid death VFX. And we'll drag this into the scene and take a look at our scene view here. And then I'm going to make this nice and big. So we're going to set the size. We're going to remove any sort of gravity. So let's head into our graph here and remove the gravity component. I think we can set the drag to be about 100. No, that's too much. Maybe 2? Yeah, that's good. So that's like a puff of smoke, like that. Let's change our alpha settings over here. And we're just going to make this white. We just kind of want a puff of smoke, like so. Actually, we might go with a little bit brown. Like that's already looking pretty good. And they kind of stack on top of each other. And we could alpha oh no, let's go additive on that one. And then let's use our cloud particle. I think that's going to be good. And we'll use soft particle and alpha clipping. And let's set our alpha here to be something like 100 and 100. And actually, let's turn off the alpha clipping. I think for this instance, alpha is just fine. As long as we don't go fully opaque, I think that looks okay. How do we? Yeah, okay. And then I think our lifetime can be anything from 0.5, maybe like 1 to 2. And our speed, we're not going to give it a direction. Oh, it needs a direction. Okay, fine. And then we're going to give a speed of maybe 2 and 5. I think that's great. And our we can bring our size up, I think. It's nice and big. Maybe 5 and 10 to match our size. Yeah, that'll be good. That's roughly the shape we want. I think we kind of want, we're going to basically want to change this depending on the size of the asteroid. So we might end up needing to pass a number in, but I think for the first asteroid for now, that's fine. And then we want to just randomize our angle. So we want to set our angular velocity to kind of be anything. So we'll select this and we'll go per component, and then we'll set the Z value from -10 to maybe 10. And that should just give it a bit of rotation. We might want to go a bit more aggressive than that, maybe -50 to 50. There we go. And we could use the particle size, the drag coefficient, And then, yeah, let's set the coefficient to be slightly lower. Then it just kind of stays intact no matter what size we are. I think that's pretty good. Okay, I'm pretty happy with this. As I keep saying, you can play around with this as much as you want. This is the great part of doing visual effects, and this is the sort of fun, creative stuff to do in game design and game development. So I'm sure you can sort of toy and tinker with this as much as possible and play around with all these values because it's very tactile, and I really love that about making video games. But this is good. I think this is going to be good enough for when our asteroid explodes and maybe sort of hide the spawning of the new ones. So let's take a look at what this looks like when we get it to spawn. So just like before, we'll convert this guy into our prefab, and let's make sure to add our cleanup handler script to it. We'll give this a 5-second and pop this into our prefabs folder. And then on our asteroid itself, let's create a reference to our prefab. And when we die, we can spawn our death effects. And then in our asteroid controller, let's create a reference to our death effect there. And that should now propagate across all of them. Lovely. Obviously, as you can tell, the small ones being that big is insane. So we really need to make 2 variants of this depending on which size of the asteroids are exploding. The cool thing is we can actually just use our prefab logic to do this. So yeah, this is kind of crazy right now. And we need to stop them from looping. So actually, let's go into our asteroid death visual effect and let's go in and make sure that this is not set to looping. We'll set the loop mode to constant and we'll loop once, and there we go. That should fix that problem. It should only ever happen once. And then what we want to do is be able to set our sizes based on our particles. So we want to be able to change some of these values for the different prefabs. So we have our size component here. So let's make 2 properties. We'll make a property float called min size, and another property float called max size. And we'll go min size and max size and plug these in like so. And we'll set this to 3 and 4 by default, like that. We should just expose a lot of these as properties because I think that gives us a bit more control. So we'll create another float called radius, and we'll drag that there, and we'll set the default to 3 and assign that there. Another property, call this, make this a float, call this min speed, and let's duplicate that and make that max speed. And default there can be 5 and 25. So min speed and max speed. And then we can also do, so I think this will be important on the smaller ones. You can drag this over here and type float. And then I think you can right click on this and choose convert to property. And that will then make that a float for you. And we can call this amount, and we'll set the default to 256, and we'll set that to exposed. So now in our death VFX, we actually should have all of these available, and so we can change them. So I think if we check all of them, that turns them all on as, hey, pay attention to these. And so then when we play, we can actually change this based off of our instance. So we'll keep this one as is for now. We'll head back. And what we'll then do is we will go into our prefab system, drag our asteroid effect, and then we'll drag it back into the inspector and make a prefab variant. Sorry, back into the project and make a prefab variant. And then we'll call this VFX underscore medium, and then we'll duplicate that because it's now a variant, and we'll call that a small. What we can then do is go into our medium asteroids and put the medium version in there, and our small asteroids and put the small version in there. Then what we can do is put all 3 in our scene, and let's go into the scene view. So then we can change our medium one. So let's change the min size from 1 to 2 and hit play. How does that look? So that's okay, but it's kind of aggressive. So we'll set the radius to 1.5. We'll set the min speed to 3 and the max speed to 10. And then maybe set the amount to 128. There we go. So it's a little bit smaller. I think it's still too aggressive. So I think we can set the max speed to 5. And that's better. I don't know if we need that many particles either. I think we can maybe set this to 64. That's probably fine, honestly. And then this one, we can just kind of make this tiny. So min size 0.5, max size 1, radius 0.5, min speed 0.5, max speed 2, amount, let's go 32. Yeah, and then it's just kind of tiny. I do think the size could be better though. Maybe we do keep size pretty high, but it's just less aggressive. Okay, so I think we can keep sizes relatively big. So we can go 2 and 5 on that one. But just the space, maybe 1 and 3. But just the number and the speed. So this one's kind of huge. This one's a bit smaller. And then this one is kind of tiny with not that many. But that's the death. And I think that's probably all we need to do. So then to apply these to the prefab, because these are currently instance changes, we will just want to right click on these and choose apply to prefab, apply override in medium. And we'll just assign that to all of them. And then on our small one, we do the same thing and we just apply these into the small version. And so then our 3 versions, if we check in the inspector, should now have different values. And we can delete these, so we no longer need to see them. But if we play them all at once, there you go. They sort of all change size. And now, when we play the game, we should get an explosion, followed by sort of smaller explosions. And it's a little less insane. The game is feeling, a lot juicier, gives a lot more feedback to what's going on. And really, that's kind of the whole point of this section, is just to show all the difference that some visual effects can make. This isn't a visual effects tutorial, but it makes a difference. And so hopefully you can see that. But I think that's pretty much it for this section. I think, these 4 really showcase what you can do and how to do it. Obviously, feel free to add more, and maybe you've got some thoughts on what you could add effects to, things you could change. So definitely give that a go if that's something that you're thinking about. But yeah, we're nearing the end now. I think the game is starting to come together. There's just a little bit more feedback we can give. And to do that, we're going to dip our toes a little bit into shaders. Up until this point, we've been writing scripts for our gameplay code to run and execute on. And you can kind of think of shaders as code that we write for our graphics card to tell them how to actually draw our game itself. So they're incredibly powerful because they are the fundamental pieces of code that tell the game how to be drawn and what it should look like. But they can also be used to manipulate the way that the game is currently being drawn already. So we can kind of stack different shader code on top of each other to really change and add impact to how our game looks at any given point in time. So just to give you a brief overview of what shaders can do, there's a great website called Shader Toy, which you can look into to show you some of the cool things that you can create basically from scratch with just a bunch of shader code. Now, we're not actually going to write shader code, so this looks scary, but basically this is all happening because of this. There's no other program doing this. All of these visuals are occurring through this code that we see here and some various additional maps. And so it's really interesting to see the sort of thing that you can do. Often on Shader Toy, we see these more sort of procedural geometric patterns because maths, but then you get into some crazy, insane things like black hole rendering. And this is wild to me. So this just sort of goes to the potential of things that shaders can do. And really, once you start learning about them, you really get to see and dive into some interesting things. So it really opens up your world as to what you can achieve in your game. And you can create stylized shaders that make your game look like a cartoon, or you can create hyper-realistic shaders that specifically make things look good, or shaders that mimic the ocean, for instance. Just, often in video games, this is how an ocean is built. It's using a very complex shader to simulate water. It's a very, very powerful tool to do things like creating a rain. This is insane. There's clouds, there's a rainforest. This is all just done with shader code. But yeah, we're not going to go into that level of detail today. We're really just going to touch on the surface, and we're not going to be writing code. We're actually going to be using another node-based system, much like the visual effect graph, called Shader Graph. So we're going to start with a pretty simple shader that is essentially just going to be an effect that we can put on top of our ship when we respawn. And I'm thinking it's maybe just to try to highlight a sort of shield, and maybe it's kind of like a pulsing effect that will color the shield in and out. And again, you could do this with sprites, I guess, but we can layer lots of things on top of each other and add additional layers of complexity if we want to. So it's very compoundable and very expandable and very scalable. So I really want to show it to you for that reason. So let's get started and build our first shader. So we'll create a new folder here. We'll call this shaders, and we are going to create shader graph, URP, and we're going to go sprite unlit shader graph. And we're going to call this shield shader. We'll choose yes when it asks you to open upon creation. What we're then going to do is go over to our ship, just choose 2D object, sprite, and we can keep this as square for now. And then we're going to open our sprite. Let's make sure that this is drawn on top. So we'll go to additional settings, order in layer, and change that to 10. And then let's just scale this up. We'll click this, hold Alt and Shift, and bring this up to about here. So we have a square sprite like so. It looks great, looks interesting. Now, if you see here, we have a material which is sprite lit default. All of the materials in Unity are using a shader. So if we click this and we go to properties, we can see that it's using the universal render pipeline 2D sprite lit default. Because again, remember I said, shaders are just ways to tell the computer how to draw your game. And so the entire rendering system in Unity needs to be using shaders, and Unity just has a bunch of them built in for default for you to use to make things easier. You don't have to always make a shader. And so what this means is that we can actually manipulate a lot of these materials to use our shaders instead. So what we'll do is we'll right click, create material. And essentially a material is just an instance of a shader. That's all you really need to know. So it's just a way at which we can sort of pass data into our code, the sort of shader script that we're going to write and manipulate things, much like we did with our visual effects instance. A material is just kind of the same thing. So we're going to call this mat_shield. And then what we're going to do is we're going to click on our square and we're going to drag this onto our material. Now, basically, because we right clicked on this and created the material from the shader, it has automatically assigned it to that shader for us. And so then any change we make to our shield shader, which I'm going to bring down here now, we can see actively in our script. So what we can do is, for instance, choose UV and drag this into our base color and then hit save. And you can see now we're rendering the information from our shader. So the way that the UV works is UV is essentially just a mapping of pixels to position on the screen. So it's just a 2-point thing of 0 to 1, right? So we have 0 and then 1 and 0 and 1. And that's a good way to sort of mess around with data. So if I actually split this up by its axis, so we just go split. So then the red axis is essentially the X position like this, you can see. And so that creates a gradient along the X axis because 0 to 1 just creates a nice gradient like that. Or our green, which is the y-axis, which is from 0 to 1. So together you end up with this. So there are a lot of operations that exist in here, and there's lots of different things you can do. And there's lots of different types of shaders you can have. So I'm not going to go too much into detail. Like I said, I think the whole point of this is just to kind of skim the surface a little bit, but it's really fun to play around in here. So feel free to play around and explore. I have a few tutorials on the channel that are exploring making shaders, but I'm also going to continue to do this as we move forward. So let me know if you would be interested in a full-on sort of shader breakdown tutorial and trying lots of different types of shaders. But let's just start for now by making a little circle. So Unity actually already has an ellipse shape that it creates. So this is just a shorthand node for us. And that's kind of where we want to start here because we want a sort of shield effect. So when we feed that into our base color, notice how it literally just draws the base color. But we would like this to be transparent if it's black. So we'll feed this into our alpha channel here. And then we are just left with the white bit. So that gives us our shape. What we can then do is set the width and the height to 1, so it stretches to the full size of our sprite. What I'd really like to do is give us a kind of a wipe, a sort of gradient wipe across this so that we can kind of give the shield a sort of like sheen to it. So let's split our UV into its X and Y. And then what we can do is let's multiply the ellipse that we have here with our X component. And you see how now that creates a gradient. So then we'll feed that into our base color instead. So what we really want to do then is basically have this value move across the shield there over time. So thankfully, there's a good way to do this. We can use the time node, but if I were to just kind of add that to our value, we kind of just end up with white because time is kind of infinite. We start at 0 and it just keeps counting up. So we really need that value to keep going but reset itself. So what we can do is we can use the modulo node and feed time into that. And then as you see, we then get this transition from 0 to 1. What we can then do is use add on that. And as you see, we then go from our fade and we're sort of starting to move, but we start at a pretty high rate. So what we really want to do is start smaller and then go across. And to do that, we can remap the value of 0 to 1 to -1, 1, and that gives us a broader depth to work with. So what we can do there is we can then add a remap node and we can feed the result of our modulo node into our remap node. So the real cool thing about this is we are just sort of building up steps in the process and adding things in, moving things around. And it's very, very procedural and non-destructive. And I think that's one of the coolest things about Shader Graph and using node-based editors in general. So now if we feed that in here and we set our X value to 0 to 1 and then -1 to 1, and we hit save here, you see how we now get this looping? So this is pretty good, but it would be nice if it was kind of one smooth transition, right? So to do that, what we can actually do is essentially flip this result and then kind of add them together. So what we'll do is we will take this result and then we'll add a 1 minus. Because keep in mind, these are all just numbers. I know it looks like colors, but the result here are just numbers. So black is 0 and white is 1. So if you do 1 minus whatever the current value is, you end up with the inverse of that. So these two are now inverted, right? So what we can then do is multiply those two values together, and black will always dominate. Therefore, we end up with this nice smooth gradient that sort of linearly moves across over time, like this, you see? And so then the only big issue here is that it looks kind of off because technically we're going above 1 with our add here. And so what we can do is on our add, we just create a clamp node. Then all we have to do at the end of our graph here is clamp the value between 0 and 1 and then feed that in. And we then get a nice smooth effect. And that's kind of the basis really of our effect. We could then choose to multiply this with a color if we wanted to. Feed that into our base color here. And let's maybe make this, bright blue or something. Yeah, maybe green. So this is pretty good. Let's just brighten that up a little bit. So we'll add another multiply node in here, and then we'll pop that into there. Let's just set this to about 5, and that should sort of bring the contrast up a little bit. Let's add a sort of edge to our shield here so it feels a bit more constant. So to do that, we can actually manipulate our UV to create a sort of circular gradient. So what we'll do is we'll grab our UV and then we will add a subtract node, and we will subtract 0.5 from our center. We'll then add a split node and we'll create a vector with just our red and green. And then we'll feed this into a dot product node and we'll feed this in twice. That creates our little circle gradient we now have. And then what we can also do is feed this into a remap node. That will allow us to sort of change the contrast of it a little bit. So we can change this to 0 to 1. And as you see there, we can sort of bring this in and out. So that'll be useful a little bit later because we can sort of change the thickness of the edge there. So if I just feed this straight into our output, you can see that, even with our gradient changing the alpha, this is another little effect that we could potentially have. I think that looks kind of cool. But if we just show that as our alpha there, that's kind of the result. So what we want to do is multiply that by our edge. So we'll grab our ellipse down here and we'll add a multiply node up here and then combine this with our remap. Combine these two together. And that then creates our actual edge there, you see? Like that, so we now have our orb. So then, if we multiply these two together, we get a fully sort of sweeping effect, although it's a little bit dark. You know, the cool thing about shaders is there's just a ton of different things you can do, and you can really just play around to go with what you think looks the best. I'm not a big fan of the multiply here, so let's change this to an add instead. So then we'll put a clamp node in here and put that in our multiply, like so. And if we save that, we then get a shield effect, like so. We can mess around with our in and out values here. And just like in the effects graph, what we can do is we can add, for instance, a vector2, and we'll call this remap value. I think that's fine. Set the default value to 0 and 1. And then what we can do is if we put that there, when we hit save, this should show up now in our material itself. And what we can then do is we can manually go in here and change the values to get the visuals that we want. Now, I think that looks very cool. So that's kind of the power of shaders. Is, well, you know, theoretically, you could have a sprite that kind of does something similar. Being able to use shaders means that you can manipulate effects here to get just the, you know, anything you really want. There's tons of stuff we could be using different colors. So even just changing this value impacts how this effect looks, and the order of our nodes change the outcome of our shader. So there's a lot of variation you can make, and you can really play around and fine tune the look of the effect that you want. And so our color here is probably something that we should also expose. So we can right click here and choose convert to property, and that will then expose our color as a property on our material. And we can then change the color as we want. Now, with a material, that exposes it in our shader, but actually, because we're actually a sprite, the sprite already has a color property on it, and we can actually make use of that in our shader. So if we delete this and we change to the vertex color and then move this into our node here, we can hit save. And as you can see, it then changes to this white color, and we can make that darker, and we can bring this to any color we want. And you can see we can now just use the color property on our renderer itself, which for a shader like this, I think is great. So let's use that. But yeah, I'm pretty happy with this as a sort of shield effect. So all we really need to do is get this to show up now when we are in our respawn phase. I'm also going to just make it like a tiny bit bigger, I think. I'm going to click this and choose Alt and Shift. That's great. Okay. So let's rename this to shield. And then let's select our ship and head into our ship controller again here. And let's get a reference to our shield. Let's just put this, let's put this up here like this. And then we'll assign that object in the inspector here. Okay, so basically at the point we're respawning, we want to turn our shield on. So we'll set that as active. And then when we're finished and our time delay has occurred, we will set our spawn, we'll turn the shield off, excuse me. So I think it's going to be better if we remove this feature of the collider not being enabled until after our sort of invulnerability period. So I'm actually just going to put this up here. And I think I'm also going to move the simulation of the rigid body being turned back on again after we've moved, because I think we can just increase this length slightly and kind of reset all these variables and give ourselves maybe 3 seconds of invulnerability. But what I want to do is add a new variable called private bool m underscore is invulnerable. And then down here, we set invulnerability to true, wait 3 seconds, and then set it to false. And what we can then do is when we are hit in our collision method, which is over here, we can check if we're invulnerable, and if we are, do nothing and just return the method. That way we should have actually some physics happen, because in case we get hit while we're invulnerable, we still want some physics interactions there. We don't want the things to go through us, which currently they are. So that's a small tweak is worth making. And we make sure our shield is disabled, and then hopefully now when we die, I'm going to boost into this rock and get it to spin me a million miles away. Boosh. We should spawn. We can then fly around, but we're invulnerable up to a moment there. So I think that's pretty good. Our shield turns on and then it turns off when we're no longer invulnerable. And yeah, I think that's pretty great. You could play around with how long you want to keep that invulnerability for. I think that's a nice touch. Potentially, you could have another collectible that turns this shield back on. You could have a UI element to show you when that's enabled or not. There's lots of different things we could do there. I think the last little bit we need to do is give a little bit of feedback to the player when they hit something to show that they've lost some health. And I think to do that, we could just have a little screen effect that occurs when that happens. So let's do another shader that works on the entire screen and changes how the screen looks when they get hit. So to do this, we have to kind of hook into the rendering system in order to do a full screen display. So what we can do is we can head over here into our assets, and we need to just go into settings and select our renderer 2D. This is essentially the setup of how Unity is going to draw our game. And if we go here and close everything up, what we have at the bottom here is a thing called renderer features, and we can basically add a full screen shader through this system. So we'll go add renderer feature and we'll do full screen pass renderer feature. And then you can see it already creates a sort of default material. So we'll click here to create a new full screen material and we'll create a shader graph full screen. We'll just call this full screen shader for now. And we'll make a material and let's put the full screen shader into our shaders folder as well as that material. And then we'll go back onto our settings file there, and it should have been set, which is great. So then what we can do is if I just type UV here, delete these nodes, and we'll just feed that into our base color. And as you can see, that then feeds the screen space UVs, which are a slightly different color, but you know, like that. So there's a ton of things we can do, but I think we're going to keep this nice and simple and essentially just create a sort of chromatic aberration effect so that each channel, the red, green, and blue channel, sort of dissipate when you hit something, and then they'll kind of go back together. So it's pretty straightforward. What we'll do is we'll get the URP sample buffer, and if we pass the blit source, which is blit is just a way to kind of say copy. It's just kind of a copy of something. When you see the term blit, it just means it's a copy. So it's an image copy of our current thing on screen, which is this, and ultimately, what we basically just want to do is offset each of our UV positions depending on our color. So we're going to create 3 copies of this, and then we are going to grab each color. So we'll create a split node, and we'll feed that into there, and we'll feed this one into this one, and then we'll feed this one into this one, and then we'll create a vector 3 node. And we'll put the red into this one over here, the green into this one over here, and the blue into this one over here. And then we'll feed that in like that. And nothing will have changed. What we'll then do is create an offset, tiling an offset node. And if I feed this into the red and I hit save, and then I maybe change this value, you'll see that that's now kind of changed the colors of things because we've offset the red channel. So in its current form, that won't really do much. If I change this to a lower number, you can see how much that changes the red channel. So what we want to do is create a new vector 2 and feed that into our offset. And we'll convert this to a property, and this will be called the red offset. And actually, we'll make sure we'll divide this by 100 and feed this in, just so that our precision on the material here is not going to be insane. So we'll hit save. That has now made this show up. And as you can see, we can change the value, and that will allow us in our material here to set our offset. So we kind of just want to repeat this for the green and the blue channel. So let's just kind of copy these guys and paste them in here and feed these in. And then we'll duplicate this. And we'll call this green offset and feed that into there. And then duplicate this, and we'll call this blue offset. And feed that into there like that. So now if we mess around with our values here, you can see that we can offset the colors on our full screen based off of these values. So we are affecting the entire image just before the end of the rendering. And yeah, you can see kind of how flexible this could be. So what we'll do is we'll just pick something that kind of seems to make sense. So I'll make the first one to kind of be -1, and then we'll kind of make this, let's go 1, and then we'll make the blue offset 1 like that. There we go. It's kind of like, okay. So what I really want to do is have a slider from 0 to 1 to kind of make this spread out. So we can use a technique called linear interpolation for that, which I think we've used in code already. But essentially we can create a lerp node, and you can set two values, A and B, and then T is how much you move between A or B as the output. So what we can do is we can feed the result of this divide here. We can feed this in as our B point, and our A point can just be 0. And that can be our offset. And then what we'll do is we'll create a new property here as a float, set this to amount, and then in the inspector here, in our Blackboard inspector, we'll change mode to slider and then hit save, and that should show up, and we should now be able to change that in the inspector there. So let's just make this smaller again, and then we'll drag the amount here and feed that into there, and then we'll just do this for the other two as well. Feed this one into B and set that as the offset and plug in the amount there, and then the same for our blue. We'll get our amount value and our lerp, and then we'll plug that into our B value here and our T value there, and then plug that into there and hit save. And now if we move this slider, you see how we gradually offset from 0 to 1 to whatever our maximum is. So we could make this more aggressive if we wanted. And then the impact level, so as we lose some health, the more health we lose, we could make it even more aggressive. But I think for now, we'll just keep these values at 1. And so then all we have to do is animate this amount value in our material. We now just have to implement this. What we really want to do then is essentially just assign that material into our ship controller to then manipulate it. So we want to do two things. We want to have a reference to the material, and then we want to kind of trigger an animation state. Okay, so with our other references, let's make a reference to our material, and we'll call this M full screen effect matte. And then in our inspector over here, we can grab that full screen material. So we'll create a coroutine similar to our respawn, and we'll call private I enumerator. Let's just call it hit routine. And then in our lose health, we will start the hit routine. So then in here, we will just call our full screen effect matte, and then we'll go set float. And this is just, and so then we just have to go find the material name of that effect. And so if we go into our shader, there we go. We can see it's underscore amount. Usually it's underscore and then whatever you've written, but you can double check here in the reference. So it's just underscore amount. So then we'll go underscore amount, and we'll set that to 1, and then wait for a second, and we'll set this back to 0. And so hopefully now when we hit something, we'll get that full screen effect. It's going to stay on for way too long. 1 second is way too long for it to be active. It should be a very subtle effect, but hopefully we'll get to see it in action. There you go. So now all we have to do is get it to transition, because that kind of looks pretty crap. So what we want to do is create an amount reference, and we'll make this 0 while amount is less than 1. We'll then return for, I'm going to do 0.35f over 100, because I want the entire thing to be about, actually I want it to be about a 15th of a second. And then what we'll do is we'll do amount plus equals 0.1f. Yeah, we'll do it divided by 10, actually. No, 100. And we'll do 0.01f. And so then we'll set the float to the amount. And then we'll kind of do the same thing, but in reverse. So we go while amount is greater than 0f, we kind of go the other way. And that should now very quickly impact and change how our screen looks. There you go. It's still kind of too slow, to be honest. Because it's linear, that's kind of a problem. So we can actually take advantage of an animation state in order to kind of perpetuate what we're doing here. So what we're going to do is we are going to add an animation curve. And that way we can kind of create our own easing curve where you get a sort of smooth in or out depending on what kind of ease you have. So linear is pretty boring, but in and out, you then get control over the time. So we're going to use an animation curve essentially to manipulate that. What we can do is we can add a property here called serialized field private animation curve. We'll go full screen ease and then select our ship and click the full screen ease. And then we'll keep it pretty simple, just between 0 and 1. I think that is probably what we want. We could probably do an ease in, ease out situation so that whichever direction we're going, it makes sense. And then what we do is we head into our thing here and we actually just sample that. So we want to go underscore full screen ease, evaluate, and then pass in our amount, which is basically our t value. This may as well be our time value. And then we'll pass those in. And now it should have a kind of ease to it. So it just feels a little punchier. And really, what we could also do is we could actually just expose this time. So we could go up into here and we could set the ease time or effect time or whatever you want to call it, and then put that in this spot instead. And then I'll set the ease time to 0.1. And there we go. I think now that's a great amount of feedback. When we hit into something, we get the feedback that we've damaged our ship a little bit. It's almost like the ship controller is getting all freaked out. So, you know, you could really mess around with that and toy with how you want it to look. You could maybe overlay some things on top, use some of the stuff we learned previously to build the shield. You could do those kind of things, maybe have some red edges or something. But I'm pretty happy with that. I think overall that's a great sort of starting point for a game. So you see how all of these components combine to make a really interesting experience that kind of before we added the effects and the screen and everything, it kind of just, it was okay, but it really didn't feel like much of a game. Whereas once you get the sparks and the dust and the screen effect and the boost effect, it then really starts to come together and turn into a game. The only thing we're missing now is sound. So one of the biggest things to create a level of impact to the player for your game is to add sounds and music. And so this is kind of a crucial point in really bringing your game to life and making it feel good, because good sounds can really elevate a game, and you'd be surprised how many people don't pay a ton of attention to sounds and music. So it's something that we really should pay attention to, and so I'm going to show you how to get that implemented into your game. Obviously, sounds are something that are tricky to come across. It's not something you can kind of create very easily on your own. So quite often, the best thing to do is to use a sound library or a sound asset pack or something similar to that effect. I've included a ton of sounds in the existing set of assets, so we're going to use those. And I've also included some music too. A lot of these I've just grabbed from Freesound. A lot of these people upload these sounds and you can do whatever you want with them. So as long as the license allows you to do that, you can just head over here and grab as many sounds as you like. So feel free to do that if you want. I've included some from here already. Another great place to get them is to go to the asset store, which if you don't know is a place where you can sort of buy 3D models and graphics and visual effects tools, all these kind of things. There's tons and tons of stuff here on the asset store. So if you want to play around with some different assets or sprites, feel free to check this out. You click on audio here, it will take you to a ton of different sound effect packs, tools, libraries. You can get effects for UI and bundles of different music pieces and sounds and weather, ambience, that kind of thing. So highly suggest checking this out if you want to be able to gather different assets. Sound assets are one of the most useful ones to pick up. So anytime you find these on a deal, I highly recommend picking them up because there'll be one sound in there that's really perfect for what you need. So gather these up whenever you get the opportunity. So I'll have a link below actually, which is an affiliate link. So feel free to click that and you can check out some of the asset and sound packs that I've already picked up. I definitely have a few myself, so I'll recommend some down below if you're interested in that. Have a look around. There's tons of great packs available for you to check out. But yeah, I didn't want to leave you empty-handed here. So I've actually included a set that I've grabbed just straight off of Freesound, which we can use and we're going to use for the next section here. So let's dive in to adding sounds to the game here. Okay, so first things first then, I think the best thing to do is to start with some music. Now, I've grabbed 4 pretty decent music tracks just straight off of Freesound, as you can hear here. You know, I think they pretty much work well as a background track that we can have going on while we're sort of shooting things. So I think we can use any of these really. So in our managers, let's create an empty game object. We'll call this music manager. And then in here, we are going to add an audio source. And we are going to select one of our music tracks. Let's go with music 2. It's nice and kind of calming. And then as you can see here, we have our output, which is our audio mixer group. There's kind of an audio mixer built into Unity. It's fine. We can get to it by going to Window, Audio, and Audio Mixer. Generally, the way that we're going to be doing this is fine for simple sounds. But if you ever want to do anything more complex in Unity, I highly, highly recommend checking out Fmod, especially for indies up until a certain amount of revenue. It's free to use and it just allows for a lot more complex behaviors, and we can sort of stack sounds together and have code driven sound effects, but it's massively out of scope for this video. But yeah, the majority of times you want to use middleware software for audio just because there's a ton of extra functionality. Unity's audio system really hasn't had any improvement in years, maybe even a decade. So I'll teach you the basics of it, but probably once you sort of already graduate from this and move into something like Wise or Fmod. All right, so we'll start with an audio mixer. To do this, we just want to create a mixer group. So we'll call this master. That'll be fine. And that can be our master group. And then we will add a new group and we'll call this music. And then we'll add another one for our sounds. We do not want this to be inside music. We want this to be inside our master group. And so that way we can kind of control the volume level generally of all of our music and sounds together. So we always want our music to be slightly quieter. So we'll set this to just default at like -20 or something. And then in our music manager here, we'll go and our audio mixer group, and we will assign this to the music. And then play on awake is fine. Basically now, if we hit play, we should start to hear some music. You also just want to make sure that if you don't hear any music and you see these bars moving, it's probably because you have disabled this, or if we uncheck that, we should now hear music. I'm actually going to turn this up because it's a little quiet. Let's bring this up to maybe about -10. Okay, now that's too loud. Okay, so we'll bring that down to -15. So there we go. We have some music playing in our scene now, which is pretty great. We just make sure to check this loop so it loops around. And yeah, I'm pretty happy with that. So next, all we need to do is add our sounds. So I think we've got a selection of sounds in here. So if I head into our sound section, we've got some sounds for our rocks breaking. And we've got a few lasers and shots here. So what we're going to do is we're going to create a script that we can place on our objects that we can then call to fire and play sounds from. So just as a quick aside before I jump into that, if you're still struggling to hear anything, there's an audio listener on the camera. You need to make sure that that's enabled because that's where the audio is going to be coming from. So in this instance, our camera kind of is global, but it allows us to sort of have spatial audio if we need that. So if we were moving around, we could have audio sources. And there's a ton of different options that we could be setting in our audio settings. Again, for our music, we can actually set this mostly in the spatial blend. It's set to 2D, you see, but if we set it to 3D, it would then be spatially related, and we can change a bunch of the settings here. But again, for music, we don't really need to do that. What we're going to do then is we're going to create an empty object on our ship. And we are going to call this sound effects _ shot. And this is going to be our sound effect component for our gunshots. So we're going to add another audio source here, and we're going to make this our shoot 01 element. And we're going to output that to our sounds channel. Now, the audio we choose doesn't actually matter too much because we're going to make a script to randomize these. And the reason we want to do that is because if we just go here and if we were to fire and we just kept playing the same sound again and again, you hear how repetitive that gets? It's just like infuriatingly repetitive. But what we can do is we can actually randomize between all three of these sounds and change their pitch. And that will sort of create a variation every time. So there'll be a slight different sound. And it's the way that essentially games allow you to reuse the same sounds without them sounding identical every time. We just vary the pitch. So we need a script that can kind of do that randomization for us. So what we want to do is we want to create a new script in here. We'll create a new mono behavior script and we will call this sound effect handler. And we'll place that on our shot component here. And then we'll open this up. We'll create a list of audio generators and we'll call these generators. And then we will create a vector that will be min max pitch. We'll just make sure to serialize these so they show up. And we will create a reference to our audio source. And when we awake, fetch our audio source from ourselves. And then what we can do is we can make a public play, and then we can select an audio generator by fetching the index of random.range 0 and then mgenerators.length. And that will then return us an index relative to how big our list is, and that will return an object to play, and then we'll set that as our generator on our audio source. And what we'll also do is set the pitch to random.range, our min-max pitch.x, and our min-max pitch.y. And that will then be our range. And then we'll call audio source.play. And that should then call our sound effect. So on our ship controller, all we have to do is reference the sound effect handler. So we'll make a reference to that up here. And we'll call this fire sound effect. And then in our try spawn bullet method, when we instantiate a bullet, we will just call play on our fire sound effects. So then in our inspector, we can just grab our special effects shot reference and pop that into the fire sound effects there. And then just make sure that this doesn't play on awake and it doesn't loop. And set our min-max pitch can be something from 0. Usually I find anything from 0.9 to 1.1 as a min-max is perfect. It looks like our list doesn't do this. So let's change this to audio clip. Looks like you can't do it that way. So we'll change these to audio clips. Unity have changed this because they have some other variations of ways you can get sounds. So yeah, there we go, that works. Okay, and then what we'll do is we will assign our gunshot clips. So let's go our sounds and we'll go shoot 1, shoot 2, and shoot 3. And then we will save. And so now when we fire our weapon, we should hear a gunshot sound. So one of the things we probably can do is actually create 2 audio sources to work from so that we're constantly just swapping between them because this sound kind of stacks. So it's probably best that we have 2 sources because we can only kind of use one at a time. So I'm pretty sure we can just add another one in here. And then these can be our 2 audio sources. And we'll set this to the same one, turn off play on awake. And then what we'll actually do is go here and add a reference to both of our audio sources. We could make this a list. It's probably easier to make this a list instead of an array. So we'll do that and we'll remove our fetch there. And then essentially we will assign an audio source. And if source is playing, then we will assign the other one. It's not a perfect solution, but that stops the kind of interruption that you just heard. And that should just be a little bit cleaner and allow for sort of 2 of the sounds to play on top of each other and stack a little bit easier. So then in our script, we just have to serialize this field as well. And then in Unity, we should now be able to assign both of these audio sources. So there we go. Now that we have the 2 stacking on top of each other, they're a little bit easier to here, and you can have multiple playing without the sort of clipping that we were hearing before, and they're not sort of interrupting each other. They can sort of ring out. So you could stack a lot of these on top of each other if you really wanted to be able to play more than 2 audio sources. But for this instance, I think just 2 stacked is enough, because the timing dictates that really there's only going to be one sound layered over the top of the other one. But yeah, that's pretty much how we get sounds to play. So we kind of just have to do the same thing now across a bunch of our different components. So we may as well just duplicate this asset here, and we'll call this SFX die, and we can create another one called SFX hit. And in this instance, we're really only going to get sort of hit once or twice, but we may as well keep the audio sources like this just in case they lie over the top of each other, but we can change our generators. So for our die, we really are just going to have a singular death sound, and that's going to be this one. And then for our hit sound, which is when we get hit by something, I think that is pretty good. So we'll pop that in there, and we'll shrink this down. And then we don't really want to do a ton of variation on this one. So we'll go 101. And for our die, we'll kind of do the same thing. We'll go 0.95 and maybe 1.05. So a little bit of variation maybe, but not too much. And then we just kind of have to set those up in our ship. So create another reference to these. So one of the cool things you can do is type an attribute called header, and we can call these sound effects. And we could bring this other header down here, and we could call this other references. And then as you see in the inspector, what that does is it breaks these up and gives you these little headings here. So that can be a useful way to just quickly sort your inspector out. You know, we could add another header for all the different things, but I think this will be fine. Just keep it in our sounds area now. So let's make 3. So we'll call this m_death sound effects and m_hit sound effects. And then we'll assign those to die and to hit, like that. And then in our ship controller, we just have to play them. So when we die, we will call death sound effects dot play. And when we're hit, we can call our hit sound effects, and we'll play that one. So if I hit into this, there you go. Yeah, so instead of that zap sound, I think we're going to go with this hit sound here. I think that's actually just sort of lands better. So a lot of this is sometimes just playing it and seeing what it sounds like, and then deciding that you want to do something different or try and tweak the sound a little bit. And I think just generally when this hits into something, it sounds a lot nicer. I think that just sounds a lot better. It sort of just matches the screen effect a little bit more. Okay, so we'll also add these new thruster sounds. And a boost one as well. So that can be our thrust. And we can add our boost. And what we will actually just remove this first audio source here. And then we will put our thrusters in there. And we'll just stick to the 1. We will actually keep this on pitch. And actually, let's just duplicate this for our booster as well. And then what we can do is in our script, we'll make a reference in our ship to our thruster effects and our booster effects. And these will loop because these are looping sounds. So what we want to do is go into our audio source and we'll set these to loop. And then in our sound effect handler, we can make a new fade in and a new method called fade out. So essentially, our thrusters really just need to kind of turn on and turn off whenever we press the button. And so they can kind of just be a sound that's constantly playing in the background. So we can expand our script here to actually support the play on awake function, but we'll handle that from this script. So what we'll do is we'll make an awake method, and we'll make a Boolean called private bool m_play on awake. And then we'll do that. And then if play on awake is called, we will just type play. And so this should all then be fine and pitch. And what we just want to do is make sure that when we're fading that we only grab our first audio source. So we'll do that like so. And we'll do the same in our fade out because they're basically going to do the same thing. And then what we'll do is we'll create a coroutine called fade audio source. And we'll pass in the source and the volume we want to fade to. So we want to fade this to 1. And so then we'll create one here called private I enumerator fade audio source. And we will accept an audio source here and a value that can be our target. And so what we'll do then is we will find the current volume of the source, and we will interpolate from A to B. So we will do while source dot volume does not equal target yield null or new wait for end of frame, and then we can do source dot volume mathf dot lerp current volume target, and then just time.delta time. And so that will essentially loop between frames. We'll just make sure if that gets squiggly that we have the systems.collections up here. And that now should then fade out audio source. So we can then do the same thing here, but we probably don't want to be able to fade in and fade out at the same time. So we want to cancel the existing coroutines. We do actually want to assign this a value. So we want to create a coroutine reference, and we'll just call this fade routine. And then we'll assign that when we call the method there and do the same thing here. And then we'll stop that routine before we do this. So now it will stop that routine, stop this from executing, and then do this one instead. And so that should now give us a fade function with our sounds. And then if we set this to play on awake for both our thrust and our boosters, and they're both set to loop, then we want to make sure their starting volume is 0. We can then assign those as our references in our ship. And then in our script on our ship controller, we can just call the method in our move. So we'll do thruster_effects dot fade in. And when we're not, we do thruster_effects dot fade out. And we can do the same for our boost. We want to call booster effects dot fade in when we're boosting. And then if we're not boosting, we want to call booster effects dot fade out. And then we want to call if not is boosting and m forward input equals 0, then that. And so that now should give us sounds for both our boost state and our thrust state. But we get a little error that our routine is null because we haven't checked it in here. So we just need to go if m_fade routine does not equal null, then stop the routine. And we'll do the same in our fade in too. We may end up getting some of these errors in the console. As I said before, index was out of range, must be non-negative. So let's take a look at this. This is sound effect handler.play over here. And oh, I can see this. We have set to source.isPlaying. So this is always going to be true because if source isn't playing, it would then just change the other one. We actually want this to be source.isPlaying without the exclamation point there. And for our fade in routine, what we actually want to do here with our fade audio source routine, what I realize is while we're in the loop, we don't reset this current volume. So it's actually just going to be the same value. So we want to move this down to here. So we're constantly readdressing that value. As I said, game dev, you will make many mistakes and sometimes you will do typos or you will make stupid little errors. Being able to debug them is an important process. So that's why I've kept a lot of these parts in where I'm making errors and I'm showing you how to solve these errors. It is an important process and it's not something that you get taught a lot as a beginner. So just keep in mind that if you see errors in the console, they're usually telling you that the line of code is incorrect. 2/3 of the time, it's just a typo or you've assigned an equals incorrectly, or you're not doing a null check beforehand or something like that. And it's so common. For instance, this fade routine, it can't cancel a routine that doesn't exist. So we have to check that it's null first. It's really important to learn about some of these mistakes that you can make because debugging is 50% of programming. Okay, so now we have our booster sound. They get quiet very slowly, but we can hear them, which is great. So let's go in and just tweak the time on those a little bit. We could add a value here called private float m_fade time. And we will then multiply our value by whatever our fade time is. Down here, we can then update our fade time. So we'll set that to about 10, so it's kind of much faster. We want to just make sure that we do the same on our thrusters. And so now we have a sound for both button inputs, sort of subtle, lower thrust sound. And you see the impact that makes? It's just such a big difference. Just that feedback. It's great. And that's most of the sounds in place. Now we just need to add ones to our asteroids and to our little orb collectible too. And I think that's pretty much it. Now, we could add them into our asteroid as before, but the main problem with that is that we actually destroy our asteroid as soon as it's supposed to die. So what we probably want to do is add the sound to the visual effect instead. So in our asteroid death visual effect, let's create an empty sound effects layer, and we'll just add our audio source and our handler, and we will add our audio source in there. Min max pitch can be 0.95 or 1.05, and the audio clip we use for the big one can be this break 01. And then we just want to set play on awake to be true in our sound effect handler then. And so basically that will then play the sound, make sure it doesn't loop, and handle that for us. So if we test this, that should now also have propagated to our other prefabs. And I think that's pretty good. That should then act as our destroy sound. Okay, that sounds pretty good to me. So with this one, because we take the collectible up off the ground, we're going to have to maybe do a different method of playing the sound, because essentially we destroy this object the moment that it is picked up. So I think the best thing to do is have something else that's going to handle the sound and then play the sound when the object is picked up using our event system. And we could technically do this with all of the sounds. We could have a specific sound manager that's paying attention to events and then playing the correct sound based off of those events. That would keep everything tidy and in one place. So it's really up to you how to do this. And so this is just maybe an example of how you might achieve that. So I think in our score manager here, we'll create an empty object and we'll just call this pick up a collectible sound, and then we'll do the same thing as before. We'll add a sound, an audio source, and a sound effect handler. We'll add a couple of these because you might pick a few up in succession. So we will add 2 audio sources, and again, making sure move this up here like this. And again, we'll make sure to turn off play on awake on these guys, and remember to put them in the sound controller. Okay, then we'll close those and assign those as our 2 audio sources in here. And then we'll add our collectible sound, which is going to be this pickup sound here. I think that's pretty good. And I'm actually just going to make that a little bit shorter. I'll just trim that tail off there, so it's nice and short. And there we go. It's a much shorter sound now. And then that will work there. We'll set the max pitch maybe 0.95 to 1.1. Actually, that can be 0.9. And that should be fine. That's all we need on that one. So then in our score manager, sound effect handler, m underscore collectible sound. And what we can actually do is we can modify our add to score method. And so we'll actually add a Boolean in here, and we'll default that to false. And we'll pass that through. And then in our score manager, we'll just need to update that method to include that. So what we can then do is call if play sound collectible sound dot play. So then on our collectible controller, we can call that event and say true to play the sound for picking that up. So it means that when we're scoring by the other means, we're not actually going to play the sound, but when we're scoring by this object, we can. You could also pass an integer to say which kind of sound to play. It could be a bespoke event if you wanted, but this is just kind of using an event that already exists, and I think it makes sense, so we're going to do it that way. And so, the only thing I haven't done is assigned that collectible sound here, so we'll do that there. And now, when we pick up those little orbs, it should play the collectible sound. Be careful not to die. There we go. So that's all of the gameplay sounds. We just need a little bit of UI sound for the feedback over the buttons, and then we've got all the sounds in our game. So I'm actually going to add another group in here, and I'm going to call this UI. I like to have sort of separate sound channels for the UI. And then we're going to add a similar, again, button. We'll just copy our script for our sound. We'll throw that into a child of our HUD object here, and we will call this SFX mouse over. And we'll call this one SFX mouse down. And we will assign the audio source there to our UI, like so. For that, so we'll go into our handler, we'll use UI1, set that as our sound for UI1, and then for mouse down, we'll use UI02. And then we basically just have to go into our UI and get that to play based off of our buttons. What we can actually do is make our own manipulator to handle a lot of this stuff for us. So we're going to make the sound effect handler here, and this can be the mouse over sound. And then our sound effect handler can be the mouse down sound. In fact, let's rename this. I don't like using mouse because technically we could be doing this with our controller. So we'll call this the sort of focus sound, I guess. And we'll call this the submit sound, and then reference those in our UI like so. So those should now be exposed in our hub, in our HUD. So we'll add the, and we'll rename these. I think I like SFX focus and SFX submit. And then what we can do is we're going to create a new script. We're not going to create a mono behavior script. We're just going to go down here and choose scripting and just empty C# script. And we're going to call this UI sound manipulator. And so this is going to extend from the pointer manipulator type. And then we're just going to hit Control period to implement the abstract class. And we'll pass this through here. We'll also make a constructor class, a constructor method called UI sound manipulator. And in here, we actually want to pass through those references. So we want a focus and a submit sound. So we want a sound effect handler, focus sound, and sound effect handler, submit sound. And we'll create local references to these. And another one, submit sound. And then we can set this dot focus sound equals focus sound here. I'm actually just going to redo that. I'm going to rename this M underscore and M underscore, and then we're going to do M underscore focus sound equals focus sound, and M underscore submit sound equals submit sound. Now this isn't going to do anything yet, but if we head into our HUD, what we can now do is add those to our buttons as well. So we can do add manipulator, and then we can just do new UI sound manipulator and add our focus sound. And then do the same for our retry button. So these will now have our sound manipulator. And then in our sound manipulator code, we can handle all the callbacks. So in here, we'll call target, and that's the visual element that this manipulator is on. We'll call register callback, and we'll call pointer capture event. There's pointer enter event. We'll use pointer enter event. That's better. And then in here, we will do m focus sound dot play, and we'll duplicate this. We'll make a pointer down event, and we'll call this on pointer down, and generate method on pointer down, and we'll call our submit sound dot play, and then we'll just copy these and unregister the callback. So that should just automatically handle playing any sound we pass into it based on our event. We could also add a different sort of events and callbacks, but that really is all that manipulators are doing, is they're just sort of shortcuts for different types of events. We're getting an error on our sound effect handler. So we should also make sure that we actually have an additional audio source in here. Is greater than 1. And that should help solve any sort of you have too many things errors. There we go. Okay, this should now work. And then we have it. So there's a slight bug that if you're throttling while you're dying, you can still hear the background sound. So we should make sure that those get turned off when we die. What we can essentially do is listen to the game over event in our sound effect handler and use that to silence our sort of looping effects. So we'll create an onEnable method and an onDisable method, and then we'll listen to our onGameOver event there, like that. And then what we'll do is we'll stop all coroutines on ourselves, and then set for each audio source in m underscore audio source we will set the source.volume to 0. But what we also just want to do is make sure that that only happens if we set the sort of autoplay feature. This is pretty poorly named. We should sort of handle like is looping play on awake or something. We might be able to split those if we want to get more complicated, but they're kind of only doing this for now, so this is fine. We essentially just want to do if not play on awake, then just don't worry about it. And that should now handle the audio for us. So there we go. We no longer have that sort of thruster sound. And if we hit retry and we start again, you can see that the sound comes back. And so we don't just have that looping sound playing if we just happen to be holding the button down. So there we have it. That's pretty much the gist of our game. We've got all the components that I think we need and I think that are important to learn when you're starting out. There's a lot more we could do potentially if we wanted to, but I'm pretty happy with where we're at. We've got all the feedback components now in place. So we've got sound and music, we've got sort of some effects with our shaders and some visual effects. And so it really has come together into its own thing. And yeah, so all that's left to do now is to package it up into a piece of software that we can give to people. So to do that, the one thing you might want to do is make sure that we actually have a sort of front end menu for people to come into so that they don't just immediately end up in the game and lose. So let's just quickly build a main menu for the players to boot up into, and I'll give you a brief understanding of how scenes work in Unity because we'll need to be able to use those in order to do this. So let's get that set up and then we're pretty much done. So one of the things I just want to do before we jump into that is just bind the text and our score to our game over screen here. So this is pretty much the same as what we did with our top bar. So we're going to just actually bind the score manager to our container instead, and then our game over background will be able to use it because then I can go in here and bind these values to our top score and our current score. So then I just have to change the top bar to our container and set that as the data source there, and that should keep everything intact, but then it should allow our end screen to show the score as well. So there we go. We can now show a top score and our current score in the menu here. And so I think that just is a little bit better. It gives you more of a reason to kind of keep playing. And yeah, I think that's pretty good. So let's move on. Essentially, up until this point, we've been working in a singular scene here in Unity. So what we'll actually do is we'll come in here and we'll create a new scene. So we'll go here, scene and new scene, and we'll just call this main menu. And what we'll then do is double click on this. And we don't need to worry too much about the background here, because we're going to ultimately just make this a piece of UI. But what I will do is I will just set the color to black, just so, you know, if there's any weird resolutions, that's just dark. So we'll essentially just create a UI menu to act as a landing screen for our game. So let's create a new UI Toolkit UI document, and we'll just call this main menu. And then we'll go into UI Builder, UI Toolkit UI Builder, and we'll make a new document, which we will save into UI Toolkit, and we'll call this main menu. I think this can stay pretty simple. I'm not going to spend ages on this video just kind of styling this out. At this point, you can feel free to kind of explore and experiment with the layout you want. So I'm just going to quickly sort of put a layout together here. Okay, that's starting to look pretty good. So essentially, I've just got a background container for our background element. I've then added a center container for our middle element. I've added the logo up top here, and then the bottom elements with our buttons and our ship. But what I am going to do is I'm going to make these buttons a little bigger. I think actually I'm just going to cheat and kind of just scale the whole container up. I think that will work. So if we go to the transform component here and we just scale everything up by 2, I think that will kind of just make the buttons bigger. Yeah, and I'm pretty happy with that. I think that's fine as a main menu. And then we'll just change the color of the buttons. So to do that, and without messing up the other ones, we'll add an additional style here called menu button. And I'll assign that to this one too. It behaves the same as the normal button, but we'll add a selector for it. And then we'll basically just change the color of these buttons. So we'll get the background and we'll change the color maybe to a blue and a border color. There we go. I'm happy with that. I think that's pretty good. So yeah, it's pretty simple, just a few elements here and then, you know, some settings to get it to look the way that we want it to. But I think that's good enough for a main menu for now. So let's get transitioning from this menu to the game. And by the way, if you are just getting some weird layout behavior between what you see in your menu screen and what's actually happening in the game view, just go over here and check into your panel settings and just see what the scale mode is set to, because changing between something like constant physical size and constant pixel size and scale with screen size will sort of change how it lays it out. And this is just kind of so it's adaptive depending on which resolutions you're using. And it's a way to manipulate and sort of keep consistent views based on different screen resolutions. I wouldn't worry about it too much. Generally, just stick with constant pixel size or scale with screen size, and set the screen size to whatever your reference resolution you want to be. For me, it's 1920 by 1080. Okay, so in our project then, let's go into our script and create a new script called main menu. Let's drag this onto our main menu here. And much like our HUD, we'll just get a reference to our UI document on enable there. So we have our play button and our quit button. We just want to grab those. So let's get a reference to those. So we'll go play button equals root.q visual element play button, and our quit button equals root.q visual element quit button. And then our quit button is nice and simple. It can just close. So we can basically copy the behavior as the quit option in our HUD here. Let's just grab this on quit event. And we can kind of just assign the same logic here. So we can just create a clickable for the quit, and we can assign our quit button to that clickable. And then we'll make a clickable for play. And we'll call this on play. And we'll turn this into an event, into a method. And so then that will actually be the method where we'll handle our transition into our gameplay scene. And then, so in order to transition from our main menu scene to our gameplay scene, we have to actually tell Unity that these two scenes are scenes that we want to include in our game in order to be able to transition between them. And that's because sometimes we might have scenes in Unity that are just for editor testing, or things we want to test in the editor, like a little gallery or a prototyping or sandboxing scene. And we don't really want to include that in a shipped build. And so Unity will only really ever be able to reference and change between scenes that you tell it to keep in mind when building the game. So in order to do that, we need to go into our build settings. So go to build profiles, and we'll come back to this window in a little bit. But what we want to do is open the scene list and choose, and if we've got our scenes here, we'll drag in our main menu scene, but we want to put it above the game scene, because Unity will load straight into whatever your first scene is in the list here. And so we don't want to load straight into our game scene. We want to load into our main menu scene when we build the game, and then that should be good. We should be able to now load in. Okay, so in order to load that scene, all we have to do then is call scene manager dot load scene, and then type in the build index for that scene. So our main menu is build index 0, and our gameplay scene is build index 1, so we'll do 1. Unity referencing scenes by an index like this is kind of dangerous, because if you change the build index, it can really mess with things, especially if you're like directly referencing them by integer. So what I would generally recommend if you have a few scenes is to use an enum instead to reference the scenes, and then all you have to do is change that value in your enum. So what we could do is something like enum scene names, and do something like main menu equals 0, and then gameplay equals 1. And then instead of that, we then do this, and we go cast this to an integer and do scene names dot main menu. Because if we moved our main menu scene, but we had a reference to this elsewhere in the game, we'd only then have to change the index in this one place rather than everywhere. So I would recommend doing that if you have a bunch of scenes, but it's kind of out of scope for this video. I just wanted to show you that because this is an easy thing to get caught up on and sort of can really mess with you. So just keep that in mind. But for now, this is fine. We can just load our game scenes. So hopefully, if we click play, it should then load us into our scene. As a final step, then we can basically just copy some of our sound stuff over from the other main menu. So I've brought in these submit and focus sounds and made a reference to them in our main menu script, similar to what we did before in our HUD. We can just add our new UI sound manipulator clickable. And then I have a little music player here, which we can just set to loop and play on awake. And then we just assign our submit and our focus sounds like so. And now our main menu will have some sound. And just like that, we're in our game. So congratulations, your game is done. You have a full game that you have created from scratch, basically in just a few hours. Well done. So we're in Unity now. Our game is playable in Unity, but we can't actually get people to play this game in Unity. I mean, technically they could download it and you could send them the project, I suppose, but that's not a great way to get people to play it. The game isn't truly finished until it's exported out of Unity and playable on your desktop. So as the final step of this video, we're going to do that. Okay, so in order to export a game, it's pretty basic. You just head up here into File, you choose Build Profiles, should have Windows selected. If you want to make a web version to put onto itch, you could download the web module, which you install in Unity Hub, but we'll just stick with a Windows module for now. Before we do that, we're just going to head up here and choose Player Settings, because we need to add some information about our game to the player so that it doesn't just show up as default company. So we'll name this your company. So whatever you want to call your studio name. I'm just going to call it Game Dev Guide. And then we're going to call it, I'm going to call this Asteroid Blast version 1. And we'll make an icon, which can just be our player ship here. And that can be the icon for our game. You can add a splash image if you want. But yeah, once that's done, then just hit build and make a folder to build the game in. So we'll call this builds and hit select folder and then just wait. Sometimes in this phase, you end up with some error messages about it failing to export. Sometimes that's because you've maybe mistyped something and you're trying to include something in a build that's only exclusive in the editor. So just keep an eye out for those in your scripts. But hopefully you've done everything right and this will export. And so once that's done, you should get your folder pop up like this with your game and your executable file. All you have to do is double click it and your game should open. And there we have it. Our game is now in full screen. And look at that. We have our game that we just made. We can fly around and do everything we need to do. So one of the things you find out when you make a build is that some of your code sometimes isn't doing what you expect it to do and behaves slightly differently, which is always fun. So in this instance, the full screen effect ended up being crazy slow. So what I did is I went in here and changed our hit routine and removed the weird calculations we were doing and instead decided to yield for the end of the frame and add to the t value an ease time value multiplied by our delta time. So again, this is the sort of time stepping thing where we're doing things by frames. The previous method was not really taking the frame time into account. And so then all I did there was set the value on my ship for the ease time to about 10, and that solved the problem. But yeah, now we have a full screen version of our game. We can click play here and we can fly around in full HD and shoot things out in front of us and ahead of us. And we hit things, and let's see if we can destroy one of these ships here. I'm going about the same speed as it, so I should be able to destroy it. Hooray. Okay. Oh, and I died. And yeah, we can just play our game. Ooh, come on. Okay, there we go. Gonna go around here. Shoot this. Oh, we got an orb. I just got hit. Oh no. There we go. And we've got our scores in here. And we can retry if we want. And the game resets. Well, that's a pretty decent score. So yeah, that's pretty much it. And that brings us to the end of the tutorial. Congratulations, you've just made your first game in Unity. That's awesome. Now this is obviously just the beginning. We've really only scratched the surface, but hopefully over the course of this video, you've picked up enough of the fundamentals to start experimenting on your own and begin turning some of those ideas you've been sitting on into real projects. There's still a lot more we could do with this Asteroids game, so if you're not sure where to go next, here are a few directions you could take it. As a simple starting point, you could add different types of collectibles with varying score values and drop chances. Maybe rarer pickups are worth more or trigger temporary bonuses. You could introduce hazards, perhaps enemies that track the player position or something that fires projectiles from off screen. Even a basic enemy ship that shoots from a distance would change the feel of the game quite a bit. If you want to push yourself even further, try building multiple levels in separate scenes, each with its own score objective. You could ramp up the asteroid spawner over time and introduce new mechanics as the player progresses. Or you could take it in a totally different direction and turn it into more of a roguelike, where each run earns currency that can be spent on permanent upgrades. Faster movement, stronger bullets, higher value pickups. Suddenly you've got progression layered on top of the core loop. You could even experiment with local multiplayer and see who can survive the longest. The point is, this project is a foundation, which what you build on is entirely up to you. I'd genuinely love to hear what you end up doing with it, so leave a comment and let me know how you got on. Additionally, if you're looking for more focused guidance or you'd like to say thanks and support support more videos like this, then please consider becoming a patron using the link down below. Also, feel free to jump into the Game Dev Guide Discord. There are loads of friendly developers at all different stages who are happy to answer questions and share what they're working on. There are, of course, plenty of other great Unity tutorials on YouTube, and naturally, I've got a few of my own that you might be interested in, so consider checking out one of the videos being suggested on screen now, as I think you'll find them especially useful if you're looking to continue your game dev journey. Thanks so much for watching, and good luck with whatever you build next.